slip that late.
Yeah. Well, I'm recording it separately, so.
Right, yeah. It's not a problem.
Testing 1, 2, Trey.
Well, I'm not using the sound from the house, so might have to figure it out. Okay, it's streaming now. I will pass you the URL.
Live stream?
Yep. I just pasted the.
Yeah, no problem. So live streaming to other room and also the internet.
The webs, yes. They have tubes.
So the other room is just showing the web.
Show whatever. Whatever is here.
What's the YouTube live like?
Probably.
How many seconds?
2, 3.
That's it? Wow.
No, I think it's more than that. I think 3 seconds if you manage to pull the manage to pull the input. But if you're pulling the HLS, which you normally do, it's about 20 30. Half of it off. Yeah, it's not terrible.
I mean, it's really bad for if you're in the same room, but if it's a separate room, that's perfectly fine.
I had to sneak in and push it in the can.
This is 200.
It's supposed to be 200 seats.
Is it?
Once all the seats are deployed, there are more chairs outside. We can get them back as well. So, as I described it earlier, this is business class for the speakers. That is premium economy. And that's economy all the way at the back. You'll have to drag your own seat, unfortunately.
Step right up, step right up.
You said the seats outside. Should we bring them in?
It's that's we should probably ask Terrence where they are.
QR code.
Don't shake it.
You shake it.
No, I didn't.
So are you here because PayPal is sponsoring this event? What are you doing? Is it the same event you're promoting?
In my notes coming you die. Remember that
I mean the same like dev outreach. Cause.
Let's go behind. No.
Who runs in green? I don't know what. No, I'm a participant.
Oh, cool.
I came, arrived here a bit too early because I thought it started at 9:30, but may not.
It does, but yeah. I mean, if this.
I'll upset and check on the live stream. It says.
Too early today.
Hi.
Hi.
Okay.
Hey, Candy. Hi.
So you're looking for the organizer.
You can do your planet. Oh, neighbor. But the thing is that you have
Check 1, 2.
Yes, I installed that. So you configure your USB file, right?
Oh, that's just yeah, I changed it to desert.
I don't know, sure, I also wish it was
Yeah, I hate that.
I stopped text right also.
Yeah, I know, really. Yeah, because I want to see something and then there was no private stuff.
Different desktop.
You didn't feel something.
Oh,
That's way too much. He's still on the way. Hey, hi, Emma. How are you? Hi.
You speaking good?
No.
Someone is work with Grab taxi.
Oh, you
This is
would grab.
Stephanie. She's
Hey,
working
hi.
with Singapore Power.
Nice to meet you.
Same here.
In discussion with some things, always prepare pictures and stuff. I suspect so. Yeah, but even then, it's people have been doing this for a while. Don't always has prepared stuff or you don't put effort. You think it's a show in or something. Just be arrogant, complacent. Kind of nice. Even though like I make you do that.
Actually, can.
Free.
There's ongoing need in our office right now. Every day there will be at least one person wearing a red t-shirt. Every day.
Just so you guys know, the first row with the tables is for speakers.
Good morning. To join us here. Hi, sir. Are you a speaker today? Yeah, sorry. It's first of all, so the speakers.
But we have 8 speakers and 10 places in the first row. I mean, we have 8 speakers and 10 places on the first row.
Yeah, that's right. So, I mean,
I have a very bad scene.
Sure, that's fine.
Do you miss anything from the
Sure, no problem. I mean, you get that as well. No problem. I mean, this just makes it comfortable. Of course, if speakers come
Yeah,
to.
of course.
Okay.
Yeah.
Yes.
Sorry, I'm gonna have to ask you to move back by 1 row. Available seats. Just right behind you.
Okay, don't worry about it. Yeah. Okay, okay, appreciate you guys.
your receipts are yours.
Take that, I can assume. I just saw it this morning actually. You have to show your 3D now. Like all the suggestions from the last time. But I had come on psychology. Yeah. I don't feel that. One thing is precisely it's wise
I'm Gary. Yes. Oh really? Which year? Which? Oh, 2010. Right. Yeah. And you back to oh, just about which? Oh, I just thought of it. It's cool. Yeah, I actually went in my application. Pretty cool. Yeah. And the program I'm applying for
Good morning. How's it going? Finally got my noise factor calculations into some form about midnight. The rest of the presentation is easy, but there's a spreadsheet in the middle. I'm like, this doesn't work.
Doing a live demo?
No. Well, there's basically a spreadsheet with some maths in it, which explains why noise is a problem. There's like, it's difficult and counterintuitive. I'm like, wait, time out by effect. What's going on? Well, the quantities used in the spreadsheet vary over 22 orders of magnitude. So, yeah, the small errors turn into gigantic errors very quickly. I know this works. Well, at least I reasonable. It's not quite orbital dynamics, but yeah, it is absolutely space communications. Yes, and that's tough.
I'll just press it.
Yeah, rain is there.
How are you?
Glad to see you.
Indeed.
Yes.
I still have to live in the demo process. Let one take a look at it. The problem is I'm going
It's some fairly hard engineering maths and but most of it is. Alright, okay. That's how I do my job. That's where we'll tell find enough pictures. Then not just for the audience, they also comps to me, right? So I don't like slides on it. Start with the out. And then just as if I was standing here talking to you, and it's fortunately not a sensitive.
Yeah, sure.
But of course. Or any.
That's been tricky when I need to try to avoid using cat functions. Usually when I try to avoid words, I put a cat feature instead.
Good for some.
After that, you cannot find one in Singapore. I think the only way to find a UK shop is me in Vietnam. We went to a lot of places. The Singapore one was Portugal, then there's what? Vietnam. Current ones, probably most of them are Vietnam. The only way to find a UK shop is to the UK. Singapore story or news or something. I think that my very first car also the one the cafe
Just follow the sign, cannot find already.
the exchange rate was more than double. You got 30% off.
Check 1, 2. All right, we're good to go. Good morning, everyone. I know mornings generally aren't very good for people of our persuasion, as I might put it. But good morning nonetheless. Let's try and make the best of it being 10:30 and us barely having woken up. Good thing is we have coffee. You'll notice that there's a URL on that. There is a URL on that coffee. Terrence, can you get me a tissue, please? I got coffee on myself. This is lovely. Anyway, yes, coffee, which is now all over me, and therefore I have more caffeine than all of you because it's on my outside as well as my inside. Anyway, right, you'll notice that there is a URL. Thank you, Michael. There is a URL on this coffee cup. If you haven't had coffee, you should go take a look. If you don't drink coffee, do what I did and steal a cup. Well, I do drink coffee, but I stole the cup anyway because I threw mine away like a responsible person. By the way, do throw your cups away when you're done with it. Just a reminder. Not that I'm trying to shame anyone, but still. Yep, there's a URL on the coffee cup. If you go to it, you will see something that looks... wrong screen. Like that. Let me make it bigger. You will see something that looks like this. It says win, thank you, headphones. See, I love my people. They give me lots of tissues for my coffee spills. Yep. You will notice that there is a URL that takes you to a place that says win headphones with BandLab. If you're wondering which headphones, these. There are 3 of them. They are Marshall Major 2s, and you can win them by doing, well, generally what the website tells you, which is to take a picture of your coffee and post it to either Twitter or Instagram and hashtag it with BandLab. But if you don't hashtag that with GeekCamp, I'm not going to be able to see it. So you might want to put BandLab and GeekCamp in there. And also, if this was because this is GeekCamp, I can't just let you post anything and get away with those. So obviously, the people who win are going to be the most geeky pictures of coffee. You have lots of props. This is Microsoft Singapore. Don't vandalize anything. Don't steal anything. Don't move anything. Don't pour coffee over anything. But barring that, go ahead and take photos with anything. If you're trying to take photos of places you shouldn't be in, Terrence will hunt you down. He's over there. He has a red Cortana-looking t-shirt. Cortana will chase you down along with Master Chief. Be careful. Yes, using machine learning. It will know where you're going to go next. Be afraid. Be very afraid. Anyway, yep. That's it for coffee, other than whatever spilt on me. So that aside, moving on to slightly less important things than caffeine for the average geek. Hello there, everyone. This is version 2016 of GeekCamp. That is not the 2016 version. That is simply the year 2016 version of GeekCamp. We've done a few changes from last year. We've tried to go way more casual with this, going back to the era of GeekCamp up until, say, 2012, 2013. No ministers, no curated talks, no keynotes, no stiff upper lip, formal shirt and long sleeves and suits. Just, Roland's dressed perfectly for this. Just t-shirt, Bermudas, and slippers. Do you ever wear suits to GeekCamp? I've seen people wear suits to GeekCamp. On that note of people wearing suits to GeekCamp, not that I'm implying that wearing a suit is in any way related to what I'm about to say, but at GeekCamp we have a very strict policy against harassment. So if you are being harassed by anyone, please look for me and let me know. I will probably be hiding out somewhere outside or in the back of this hall. And if you need to flag anything to us, just look for me. Now, sponsors. I've already talked about Bandcamp. except I haven't told you what they do. Well, Bandcamp is a collaborative music platform. If you give me a moment, I'll go to their website, and I'll let the site speak for itself. Maybe I should log out first. Home. All right. Well, the site kind of sort of speaks for itself. BandLab is, like I said, a social music creation platform. They do some pretty cool stuff. They've also recently bought the Rolling Stone, if you know what that is. They did not buy the Rolling Stones, the band, because nobody buys a band, unless you're weird. But they did definitely buy a music magazine that is, some would say, a nice cornerstone of the industry. And guess who's their partner of the year? Ta-da! Microsoft, our next, well, I wouldn't say sponsor, but Microsoft is absolutely critical for the continued existence of GeekCamp, because otherwise we would all be sitting on the streets right outside here instead of in this air-conditioned venue right now. So yes, thank you so much, Microsoft. We love you. And our third sponsor, without whom you would all be malnourished and starved little kids and adults, PayPal. Lovely sponsorship of our lunch today that you'll be seeing in a bit. Speaking of lunch, BandLab, by the way, also sponsored all that lovely coffee, which is why their URL is on the coffee cups. Go there, win headphones, drink coffee. It's all connected. It's a giant conspiracy. Sponsorship is a conspiracy, obviously, which is why we do it. What you don't know is that we're all part of the Illuminati. Except by saying that, now you are part of the Illuminati. Anyway, moving on to less serious things, the schedule. We're going to have 8 talks today. Simply put, it's 3 lunch, 3 break, 2. Sometimes I like mirroring my screen, sometimes I hate it. We're going to start off with Michael. Talking about the magic behind Engineers.SG, and then we'll have Roland talking about the wonders of a cardboard box, to paraphrase his title. And we're going to have Letitia talking about evolution of careers from I'm going to sit down and do admin things to I'm going to sit down and do JavaScript things. Might sound similar, but it's actually kind of different. After the break, we will have 3 talks again. We'll have Shupeng with his 3D engine for the Pebble. We'll have Omer talking about C++, as I like to call it, Rust. And then we'll have Justin talking about the Hyperledger project. And after a little break, so we can rest our tired little brain cells, we're going to have Jos talking about GraphQL. GraphQL is not REST, has nothing to do with Rust. And then we'll have, to wrap up the day, Rowan talking about Kubernetes, which is a lovely little way of doing infrastructure automation and management. Now, that the schedule's out of the way, some very important housekeeping matters. I'm going to start with something that's immediately obvious. The front door is now closed. You'll want to move in and out of the back if you need to go to the washroom, get some coffee, get some drinks, blah, blah, blah. Run away because you think we're all scary, whatever reason. Use the back door. If you are a speaker, feel free to use the front door as long as it's not in the middle of a talk, or I will hunt you down and bad things will happen. For other housekeeping matters, I'm going to have Terrence come up and give you information because he is the local here at Microsoft.
All right, thanks, Rahul. Hi guys, good morning. Awesome, good to see you guys at level. Let's try it again. Good morning, everyone. Good morning. Awesome, awesome. If you guys haven't had coffee yet, it's right up there. All right, so once again, welcome to Microsoft. On behalf of Microsoft, we're really happy to see all of you here today. My name is Terrence, and I'm from Microsoft, of course. And of course, to add on what Rahul was saying earlier, just wanted to give a few important points because we don't want to see you guys going to places that you shouldn't be. You might be locked out and you might end up staying, your whole day and the weekend over here, and no one's going to save you. So first of all, this floor that you're on today, this is level 21. Okay, level 21 is an open floor. You guys can go anywhere in the level as long as you don't go through any glass doors. technically is what I meant, because you will see like two rooms over there at the far end. You will see a transparency center and a cybercrime center, as well as the MTC, which stands for Microsoft Technology Center, right? So those two rooms, unfortunately, they're all bound today. If you happen to find a way in, you can't get out. All right, so please do try not to get in there. If you see the door open, don't go in there. If you would like to take pictures from outside, it's fine, but just don't go in there. All right, trust me. All right, and for restrooms, okay, so there are two sets of restrooms on this level. One set, if you get there, you're not going to come out. So it's important to take note of this. All right, so to go to the restroom, you want to go to the one near the transparency center. Okay, so if you go out of this door over here, all right, come out of this door, if you go straight all the way past the very nice tables and with lights around the table, you will see, there's this transparency center, the one with the green background. On the right hand side, you'll see a small corridor. That's the toilet you want to use. If you push any button and you go outside to the dark corridors, you won't be able to come in there unless you have access cards. So please take note, there are two sets. One of them is not available. The one that you use is the one near the transparency center. All right. So of course, that's for level 21. For level 22 as well, in case there is there's more people that's able to fit in this room, we might open the level upstairs, so that's also open. But likewise, you'll see any glass doors, any buttons you push to get there, don't do that. Because once you get into the rooms with the buttons, you need another card to come back again. So yeah, just remember, ground rules again, don't recap, see any buttons, don't push them, go see any glass doors, don't go through them. Then you're safe. Sounds good? All right, awesome. Okay, any questions, feel free to reach out to me. I'll be happy to show you guys around later at some time. Otherwise, we have a lot of exciting lineup for you. I'll pass the time back to Rahul. Thanks, man.
All right. Now that we have a very important housekeeping things out of the way, there's other very important things to be covered. We have stickers at the registration. 3 colors. Which faction do you belong to? I'm just going to leave it at that and let you figure out what it means. Anyway, most important thing today, have fun. Be that Tushin over there. If you were unlucky enough to get a chair without a table, welcome to economy class. Have fun. All right, Michael.
Okay. Ooh. Am I up? Oh, nope. Let me get it up there. Right. Hello, good morning, everybody. Hi. So today I'll be talking a little bit about a small little project I started a few years ago. It's called Engineers.SG. So I'll be sharing a little bit about the magic that happens behind the scenes. What you see on the screen here are a bunch of volunteers that helped out at Force Asia earlier this year in March. I see a number of faces here who were there with us. Kathy, somewhere in the middle over there. Yeah. Right, a bit about me. My name is Michael Cheng. That's my Twitter handle. You can follow me there. There's also a GitHub organization with that name with some of my open source projects. So a bit about my origin story. I studied arts and social sciences in NUS. I did not major in computer sciences, but I picked up programming on my own, and PHP is basically my weapon of choice. I joined a little startup back in 2011. It's called Found. And when that kind of ran out of money, as all startups do, I joined another company called Make33, and of course you all know that company to be me right now. After that I joined another company called Neo Innovation, which does agile stuff. Of course that went away and they got bought by Pivotal Labs. There seems to be a trend going on there. Anyway, that's where I am right now. I'm at Singapore Power. I'm a software engineer there, working on some new digital products for the company. We're hiring, by the way. Anyway, moving along. Engineers.SG, it was a small little project that I started. It's a not-for-profit community initiative. So We wanted to basically help document the Singapore tech scene. What basically happened was some years ago, I attended a little meetup, and somebody was complaining about, I can't find any engineers. There are no engineers in Singapore. That got me a little bit riled up. And, but I thought it got me thinking that perhaps we have a marketing problem. We're not telling people that we exist. We didn't tell more people that we have grassroots organizations, grassroots meetup groups that are happening. Because I think in the late 90s and early 2000s, IT is perceived to be more enterprise IT rather than open source IT stuff. So I guess maybe that's the way. So I felt, wait, there's got to be a way to tell more people about us. So videos is kind of like a way of showing other people that what we do, and of course to also let people know that these user groups exist. So you find on our website, you go down to the bottom, you'll find a link to the event page. If you like the meetup or you like the videos that's being shown there, you can click that and go to the event page and maybe follow or join the group that's there. So that's kind of like one of the motives I wanted to do. That's one of the reasons why I started this group. We started this back in October 2013. The first time we ever did this was at the user group that I ran. It's called the Singapore PHP User Group. It's on October 30th that we did our first recording. It was a single camera setup, very different from what we have right now, which is 2 cameras and many other things going on. So, which I should go through in more detail later. Yeah, so basically, yeah, this is why I created Engineers.SG. Where are the engineers? So I want to make Engineers.SG the place where you can go to find out where the engineers are, what we're talking about, and what are the cool things that we all like to geek out about. Right. And we have been recording quite a lot of meetups in the last 2 years plus, 3 years, coming 3 years. These are just a short, small handful of the meetup groups that we meet, that we record. Some stats right now, we have on our website, we've got about 1,217 videos, plus today 8 videos will be going up after today, so we'll probably hit 2020-ish. We've got 2,400 subscribers on our YouTube channel. Our monthly views is about 20K on our website, 25,000 views on our YouTube channel. We've recorded 21 conferences so far in the last 2 years plus. CSSConf and GSConf is the next conference we're recording. We have trained about 40 volunteers. So Engineers.SG is basically a volunteer-driven kind of organization. We don't get any money from this. And basically it's from passionate people who are interested in contributing back to the community and people who are interested in learning about the technology that we use. So I've been training quite a number of people. Of course, the actual active people, you probably see them at meetups, you know, so they're probably just a handful of really active ones. But we're looking for more. We're looking for more volunteers, yes. So this is our website. It's written in Ruby on Rails, if you're really keen on that. And this is our YouTube channel. So a bit about the magic. So I just recorded the iOS conference last week, and so it was on Thursday and Friday. I went back home, and over the weekend I got the videos out, and by Monday was Sunday night and Monday, the guys were able to watch the videos. So these are the tweets, the very kind tweets from the presenters for the conference. You know, yeah, like Ben Asher, who works at Yelp. He was at Singapore for iOS Conf, and basically, yeah, he said the same thing that I did last year. Like the moment he landed in SF, the videos are ready. So it's kind of cool. So how do we do it? How do we get this done? Well, I think with any kind of thing that we do, we try to streamline the capture process. I spent about a year and a half just iterating and trying out different techniques of capturing. So when I first started out, it was just one camera, and then we added a screen capture tool and a few other things. But basically what we want to do is we want to capture all the inputs. By streamlining the capture process is basically about capturing all the inputs together, the video, the screen capture, as well as the audio, coming into at the same time, capturing all this at the same time, and feeding all these sources into a laptop via USB. So all right in front here right now is a laptop that is capturing what I'm there's camera pointing at me, it's capturing my screen as well as capturing my audio, my voice. And basically goes through a software video mixer that basically records streams and it allows me to edit the video feed in real time. With this, there's basically no video post-production required. So basically, at the end of the day, the videos are ready, the MP4 files are ready, and I can upload it. Yeah. So just a visual representation. So we have the presenter's laptop. There's a video output, like in my case, it's HDMI out, goes to video splitter, which it splits the video channel, one to the projector, and the other one goes to a screen capture 2, which then gets pushed into, I plug that into the laptop using USB. For the presenter, we have, in most of our cases, we have a webcam for ease of use. Basically, we have a lot of volunteers who are not exactly very technical, and we want to make it as easy to use as possible so that anyone can try to use our system. So we have a webcam, and we also have a small little microphone that kind of picks up the audio. So the set that we have today, currently we have about 5 of these sets running around somewhere. The set we're using today is set number 2. I gave them names by the sequence in which I created it. Anyway, so the comes the webcam and the audio basically as a USB interface somewhere that captures that, and basically magically I'll have MP4 file that's ready to be uploaded. Right. Once the file is ready, the only post-processing I do is basically an audio processing. Basically, I kind of levels out the audio so that if it's too soft, I'll kind of even it out so they can hear the voice. I find being able to hear the voice of the speaker very clearly is a very important thing, especially if you're watching a video. You may not be watching a video, you just be listening to the video. So the audio quality, for me, is a very important thing to get right. And hearing the audio you don't have to tweak. I mean, as in hearing it in a way that you don't have to tweak your volume control is very important. For me, I use Apple earphones when I'm checking the audio levels, so that at least I know that is with a simple, basic earpiece, I can hear the audio properly. So I do some audio processing on this right now. The script I use is actually a shell script that uses FFmpeg and another open source project called SOX, which will convert, which will basically take the video file, split it into 2 files, a video channel as well as audio channel, and process the audio using SOX, and then recombines them into 1 file. This script wasn't written by me, it was written by Sayani, who runs WeBuild. So basically I took that script and I modified it to support multi-files access. I'll show you the GitHub repo a bit later where the scripts are available. So once audio is processed, I'll upload to YouTube, and that gets, there's a cron job that runs every 10 minutes that pull the videos into our website. Once the video appears on our website, there is an admin interface where I log in to update the title, the description, and many other things. Link to slides, and also link back to the events. I find it's important to link back to the event page because I want the viewers of the website to also find out more about the meetup group that's organizing this, so that they can also attend future meetups and join the meetups there. Of course, that's what happens on the day itself, but what happens before that? So a bit more about the magic. Well, it's not really magic, it's just process. So I actually contact the meetup organizers because for me, getting the presenters comfortable in recording our video is important. We don't want them to feel offended, or we don't want them to show anything that if they are not comfortable with going online or being made available on the internet. So we make sure that the presenters are comfortable with us recording them. If they are not comfortable, we just say, okay, so we just won't record them. There were situations where we recorded that before, and we had to go back and do some editing after the fact. So there were situations that happened, but as long as they're comfortable with us recording it, it's fine. Then we get our volunteers to sign up on the meetup schedule. So we use WeBuild.SG for their events calendar. So we use that quite extensively to help us organize and plan our duty roster so everyone will know what's going on. And we ask our volunteers, they should sign up for the meetup as well, so that the meetup organizers knows that they are going there. And then they pick up the set on the day before, and then they basically I would advise for them to reach the meetup venue like half an hour before. It takes, typically our set is quite simple to set up. It takes about 15 minutes to set it up if you have enough practice. Otherwise, half an hour should be a comfortable time to get things all set up. So as I showed you earlier, basically after the meetup's over, I copy out the file, do some post-processing on it. And it's in a wiki page over here. You can probably find it. Yep, there you go. So there's a couple of scripts that I use. Can you see it? There's a couple of scripts that I use. There's a multinorm.sh, which basically does audio normalization. So it evens out the audio, so it's not too loud or too soft. I have a script that actually helps me to generate a thumbnail. So I think it uses FFmpeg underneath it. For videos, in the past, I used to open up the files in iMovie or Final Cut Pro to kind of cut out the parts, which is a very heavy process. So I use FFmpeg, which I wrote a shell script for to split the file into separate files. There's another script that I use which concatenates. So basically, if I have separate videos, I can merge them into one file if I need to. I did not put that file here, but I probably should. And wait, it might be here. Nope, it's not here. Never mind. I'll figure that out. So yeah, so this is all open source, so you can actually see what's going on. Multinorm.sh. You will dig inside there. It's nothing more than just reading through some files, copying it to a folder, splitting the files, normalizing it, and recombining it into one file. So yes, it's shell script. And yeah, let's get back to this. After this, we update the admin page, and then we also post a link back to the meetup page. So we try to use our short URLs. We try to link them back to our website because there are situations in the past where we had to take down videos. Like there were some videos that would, and YouTube is kind of bad in the way they don't let us re-upload the same file or change the video at the URL. They don't let us do that. So we have to find a way. We felt that we need a permalink. So the permalink should be our website rather than the YouTube page. Like most recent situation was at iOSConf. iOSConf, I had one video that I uploaded, and apparently the speaker actually changed the title of her talk. And so I had to re-edit the video, but I kept the link the same on the website. So that made it a lot easier to manage. Of course, there's a simpler process. Just upload the file somewhere that Michael can retrieve it, and then I'll process the file, which a lot of my volunteers do. Okay, so this is some of the open source resources. So we have a GitHub page that we maintain all this, where I documented my process of setting up this project. So there were a couple of, like in this wiki guide, I include some prerequisites. What you should try to create a YouTube channel, YouTube account, how you can add other people to your channel so you can have other people help you manage your videos. I've also documented different ways that you could possibly try to do this yourself. So the original goal when I first started Engineers.SG was to try to get all the meetup groups to get involved, to tell the meetup organizers to, hey, get your own volunteers to record this video. But it turns out not many meetup organizers have a big pool of co-organizers or volunteers they can tap on. The other option I had was to think about getting venue owners to be involved. The venue owners, like Microsoft, will have one set here, and then we can just draw it out. But that creates an administrative burden on the venue owners. Basically, whoever works at Microsoft has to be around for us to draw it out and return it, so that didn't work out. So using a bunch of volunteers, as a core team of volunteers to go around to different meetups was, I felt, a better option for this. So, but in doing so, I also want the volunteers to learn how to do this themselves if they so choose to. So like, in here I documented the different processes of doing it, either using your own camera. So if you have your phone, you can download the YouTube. There's YouTube Capture app, which you can use to like record videos and upload it straight to your YouTube channel. So you use your phone, and then you could even like at the bottom, put it on a smaller tripod, and you can record your meetup. The audio capture on the iPhone is actually quite good. The video capture as well is also quite, for the more recent cameras like iPhone, all the pluses, basically the bigger ones have image stabilization, which is kind of great for this. Like in the past, what I'll do is when my main recording system fails on me, I'll use that as a backup. It has happened a few times. Yeah, like for the last one, I actually used an iPad to record it. So yeah, it was okay. Yeah, using one camera is also possible. I did some research on what are the best of class cameras with good audio pickup, and something that's cheap. So I found this Zoom Q4. I think it's another one, Q4N right now, the latest model. It costs about 400 plus. The audio capture on this is actually very good. Zoom makes very good microphones, and this is the microphone that just so happened to have a HD camera. Of course, much later I found out that actually Sony cameras are actually not bad. Like the one that you see at the back right there, that's our backup camera. The backup camera costs about 200-ish. You can get it from Lazada. And the audio capture on that is quite good. There were situations in the past when my primary system fails on me, and I had to rely on the audio capture from that piece of thing. So it's not too bad. How am I doing on time? Okay? Yeah. All right. Yeah. So that's for video capture. There's also the recording of the screen. So how do I do recording of the screen? If the presenter is using a MacBook Pro or MacBook, they can actually just start the QuickTime app and just start a screen recording of their own screen. And this can even set it up to use the built-in microphone so that you can, basically I can record my screen right now as I'm doing the presentation. So that's one way. Of course, you want something that's less intrusive. What I strive for in our setup is to not require our presenters to install any software. Like solutions in the past would be, oh, please install this driver here, or please install this USB thingy and all that stuff, which can be quite intrusive, and I think it's not good to have to push this on presenters. So what I wanted to do is to have a non-intrusive way of capturing what is happening on their screen. So what I'm using is a hardware screen grabber that's called AvenMedia Live Gamer Portable. This is actually this type of devices are actually created for gamers to capture their gameplay. So like PS2 or Xbox, they use that to capture their HDMI output or something. So I'm using this right now. Actually in front here to capture my screen. In the past, I had an analog system, so I had to do some manipulation. But basically, yeah. So basically, getting the HDMI feed in, there's a software that basically lets me record the video, and I could do post-production editing with iMovie or something like that. And of course, eventually, I came to a point where, look, I don't want to have to take all these separate files and combine them in post-production. How do I do this? There's a couple of software that's out there. This is one of those that I used in the early days. It's called XSplit Broadcaster. It costs about $4.95 as a monthly subscription. So that's what I used to use. Of course, nowadays, there is a new software out there that I'm using. It's called OBS Project. Thanks to Rahul, who actually recommended this software to me many years ago. So that, look, guys, you should use this. It's free. It's open source. When I first started, it was quite crappy. It wasn't as good as it was. It only had a Windows version, and the Mac version wasn't as powerful because I was using a Windows machine, and yeah. I actually did try to use my Mac to do the recording in the past. The result was mixed. Yeah, I can get good video on it, but it's not as good. Especially for the device I'm using, the Mac drivers are not as compatible with OBS, which is kind of strange. It has its own proprietary drivers, which is kind of weird. Anyway, so this is a free software you could use. That's the last link here. I also put up a small little video tutorial. If you are so inclined, you want to watch a video of me telling others how to set this up, you can watch this. Yeah, there's nothing you can try. My website is also open source, so you can actually check out the website on GitHub. It's a Ruby on Rails app. So you can scroll down, there's a whole bunch of instructions how to get the code, how to set up Ruby, how to install Postgres, and how to get this thing started and even deployed get this thing deployed somewhere. We did take part in Tech Ladies earlier this year. So Tech Ladies is a small program that help women learn about programming by working on a project for a NGO. So they basically work on the Engineers.SG website as well as their program. There. Anyway, so basically, yeah, I open sourced it so people could actually check it out and even contribute back. There have been quite a number of pull requests that I received in the past. So thanks to all those who actually sent pull requests. So a few photos of our team in action. So this is, when I was at Make Me, that was where I first started recording the videos. They had a weekly thing. We had a weekly thing called Hackers and Painters. So if the guys come to my office and I record the thing. So this is me recording. I can't remember his name, but he's presenting on Kibana, which is a visualization tool for stats. Apparently, it's our most popular video most viewed video on our channel. It's about 170,000 views so far. Quite scary. This is the first conference that we recorded. This is at GeekCamp 2014. So the first conference that we attempted to record multi-tracks and stuff. It was quite scary because I had to buy another set of my recording gear just for this. So it was kind of scary, but we got it done. So this is our typical recording setup, where we record where we have on the bottom we have my laptop, with audio mixer as well as a video camera here. So the video camera was always pointing at the speaker, like right now in front of me. There's a Sony camera pointing at me, so that records my face. And this is AverMedia Live Gamer Portable, which is a screen capture tool. There are a bunch of these screen capture tools out there. Elgato has one. Blackmagic has a couple of these screen capture tools as well. So you can actually look those up. What I like about AverMedia is that it has very good support for different types of screen resolutions. So you can support 4:3, 16:9, which some of the other screen capture tools don't support. And this one works through USB 2, so I don't need to have a very powerful machine to run this properly. Yeah. So this is my setup at Force Asia. I had a small little stool where I put my laptop there. You know, it's almost every single meetup I go to, I have a different configuration, and it's kind of fun. This is the software in action. This is open broadcaster software. So I could in real time move this around and adjust and resize and adjust the different screens. I could set up different default arrangements of screens, which I could then pre-configure and then switch into the correct scenes as and when it is required. So that's how if you watch the videos on Engineers.SG, the screen transitions look so smooth because it's all software. Software for the win. For audio recording, as I said, I put a premium on good audio recording. So having good microphones to pick up the sound of the speaker, the voice of the speaker is important. So in my case, right now I'm using a lapel mic, which is hooked up to my shirt sleeve. In other situations where where the volunteers, I don't want the volunteers to intrude on the speakers, I'll just put one condenser microphone right in front of them. Like you see in front there, that's one of the condenser microphones that we use. I'm using that for question and answers, so your voice can also be heard by whoever's watching the video later. Yeah. But in most situations, we only have one, which will pick up the speaker's voice. You'll still pick up a little bit of the background sound, as in the Q&A, which we can kind of even out using our audio processing tool, which will kind of evens out the sound. So it levels out the background sound to Q&A. Will probably be at the same level, audio level as the speaker. Yeah. So this is an example of the wireless clip mics that we use. We first used this at PyCon in 2014, I think. We first used this in PyCon because one of the organizers who was there kind of told me, hey guys, the audio that they had last year was quite bad. We need better audio. Said, okay, fine, sure. Let's get this. It's not cheap though. So it's audio. This is a sound mixer that we use. Actually, I don't use this anymore because I found a smaller and more compact device over there. It's the Zoom H5. Yeah, it's a good recorder. In most of our systems, I also have a backup system. I also have a backup microphone and a backup audio recorder and backup camera. Why do I have a backup? Because it's running Windows. Well, thankfully, it has not crashed too badly on me before, so it's okay. But in situations where the recording does go sour or something doesn't have, that we don't capture audio properly or it's out of sync or whatever, I could use a backup video to reconstruct the slides and a backup audio to reconstruct the video that I need. Because for me, the audio and the slides are the most important thing. My gesticulation and all that stuff, that doesn't matter. It's my voice and the slides that's more important. So having backup systems is important for me, and I think, like right now in this case, I have a backup camera at the back that's pointed at the screen. So it's recording the screen. So if anything happens to my system, I can reconstruct the slide transitions using that. I have another camera in front. This is also recording a video, so in case that crashes, I still have that to recover. And then the H5 itself is actually recording my audio as it sends it to the live stream. So, and of course the software OBS, now the benefit of using OBS is it has support for live streaming. So you can stream to Twitch. OBS is actually, again, another gamers tool. The gamers use that to Twitch, to screencast their Twitch, to their Twitch channels of their gameplay and all that stuff. So OBS is actually a pretty good tool. It's for streaming as well as for recording. So with all this gear, we need to have a way of carrying everything around. So I resorted to getting my mom's old suitcases and stuff. At first, it was kind of ghetto. I just, we just use a shopping cart, right? How hard can it get? I mean, there's not much stuff. How bad could it be? It's like less than $20 for this little thing. So it turns out it wasn't a good idea. Why? Because you're carrying a lot of gear and the wheels are flimsy. I bought two and both their wheels broke. I don't know why. I don't know how the guys were handling it, but the wheels broke. I think because the gear was too heavy, they're carrying up staircases and all that stuff. It broke. And I was like, man, I'm not going to spend more money on this shit. Let's get some proper suitcases. And that's when Mustafa comes in. Mustafa has some really cheap and good quality suitcases. So all these two over here are used for carrying. So here are 3 of the sets that we have. Again, I have a total of 5 sets right now. 2 of them are actually stored in a secret location where my volunteers can pick up and use during meetups, for meetups. When they're done, they can bring it back there and store it in the secret location. Okay. So I named them by the order in which I accumulated the equipment for. The equipment that I accumulated, it actually started early this year. So in March, when I was recording recording Force Asia, they needed to record 5 tracks simultaneously. So which is why I had to start buying additional equipment just to help make that happen. So right now I have 5 sets. Yeah. So if you are interested in helping out as a volunteer, there are enough sets for you to carry around. In the past, when I first started doing this, the meetups were not as regular. There were only like 1 or 2 meetups a week, at most 2 a week. But nowadays, it's like 4 or 5 days a week I'm involved in going for meetups, and on my team rather, we're all going for meetups and recording meetups, which is kind of cool. Cool for the community, but stressful for us. Thankfully, I have a job that lets me knock off at 6 o'clock, so it's thank you Singapore Power, and Pivotal, and Neo. Yeah, we do have a cable management problem because carrying so much gear around does require a lot of cables. So yeah, we do have. But then again, my rationale is we'll only be there for a couple of hours. I don't think it's not that much of a deal. But for conferences, when I do record conferences, I try to tape down stuff like over there. There's a little black tape, gaffer tape, or duct tape. Yeah, simple. So what's in our bag? Here's what our set number 3 and 4, which is what our community members use. This is laid out on the table what the guys would carry to the different meetups. I'll just go through some of them. We have a Windows laptop because OBS Studio works best on Windows, especially with the screen recording tool that we have. And it has been proven to be quite effective. And it's cheap. I got this off Carousel for like $300. Yeah, with dedicated graphics card some more. It's quite good. Anyway, so for screen capture, I also have a bunch of video adapters. So I want to prepare for every situation, every kind of output that the presenters bring to us. So over here we have HDMI. Okay, there's another slide here. So we have a VGA to HDMI. We have which is meant for locations where there's only VGA projectors. We have mini DisplayPort to HDMI. We have a DisplayPort to HDMI and HDMI to VGA and a few other things. So yeah, we're ready for you, except USB-C, which I'll probably have to get soon. Actually, I have a couple of them already, so I have a couple of, yes. Right, so for the recording audio, to simplify things, I basically got a Blue Icicle USB. It's a USB sound card which has a XLR interface, a 3-pin interface, which can be connected directly to a condenser microphone. So with this setup, because condenser microphones requires you to send an electrical charge to it to basically charge the diaphragm. So basically, it requires a electrical charge which the Icicle can provide. So it basically will power the condenser microphones. Why do they use condenser microphones? I think they have the best audio pickup overall. Webcam. So we have a Logitech webcam that we use. The cable is kind of long, about 2 meters. But in case we have situations where the presenters is quite far from you, we have a 10-meter USB 2 extension cable just in case. Here's a screen capture tool. It uses a mini USB cable that connects to the laptop. HDMI cables as well as HDMI splitter. So in the past, when we first started out, it was all VGA because that was the only tool that I know how to use. Then much later, I figured out that we could actually use HDMI as the capture. Yeah, so this video camera, this is usually the backup camera that you see at the back. The backup audio recorder, I'm using the Zoom H1. It's kind of cheap, about $100+ for this. So it captures really good audio. Bunch of tripods, and for the backup camera as well as the main camera. And of course, you need power. So yeah. So what's next? What's up? What are the next steps that we want to push Engineers.SG to? I want to try maybe. Well, these are my wish list. I don't think I have the capacity to actually do this right now, but these are things on my wish list, and I hope that I can get some volunteers to help out and spearhead some of these things. One of which is to produce transcripts for videos, so that people can easily skim and scan the text of the content of the talk, and even make it searchable by keywords. And even translation and subtitling, so that it makes our video accessible to the region. So I envision in future we could have a Bahasa version or Vietnamese version which can be made available, and people in those countries can watch and learn some of these things. And also find a way to build to optimize our workflow further, to automate the upload and distribution process. Because right now it's still rather manual after the fact. I still need to upload the files and all that stuff, update the content and stuff. So these are some of our volunteers that we have. As you see, on the left we have the volunteers for Force Asia. On the right is our volunteers at PyCon 2014, I think. Should be 2014. Yeah, so we have Beyond here, Valentine, Natalia, and a few others. Yep. I feel bad for some of the volunteers at Force Asia because I had to they were there to attend the conference, and I was short-handed, so I kind of like, hello, can you help me? And they were all very kind in helping me, and I'm really, really thankful for all of them. So you will find that what we're doing is inspiring and kind of mildly interesting.
Or useful.
Or useful. Do join us and support us. You can email me at admin@Engineers.SG. You can also follow us on Twitter, Engineers for the Win. Or you can like our page on Facebook. Or if you're so inclined, you can actually support us by clicking on this little link over here, which will bring you to a little support page where you can help out in some small monetary means, So no pressure. Don't do it if you don't want to. Yes, that's all I have. Questions? Yes, Roland. You
mentioned I forget what it was, but sort of your overwhelmingly most popular talk in terms of views. Have you learnt anything interesting about which speakers or topics or events get most views after the fact?
Well, keywords, if it's a buzzword-filled kind of talk, like Docker or or Kibana or something like that. So search terms and buzzwords do draw a lot of views. Big name speakers also draw a fair bit of views, because I think partially because they retweet or reshare it on their own Twitter account or through their social network. So their therein also brings a lot of views. To be honest, I think I need some data science on this. We need data science shit out of this to find out what are the popular ones. I have not done it yet, so it's something I probably should try to figure out. Not that I want to use that to target different, find out which are the meetups I should record or whatever. I try not to curate that. Because I really want to capture all the content, as much of the content as possible. I try not to curate or target things. But I do recently on the website, I actually added a featured section so I can actually target or other highlight noteworthy videos. I think recently I highlighted the keynote videos from iOSConf during the Agile conference. After the Agile conference, I also highlighted I also brought up as a featured video, some of the keynote speakers from Agile conference. So there are some ways of servicing things, and usually if it's the first video on the home screen, on the home page, usually it gets quite a fair bit of views as well, because it's usually the first item you click on to kind of get a sense of what are the videos there. Yeah, I should really data science this and do some.
Seems like an interesting.
It would be an interesting project. Yes, it would be an interesting project. Any other questions? Yes.
I hear you mentioned you started this to increase the visibility on engineers in Singapore. But I also like to say big thanks from all engineers that it's also useful to engineers themselves, because we don't have time to attend all of these talks, and sometimes we miss out. It's great to be able to follow along anyway. Yeah, so thanks a lot for that.
Thanks.
I have one question though. So you show you have a lot of gear that your volunteers bring down for every event. Have you ever lost any equipment? And do you have any tips and tricks on how to make sure that your volunteers actually bring back all the equipment?
I have lost things before. Even myself personally, I've lost. It's usually out of forgetfulness when you're in a hurry packing stuff away, like power adapters and stuff. So I do have I did lost one power adapter once. I think it was stuck to one of the. I haven't actually solved that. So I think some of my volunteers did suggested having a packing list so they can look through it and then they can double check what's there. In the volunteers training, when I conduct volunteers training, I would ask the volunteers to learn how to unpack the pack and repack the set. And I would tell them which are the pockets they should put the specific items so that they would know what needs to go back where. That is helpful in helping them remember what they should be keeping. For some of the equipment, for most of the more expensive equipment, I actually put the Engineers.SG sticker on it so people will know that it belongs to us. There was one situation where we had a laptop bag. So we were at Force Asia, there were a lot of Lenovo laptops flying around. And there was one particular bag. There were a lot of those laptop bags, right? We weren't sure which it belonged to. And it just so happened that I stuck the Engineers.SG sticker on the laptop bag, so he was able to find it. About the videos being useful for engineers, yes, that's one of the goals. I wanted this for people to also learn from these videos. One of the validations I have of this was at my workplace at Neo Innovation, like last year. I was doing something, and then my colleague was, during lunchtime, he was watching a video behind me. I turned around, what was he watching? It was a PyCon video of one of my other colleagues talking about PyTest. Yeah, testing in Python, and then apparently we were working on a Django project, and he needed to skill up on testing in Python. He was watching a video that my team recorded. So for me, that was a big validation of what that people are actually using it for the purpose that it was meant to, which I think is a good thing. Okay. Yes.
This is a not-for-profit project, and I want to know what's the benefit for you for doing this, or what do you enjoy, or what do you learn from this project?
It's not for profit, yes, but we do need money. So for certain things, like some conferences, I actually do charge a small fee. The money that actually goes to helping upkeep the equipment that we have. It's also the same there also is a company. There's a company behind this project, and the company is also used to organize PHP conference, which is PHPConf Asia, which I run, and basically the money that I earn from the conference also gets funneled back into purchasing equipment for all our sets. What I learned from this is I think the community can be really. I think we have a great community here. That everyone is willing to share new things, and as the word got out that we're doing this. There were more meetup groups that were interested in getting their events recorded, which I find is very cool. It's a cool thing, and I hope I have more volunteers. I really wish I had more volunteers that can capture everything. But I've come to the conclusion that completeness is not a goal anymore. I don't need to capture all the videos, which could be a good thing. Which means you guys have to start going for meetups. Yeah. So. Does that answer your question? Yeah. Okay. I don't actually benefit much from this. I have sleepless nights.
If anything, it's the community that benefits.
Yeah. I hope you guys enjoy it. Yes, Vishnu?
When you're recording in two different cameras, has clock drift ever been an issue? Like I've heard that things can be like 1 second off when you're doing like an hour-long video.
Clock drift, you mean OBS?
Between the cameras or OBS? One camera's at a different clock frequency than the other one, and it's slightly off.
Well, I think I'm recording 50 FPS on both cameras right now, so I think it should be fairly okay. But the problem does arise when I put these two together with the screen recording, because the screen recording is recorded at 30 frames per second, and the videos are going at 50 frames per second. So sometimes it does happen, but I'm using Final Cut Pro that kind of reduces that probability. So the workflow during conferences, for post-production during conferences is I'll take all the video sources, put it into Final Cut Pro and synchronize them using the audio. So I use the audio to synchronize a bunch of clips together, so that I know that when it's, the video clips will be in sync. So when I need to cut out or edit out parts, I know that the audio and the movement of the lips are kind of in sync. We did have a problem before in the past when we were using webcams where the lips are moving, but the audio is like 10 millisecond off or something. So there's a bit of a disjoint there, but those can be fixed. Those can be fixed in post-production. But in the previous system, when I was figuring out the audio setup on OBS, I did have to put on the video camera a few millisecond offset so that you'll be in sync with the audio. But once I figured out how to actually solve that problem by not putting it as a source, but putting it as a audio input rather than an item in the scenes list, it kind of fixed the problem. Yeah. Yes. Took a while to figure it out, but yeah. Yes.
When you mention producing transcripts, you don't mean manual, right? I assume you mean automated tools. Transcripts.
I know.
Have you tried anything that looks promising?
To be honest, I have not had the bandwidth to actually explore that yet. But there are ways. I mean, there's auto subtitling on YouTube, which is kind of crappy. I've not actually looked into that. Although, if you go to any of the videos on YouTube, we are kind of enrolled into a program called the Amara project. So the Amara project does. Just scroll down. Yeah. So if you scroll down here, there's an Amara link where you can contribute back to. Ooh, did I click the wrong one? Oops. Where are you? Yeah, okay. So there's an Amara project page where you can actually contribute to subtitles of different videos. And I've also recently turned on the community contributed subtitlings. So there is a option here that allows communities members to contribute subtitles of different languages. So you could do that as well right now. Yeah, I have not had the bandwidth to actually explore this further. Yeah, so if anyone of you would like to help out, I'll be very happy to grant you access to stuff. Yep, thanks.
I think that's about as much time as we have for questions.
All right. Thank you very much.
Michael, not just for the talk, but also for next up we have Roland, who's going to talk to you about, as I like key paraphrasing his talk, the adventures with a cardboard box.
That's about right. Do I need a microphone?
Yeah, you do.
So that name is not the English title anyway. Something cardboard box, something satellite. If cardboard boxes and satellites don't get you excited, then I have to question my idea.
Yeah, my thoughts exactly. Okay. The magic has not happened. Settings. Display. Oh, there we go.
Focus. All right.
All right.
The floor is yours.
To do that. Hopefully the right things will happen. Hey. Okay. Yes, let's keep this configuration. Let's close that one. And we shall come back to the scary maths later. So, the title, as it says, I would point out, is not metaphorical. This is about an actual use for a real cardboard box to receive radio signals from the moon. This is part of a broader series of talks and demonstrations I'm doing on amateur radio. I won't repeat the entire introduction today, other than to say there's a great Wikipedia article. This is the sort of conventional symbol for amateur radio. Something's gone wrong. Give me a moment, please. I should be able to see what is happening. Press that. Slideshow. Everything's fine, just I haven't got the usual presenter display. Never mind. But very briefly, amateur radio is a radio communication service, but it's specifically for things that are about personal motivations rather than what you're doing for your employer. The definition is used in most English-speaking jurisdictions. It's been used for about half a century. I would suggest it looks an awful lot like a definition of the maker movement, except for the bit about radio. That is, it's self-training, it's not for profit, it's sort of engineering for fun. I resumed my involvement in amateur radio about 2 years ago. I first did this when I was a kid. And the question for me at the time was, why do it? The internet and smartphones have kind of eliminated the traditional use of amateur radio. What's the point anymore? And so I identified 4 different areas where amateur radio was interesting. To operate where the mobile network goes away, this is particularly in natural disaster type scenarios. Louisiana went underwater, the mobile network stops working, and the roads are underwater, so engineers can't get out and fix it. Operate in places where the network doesn't exist. Rural and desert areas are an obvious case. Space is the other, which is my area of interest. The DIY radio electronics very much interests me. I've been playing with electronics since I was 7 years old. And so this as an application of electronics is fascinating. And not so much for myself, but for many people, the ability to operate at increased power. Amateurs can operate in the sort of high hundreds or low kilowatts, which is useful for communicating very long distances on the Earth's surface using the ionosphere as both a duct and a mirror. Amateurs have been involved in space right from the beginning, and I do mean the beginning. In '57, hello, I do apologize, my presenter mode just isn't working. In 1957, the Soviet Union launched Sputnik. The first person in the Western world to detect Sputnik was not part of a university or of a military organization or of any governmental organization. It was a ham operating out of his basement in West Germany. He later went on to establish the Bochum Observatory, and I'll come back to it later. But yeah, it happens that Westerners weren't looking at the time, so it was a ham who picked it up first. Hams were involved right at the beginning of the space race. So in 1961, when the first cosmonauts and astronauts went to orbit, December that year, Oscar 1, orbiting satellite carrying amateur radio, went into orbit. It hitched a free ride on, of course, a CIA rocket. I'm perfectly serious. And so that was the first of the amateur satellites. There have now been dozens or low hundreds of satellites carrying amateur traffic one way or another. It's an ongoing thing. There are probably 30-odd operating today. One is the ISS. This has not only an amateur station on board, but also an amateur repeater. And more than half of the astronauts, and I believe also the cosmonauts who serve on the ISS, are in fact licensed amateurs and use it to talk to friends and family from orbit. So I haven't yet got around to doing it because it's the wrong time zone. The astronauts operate on London time, and they usually do amateur radio after work. So think 3 in the morning, 4 in the morning our time. I will get to it at some point. Another interesting variant is satellites that were built for a different purpose. So these are EO 79 and 80, they're European Space Agency satellites that had a sort of paid science mission first, and in return for being allowed to use amateur spectrum, then made these satellites available for amateur use for the entire rest of their lifetimes. So they spend 6 to 12 months doing their science mission, and then sort of 5 to 10 years providing amateur service. So there's quite a few different ways that amateur satellite capacity comes into being. They're not all fully amateur-funded satellites. To talk to these low Earth orbit satellites, so the ISS, the EOs, you don't need terribly complicated equipment. In some cases, you can do it with a handheld antenna. And in fact, if you look at the bases of the antennas just in front of my head, they actually have nice foam handles. These are antennas designed for handheld use with a handheld radio. In this case, I've got a pair of them to solve a polarization problem, and a little metal box in the middle that has motors in it that steers to follow low Earth orbit satellites as they cross the sky. They cross quickly, 15 minutes is typical. And so yeah, it gets exhausting to keep pointing while you're talking. So I've forgotten the sequence of the story, but a satellite that was launched in 2000 called AO40, Amateur Oscar 40, had intended to use what's called a Molniya orbit. This was something invented by the Russians because they had a need to serve the very northern latitudes. And so you take 3 satellites with this very elliptical orbit that's fairly tight around the southern hemisphere and a long way out 65, 70,000 kilometers at the northern hemisphere, and it has about 12 hours of exposure on each orbit. So just 3 of these is enough to provide round-the-clock coverage for the entire Earth north of about 40 degrees latitude. And so for the Soviet Union, this was a very useful tool. So AO40 decided to attempt to get into a Molniya orbit rather. It failed, and so it ended up in this entirely different orbit to what was planned. But, and again, so this is not like commercial service. There's a whole lot of random stuff going on. I'll come back to AO40 later, but I raise it now because it will be important in the story to give you a sense of where it is. It's not in low Earth orbit. Right? It was only operating for 4 years, between 2000 and 2004, but it's in this very elliptical and very high orbit. Outside of geostationary, in fact. So quite a long way out. My end objective is to bounce radio signals off the moon. This is a bit difficult. It's 750,000 kilometers round trip. And so it's not just radio, it's cryogenics, it's signal processing, and a whole bunch of other things that all have to work at the same time for this to work. This is a multi-year project, and that's okay. I will sort of keep playing with related stuff as steps towards. And that's part of actually how the thing with the cardboard box came about. I was looking for an intermediate project. Before I get into what I'm doing, just a quick survey of other cool things that amateurs have done or are doing in space. During the Apollo program, when second-hand TV dishes were not available cheaply, this gentleman built himself a stressed hyperbola dish. So it's not a parabola, it's straight beams that are then stretched using fishing line, but it's near enough to provide a focused beam, and was actually able to listen in to the capsule communications for the Apollo program. The deal was, yes, it's fine for amateurs to be listening, no, you can't record it or reproduce it. So it's an interesting way. In Singapore, it's like if it's not broadcast, you're not allowed to listen to it. In the US, it was like, fine, you got us, but you can't reproduce it. So they got to listen, but the official recordings are NASA's. One thing that's generally fairly easy, actually, is to listen to Jupiter. Jupiter is the most powerful source of HF radio emissions in the solar system, even more so than the sun. And so with a bit of wire about 8 meters long and a sensitive receiver, you can in fact listen to radio noise emitted by Jupiter. At the other extreme, and I mentioned the Bochum Observatory, founded by the guy who happened to hear Sputnik. In 2006, a bunch of amateurs were able to detect Voyager's signal. At that point, it was already past Pluto. It was 10 billion kilometers. So this is, I think 250,000 kilometers is hard. They then set about bouncing radio signals off Venus. It's 5 million kilometers away in 2009. That's beyond what I expect ever to attempt. Apparently, they're a fairly ambitious group, so they've set their sights even higher. Not to bounce signals off Mars, which apparently would be too easy, but to build this object and put it in orbit around Mars. They're not kidding. How they'll arrange a ride, not yet clear. But as I said, amateurs have put dozens of satellites into orbit, including in some fairly high orbits. Can we get a ride to Mars? Well, time will tell. If they succeed, they will win this revolting object. This was a cup created in 1929. Hiram Percy Maxim, who's very much the sort of father of the amateur radio movement in the US, was also fascinated by Mars. And so he established a prize, which is just the cup, there's no cash, for the first amateurs who established two-way communication with Mars. And details up to you. So it's the AMSAT Germany group who's doing this, and they actually expect to succeed, at least within our lifetimes. Quite how, whether that's 5 years or 20 years away, I don't know. More in the sort of projects that have succeeded, this is IC3. It was a satellite launched probe launched in the 70s. It was placed in a location called Earth-Sun L1 to observe the sun. It was then retasked to rendezvous with a comet. It was then retasked again to rendezvous with a second comet. So it's both the first spacecraft ever to rendezvous with a comet and the first and only to rendezvous with two, as part of the posse of probes that chased Halley in 1986. By about 97, NASA was like, okay, we're finished. We have nothing more useful to do with this spacecraft. So they gifted it to the Smithsonian in orbit. It's in orbit around the sun, and it intersects the Earth every 15 to 20 years, approximately. So in about 2010, more than a decade after its last command was sent by NASA, a bunch of people, who I assume are college students, thought, IC3 will intersect with Earth in about 2014. We should reactivate it. And so with the help of the Smithsonian and NASA and the Arecibo Observatory, who lent them the world's biggest dish, and some radio manufacturers who lent them software-defined radios, this small team actually put together a project to regain control of the craft, to fire its engines once to get it into a stabilizing spin. Unfortunately, they weren't able to make the additional firings to put it back into its original mission. But this, of course, required not only orbital mechanics and spacecraft operations, but radio. Right? The reason for the use of the Arecibo dish was to have this very weak signal communication with a spacecraft that at the time was a long way away. And so this is kind of an extreme example, but it's what people who are playing with this stuff for fun can and have achieved. So getting back to what I'm doing, my problem for choosing smaller projects and sort of small steps towards the larger one is low Earth orbit's pretty easy and can be done with handheld gear and can be simplified, at least operationally, by having an automated tracker, which I built earlier this year. Geostationary and Molniya are anything up to, whatever, there's thousands of times that distance, but with suitable dishes and some fiddling, it's doable. But to get from, and setting aside that there are no Molniya orbit or currently any amateur geostationary orbits, although there will be in about 18 months, getting from 60,000 kilometers to 750,000 kilometers in one step is a bit horrifying. It's quite a difficult thing to do. I was like, well, you know, wouldn't it be nice if there was at least one intermediate step? But there can't be because there are no operating radio transmitters on the moon, which is literally true, but misleading. There's an operating radio transmitter in orbit around the moon. This is the Lunar Reconnaissance Orbiter. It's in the process of doing sub-square meter photographs of the entire surface of the moon. It has 2 downlinks. One of them's on S-band, which is pretty close to Wi-Fi and Bluetooth. So the equipment is readily available. Not necessarily cheap, but readily available. So when I realized this, I thought, oh, hey, this is still operating. Surely somebody has gone to look for it. And the answer is 2 people have gone to look for it. One using a 60 centimeter satellite dish, one using a 90 centimeter Wi-Fi point-to-point dish. But they're both, because of the frequencies, they're both about right. Fairly similar stats. So the dishes are comparable size, they're both optimized at about the same frequency, very similar gain. 21, 22 decibels is approximately 100 to 1. So instead of listening to the whole sky, they're listening to a hundredth, about a 15 by 15 degree cone, if you like. Some differences in approach. The OZ9AC guy used a 1,000 to 1 low noise amplifier without any frequency conversion, which means he needed some fairly fancy coax. It turns out that the standard coax that we use for most radio is useless at 2.4 gig because the losses in the coax are immense. The gateway guy basically sort of ordered random gear off Alibaba and then messed around for a while and got it to work, was using a low noise block and down converter for satellite TV. And then just cheap coax and RTL SDR, the standard dongles. And again, because the down conversion had occurred, the frequency was in a range that a $10 STL dongle could talk to rather than a $1,500 universal software radio peripheral, which is the sort of Rolls Royce of software-defined radios. So, okay, I thought that's great. So when I get to the point of doing that sort of stuff, this will be a useful starting project ahead of getting a 3-meter dish and all the other stuff required for Earth, Moon, Earth. But they're still dishes. And in Singapore, there's a regulatory problem with dishes. It's doable, but you need about 3 or 4 government agencies to all say yes at the same time. And so I will get there, but it's not where I want to start. So I thought, okay, I will shelve this as an interesting project as an interesting entry point once I start having those discussions with the various bodies who have to say yes. So separately, about a week later, I was reading up on AO40, this thing that tried to get to a Molniya orbit and ended up in this, not quite, but this very high orbit. And there'd been a problem with getting hams in the US to try it, because even in 2000, hams were sort of less willing to go out and buy a dish.
So someone says, well, no, it's microwave. You don't need a dish. You can use a horn, meaning something with flat sides, a bit like a speaker box. And the important thing about flat sides is you can literally use a cardboard box and a roll of alfoil. So not a metaphor, an actual cardboard box, in fact, two. And so what you're seeing here, so from the outside you're seeing a cardboard box. Inside is a second box with sort of 4 roughly triangular pieces to make the horn. And at the back of the horn, a bit of, roughly a paperclip, a bit of wire stuffed directly into the input socket on the low noise block. And so the low noise block and down converter sitting directly on the back of the cardboard box, and the driven element is just a bit of stiff wire in the throat of the thing. So I thought, well, that's really cool. I love this. This is a sort of nice hack and good thing for hams and yada, yada, yada. And then I happened to notice the specifications. And here we've got one of the craziest coincidences ever. LRO operates at 2271 megahertz. AO40 operated at 2304. They're less than 2% apart. It means I don't even have to redo the numbers for I can just make the same box. I will redo the sums, but in principle, they're so close that you can use exactly the same equipment in both cases. But importantly, the gain is about the same. 20 dBi is about 100-fold. This is near enough the same specs as what these other two guys were using to detect LRO. So like, whoa! So I can take a cardboard box that was used to solve a problem a decade ago for AO40 and use it to detect transmissions from the moon. I've got my intermediate project now. Unless the MDA decides to start regulating cardboard boxes, in which case I have a problem. But assuming not, that's the approach that's available. So I'm taking sort of a hybrid because I already have a Navina, which has what's called a field programmable RF unit, the sort of a primary component of a software-defined radio on board, which operates all the way up to 3.8 gigahertz. So it will cover completely the frequencies involved, meaning I don't actually need a down converter. So I've taken the box, a low noise amplifier, a bit of rather expensive coax, and the Navina. That's the current design. The amplifier is just a little box. It's sort of that big with SMA connectors on both ends. The coax is ludicrously expensive. A, because it's got to have low capacitance, so it's not absorbing the signal, and B, because it's got to have good shielding, so the signal isn't escaping. A really fundamental problem. If anyone in the room has done any communications engineering, the reason that super heterodyne radios were devised is because a device like this, which has a lot of gain and the same frequency at the input and the output, is a very high risk of feedback. If any of the output that's 1,000 times as strong as the input gets back in, then you'll just get feedback. And you probably won't damage the amplifier, but you'll certainly lose your signal under the noise. And so, yeah, you need the coax not only to not have capacitive losses that absorb a high-frequency signal, but also not to have emission, which will make its way back in. So, yeah, that's like an $80 cable. A Navina. Unfortunately, I've damaged the screen connector on mine, so I may have to do something a bit clever, but the device is still working fine. Not apparent in this photograph, but there's a sort of option socket here, and the Navina is shipped with about 4. This is Bunny Huang's open source laptop, for those who are not aware of it. It's shipped with about 4 different options, and one of them is the field programmable RF unit. And it makes use of the fact that on the motherboard, there's an FPGA, because the rate of samples coming off a Lime chip is so high that you can't get it into a USB 3 or even a USB-C connector. You'd need about 4. So you've got this very high bandwidth connector available. So, how am I for time? When do I finish? Anyone? Come on, 11:30, so I'm off about 20 minutes. Okay, that's fine, good. So here's the difficult math part of the talk. There are 4 separate ideas that I want to present here, and this is to give a sense of why this thing is difficult to do, even one way, and then sort of in your head you can work out what happens if you double the distance. It gets worse. So this first table describes the amount of power, the amount of signal power available at each step between the LRO and the analog to digital converter inside the chip in the laptop. The transmitter is operating at about 5 watts, or in scientific notation, for reasons that will become obvious, we're crossing 22 orders of magnitude here, so the numbers get tiny. 5 by 10 to the 0. To make their lives easier, radio engineers use decibels, and usually decibels of milliwatts. The reason is, instead of doing a lot of multiplication, it becomes addition and subtraction. All the powers of 2 we're accustomed to become multiples of 3. So a doubling is add 3, or halving is subtract 3. Multiply by 16, add 12. Or divide by 16, subtract 12. And so for radio engineers, it's all gain in decibels, and therefore an actual power level in decibel milliwatts. However, very few people in this room are accustomed to thinking this way, so here are the same numbers in scientific notation and then metric. So the transmitter on the satellite is operating at about 5 watts. It has a 75 centimeter dish antenna, which delivers about 22 decibels. It's about 200-fold, 160-fold gain, effective gain. So instead of radiating uniformly, it packs it into 160th of the sky. And so the effective isotropic means all directions, radiated power is 790 watts. This doesn't change the actual amount of energy that's left the satellite, but because it packs it into one narrow piece, it means we can pretend that we've got that larger amount of energy. The big problem is the free space path loss, where we get to lop 21 zeros off the amount of power. So what was 800 watts of effective power is now in the attowatt. In fact, not even. It's the zeptowatt range. There are some even worse problems. Pointing is difficult. In fact, the reason that this project is connected to my satellite tracker is that at some point I will mount the cardboard box on the tracker in order to maintain precision pointing, to keep the moon right in the middle of the field, because there are losses associated with pointing. I've guessed here between atmosphere and pointing divide by about 4. There are also atmospheric losses. If you're looking at stars in the sky, they twinkle a bit. This is called scintillation, and it's because you've got air between you, at least the first 50 kilometers, you've got air. It's moving a little bit, that disrupts the signal a little bit. So between those two, allow 5 decibels, roughly divide by 4. Okay, and finally polarization. So the tracker that I built back at Maker Faire actually had pairs of antennas at right angles. This is to synthesize something called circular polarization. Most radio signals are linear. You've got a simple antenna, straight line, electrons being pushed back and forth, left and right, and so you've got an E field going this way, and therefore the H or magnetic field going this way. That's the basis of radio, and most of it's done linear. You can also polarize a signal in a circular way. And so the signal is doing a helix. It's going in circles. The simplest way to do it is to have an antenna that is itself a helix and point it in the direction you're pointing. And so as the electrons are moved up and down the wire antenna, you're creating firstly an electric field that's in a helix, and then 90 degrees behind it, a magnetic field that's in a helix. This turns out to be really useful for satellites because it means you only have to get the pointing right. You don't have to align polarization. If you've got 2 linear antennas, if you're on Earth, you've got a TV and a TV station, then okay, that's really easy. But if you've got a satellite at an unknown orientation and you've got an antenna on the Earth, it's not enough to point them at each other. You've also got to get them into the same polarization, or you're throwing away 99.9% of your signal. So helical is frequently used in satellite comms because it means that once you've solved the pointing problem, you don't have to solve the polarization problem. The difficulty is, because I'm using a horn here, horns can only do linear. So I'm getting away from the need to make a curve, and both the technical problem and the regulatory problem, but what I'm getting back is I can only operate linear. And what that means is, and only one linear, it can't be polarized 2 ways. So for the satellite tracker I did for Maker Faire, it's 2 antennas, and there's a way to mix them. In this case, I can only do it one way, which means I lose 50% of my signal. So I go from 2 by 10 to the minus 19 watts, once I've taken into account atmosphere and pointing problems, to 1. This is 1/10 of an attowatt. In SI, that's called a zeptowatt, which means basically nothing to anyone. In metric, you're allowed to concatenate prefixes. So to help make some sense of this, what I'm talking about is 0.1 nanowatts, 1/10 of a billionth of a billionth of a watt. And this is not notional. This is an actual amount of power that's available for processing. So we're not it's a ludicrously small amount of power. So, okay, how do we get from this to a usable signal? The first is the cardboard box. The cardboard box has a forward gain of about 20 dB or 100-fold. So that gets us from 1/10 of an attowatt to 10 attowatts. Bravo. We've gone from almost nothing to a little bit less than, a little bit more. The next is the low noise amplifier. It adds about 1,000-fold gain, 30 dB, which gets us up into the femtowatt range. Unfortunately, we then have some problems. The coax, despite being very fancy, will still lose about 30% of the energy that gets passed to it. There's also coupling inside the novena between the coax and the line microsystems chip. I'm guessing another decibel there. It might be actually 2 or 3. So what's presented? So inside the field programmable RF chip, the Lime chip, are these 4 amplifiers that process the signal in sequence. So at the time that we enter the chip, we are at about 5.6 femtowatts. This is still a ludicrously very tiny signal. Fortunately, there's a lot of gain available inside the chip. There's firstly a low noise amp stage, which introduces about 12 decibels or 16-fold amplification. There's then a variable amplifier for up to 1,000-fold. There's then a low-pass filter for getting rid of a lot of noise. There's then another variable amp with another 1,000-fold. So at this point, we're steaming. We've reached 350 nanowatts, a third of a microwatt. Is this enough? Hard to say. So inside the chip, the ADC it's differential, and it works on about a 1-volt peak-to-peak basis. It's a 12-bit ADC, meaning 4,096 levels, and I believe they're linear, meaning we're looking at about 240 microvolts per step in the input to the ADC. Okay, so how do we compare these things? The input to the ADC has an impedance of about 2 kilo ohms. So you multiply these two numbers together and take the square root. And that gives you a voltage of about 27 millivolts, which is almost 100, in fact, just over 100 times the step size. So the answer is yes. Assuming that my numbers are right, and there's an awful lot of guesswork in here, so they might not be. But assuming that they're right, then this stuff altogether is enough and just enough to allow the ADC inside the front-end chip to actually discern the signal that's arriving from LRO. So sort of we can almost celebrate, except we have a problem. There's always a problem. The problem here is noise. So this is a much lengthier discussion, so I'm going to sort of gloss over it a bit. The entire sky outside of Earth, so the entire universe, is emitting radiation, called heat, at a very low level, about 3.7 degrees Kelvin or minus 269 Celsius. But it's not zero. And for numbers this tiny, or this tiny amount of heat actually matters. Worse, the moon is not at that temperature. The moon varies between a couple of hundred below freezing and a couple of hundred above freezing. For the purposes of this, I've assumed about minus 25 Celsius, which is somewhere near the middle, or 250 Kelvin, and that the moon is occupying only part of the field that the box is looking at. So it is as though we were inside a sphere at 23 degrees Kelvin, minus 250 Celsius. We multiply this by something called Boltzmann's constant, which is very close to Avogadro's number, for those who remember their chemistry. And we end up with something called the noise power spectral density, which is measured in watts per hertz, or joules, in fact. And the difficulty here is the amount of noise power you take in is a function of how wide a bandwidth you're listening to. If you're listening to a channel that's 1 hertz wide, then you'll get 10 to the minus 22 joules of energy per second. If you're taking a channel that in this case is 5 megahertz wide, you'll get about 10 to the minus 15 watts of noise. That's an incredibly tiny number, except that it's about 10,000 times this number. So now we have a problem. That at a first approximation, if you don't have the antenna, what you're receiving in noise alone is 10,000 times what's coming from the satellite. And that's within the passband that you care about. That's hopeless. There's absolutely no way to recover that signal. So you then add an antenna, and this helps us. Oh, sorry, it actually gets a bit worse because of the polarization problem, but that's fine. Add the antenna, and the gain in the antenna we get to count twice. I think I've got this right. Firstly, it strengthens the apparent signal coming from the satellite because it widens the aperture. The aperture for a paperclip is tiny. The aperture for a cardboard box is about 100 times that. So the amount of signal power that's entering and being guided into the front end of the low noise amplifier is increased by about 100-fold by having the box there. This is the basis of an amplifier or of a sort of a cone that you're hearing with or whatever. It's the same idea. But additionally, it narrows the beam. So the fraction of the sky that we're receiving noise power from is dropping at the same time. So we get to count the gain twice. Not perfectly. Unfortunately, hidden in here is an assumption about the antenna gain. So I'm afraid my spreadsheet isn't quite right, and so the numbers are slightly exaggerated. But so these are all added except here. Here we subtract. These are these numbers here. But we're subtracting in this case because the box is simultaneously increasing the amount of energy received from the satellite and reducing the total amount of noise power that's entering. And so we step from this hopeless signal-to-noise ratio of 1 in 10,000, which we have absolutely no hope of decoding, to 1.26. So for every, say, watt of total energy coming into the box, we're getting about 600 milliwatts of signal and about 400 milliwatts of noise. That is just barely decodable. It's just enough. This works because of this double effect of the antenna gain. The next few steps are fairly unexciting, except for something called noise factor. And this is a problem for all amplifiers, but especially for low noise amplifiers. Nothing an amplifier can do can reduce the amount of noise. If you've got a signal that contains 9 watts of signal and 1 watt of noise, a signal-to-noise ratio of 9 to 1, then no matter what your amplifier does, your output can't have a better signal-to-noise ratio because any amplification it performs will amplify both the signal and the noise. But worse than that, most amplifiers will introduce noise themselves. That's called noise factor. And that's a whole lecture by itself, but it adds noise without adding gain. And so I sort of scoured the world to find someone who can do a 30 dB microwave preamp with a very small noise factor. And to get a sense of how small that is, compare it with the low noise amp on board the radio chip. This only provides 12 dB or 16-fold gain, and yet it quadruples the noise. And that's typical. To go and find an amp that can provide 1,000-fold gain and add only 10, 20% to the noise is a big deal. It's also an expensive device. It's a like $500, $600 device once it's landed in Singapore. So I raise this to make the point that it's not enough that we can resolve the signal. And it's not enough that we've solved the sky noise. We've also got to deal with system noise introduced by the components in the signal chain. And in this case, although the very expensive preamp only slightly worsened the signal-to-noise ratio, the one built into the radio chip quadrupled the noise. And on these numbers, it drops our signal-to-noise ratio from 1.12, which we probably can decode, to 0.32. That is, the noise is 3 times as big as the signal, which we can't decode. So at this point, we're like, OK, we give up and go home. Not quite. There are at least 2 interesting strategies to pursue here. The first is, let's go and get a dish. Increase, or 29 to keep the numbers simple. So let's go from 100-fold to 800-fold. Suddenly, our signal-to-noise ratio is looking much healthier, even despite the amount of noise gratuitously added by the low-noise amp in the radio chip. Unfortunately, as I said, dishes are a problem in this country, and the other strategy of using, what in this case would be 8 boxes, is complicated for reasons I'll get to the end. Mostly it's expensive, but there's another problem. So the other solution is the bandwidth. Rather than trying to land the entire 5 megahertz wide signal that the satellite is sending, we lower our sights a little and only take 1 megahertz. This doesn't affect, actually it does, but I haven't shown it. It doesn't badly affect, it allows us to detect the signal it's not wide enough to allow us to demodulate it. It's like standing outside a door of a nightclub. We can hear but we can't hear the lyrics and we can't hear the melody. So it's that problem. We've narrowed what we can hear. But at the same time, we've narrowed how much noise we're bringing in. And so it gets our signal-to-noise ratio back above 1, so we have a reasonable chance of detecting the signal. And so that's the point of the experiment. I'm not trying to demodulate, receive, and decode NASA's, in this case, it's not even the mission data, it's the telemetry tracking and control data. All I'm trying to do is detect the signal from the satellite and also measure its Doppler. So it's coming around the moon. As it comes towards us, its signal is raised. As it goes across, it's about the transmitted frequency, and as it goes away, it's lowered. So what I'm hoping to be able to do, if this succeeds, is detect that the signal suddenly appears when LRO appears in front of the moon, and the timing's public, that its frequency slowly drops, and then that it disappears when it's supposed to go behind the moon again. So that's the expected outcome of the experiment. Bit tight for time. Okay. But yeah, not trying to demodulate, let alone decode or receive. So where am I? I've got the coax has arrived. The low noise app is theoretically in Singapore in DHL's holding somewhere. So I should have it in the next few days. My Novena is working, except that I damaged the screen cable. So there's a bit of fiddling there. And I will shortly procure a cardboard box. Additional approaches. So I mentioned that I'm not using a down converter at this point. I'm starting with the sort of the purest, do a very low noise amp. However, adding a down converter adds another 1,000-fold gain, but also simplifies the coax and the losses in the front end of the radio. So this is a user more conventional convert from 2 gig to 300 megahertz type approach, which means one more device in the chain, but drastically simplifies the link budget. And the other is to use a much more sensitive spectrum analyzer. Get a lab instrument. These are expensive. They have to be paid money for and rented, and they can't be moved usually, which is fine. I can just stick the box out the window and point it at the moon, but I have to go and rent time in a lab somewhere to do it. But it's certainly an option. The other, I mentioned long-term averaging. Because I have knowledge in advance of the behavior of the satellite, I can, in principle, take signals over a long period of time. So even with like a 0.3 signal-to-noise ratio, I could, in principle, detect bias. It's not going to be perfectly uniform noise because I know something about the behavior of the satellite. So take several minutes data and sum it, and I can perhaps argue that successfully that we're seeing data that's consistent with transmissions from the satellite without actually being able to detect it in the usual way. However, if both of those fail, then sure. So, and this is two options really. One is to go to a 3, 4, 5 meter dish, which means I've got to go through all the regulatory hurdles. The other is an array of boxes, which I won't do because two problems. One, mixing is difficult. You have problems with the phase relationship between the boxes and you introduce a lot of noise in the mixer. But two, you need a preamp per box. So if I switch to sort of 8 cardboard boxes, I'm looking at about $5,000 worth of preamps. I didn't mind buying one because it will have application in future projects, but I'm not going to buy 8. So yeah, hopefully it doesn't come to this. Yeah, right on target. Right, brilliant. Questions? Brahim. Say again?
Before you preamp? Because
what are you going to mix?
If you have lots of noisy signal, if you average them, the noise will drop. So
but you've got to run. How are you going to get it from the horn to the preamp?
So we need to preamp before you mix them.
There's no transmission line. The preamp's input SMA connector is actually in the throat of the horn with a paperclip stuck in it. If you want to mix, you've got to put bits of coax. And every one of those introduces loss. And you're dealing with zeptowatts. I've got, what you gain in the multiple boxes, you'll actually potentially lose in the distribution network, let alone the noise that a mixer will introduce. I think it's landed, I expect $566. Yeah, so, just one. I've got about one more question.
Sure. Yeah. We have time for like a couple questions.
Okay.
So what do you expect to get from the signal?
Just a carrier. Because I've got to narrow the bandwidth to the point where I can no longer even demodulate the signal, let alone attempt to decode its contents. It really is just either the signal's there or it's not. And I know it's approximate frequency, so I'm looking for you sort of nothing, a signal, nothing. There's no way to even demodulate the signal. But further, as far as I know, NASA is not publishing information about the content, so I'm not in a position to decode it. So there was another one here somewhere. Yep.
I guess since we're using a cardboard box and trying to listen to the moon, which is relatively near, you don't have to be very accurate about where you're pointing the cardboard box.
Its field of view is about 15 degrees. So it's, yeah, there's a fair bit of play, but clearly the pattern is a curve. The closer to the center of the horn the moon is, the better.
So you also mentioned other projects like the IC3 satellite. So those are far further away. So and some of it involve transmitting a signal to them rather than reading. So I guess there's a huge amount of angular accuracy required. Yeah. So any idea of how accurate it needs to be? And
yeah, so in the Arecibo case, it's a 300-meter dish. I couldn't tell you off the top of my head, but I imagine it's like hundredths of a degree. And so they cheat a bit because they can't steer the dish. The dish is stuck. And the Chinese one that just started operating is 500 meters. It's also stuck. They just wait for the Earth to point in the right position. But what you can do, you've got a bit of wiggle room at the focus. And so, yeah, they've got a sort of very high precision way of controlling the beam between the focus and the dish in order to track. But yeah, to cover the distances that they covered initially, it's fractions of a degree. And yeah, I'm never likely to build equipment that accurate. Sure.
Yeah. So you talked a lot about satellites at the beginning, right? And a lot of them are well funded by governments. Do you know of any, because it's ham radio, right? So do you know of any satellites that are not government funded?
I haven't done a sort of exhaustive study, but it's generally a mix. So go back to Oscar 1, the device itself was built by amateurs in a garage and paid for by the people who built it. But the
beyond the exosphere, because you have unique rockets to
told you they got a free ride on a CIA rocket. Seriously. So it was like engineers it's a project called Corona, and it's NASA's most successful project ever. It was 130 something launches and 130 recoveries. And this is recovery in flight. So you've got a film canister falling through the atmosphere with a parachute and a supersonic aircraft that intercepts, catches it. Right? So this was a vitally important intelligence function at the height of the Cold War. And so, yeah, like whatever they needed to spend, they spend. And that's where most of NASA's money was coming from. But the satellite is the cameras are a payload at the top of a rocket. It must be actually symmetrical. Otherwise, the rocket engines can't keep the rocket straight. And so you add ballast. And so they're able to say, oh, well, instead of just putting in your rocks, how about this satellite, this transponder? And so that was the deal. They were able to, because they were the right guys, they were doing the engineering work for NASA and NASA contractors anyway, and they were hams, they were able to sort of make the argument that, hey, how about this as a ballast? No wonder. And therefore, they were able to get their ride for free. Right. They still had to deal with pointing and power, and that's a complicated problem. And so there's never been a success yet in getting to geostationary, but there are two projects that are likely to go into geostationary in 2018, and both of them are riding on the back of commercial satellites. So that the ride, the pointing, the power is provided by others. The amateurs are only providing the repeater. Bizarrely, one of them is the US, no big surprise. The other one's Qatar. Somehow, the amateur club of Qatar was able to persuade QTEL to carry a ham transponder into geostationary. And that's due for January, February 2018.
I'm afraid that's all we have time for, but if you have further questions, you can always look for Roland over lunch or break, assuming he doesn't want to run away from you at that point.
I'll be around, yeah.
All right, thank you, Roland. I noticed that some of the speakers like walking around, so if you do like walking around, this is the night to use. Podium's yours.
Hi guys, my name is Letitia and I'm actually a JS lead developer at Temasek Communications. And as you can hear, I'm actually quite nervous because this is my first talk. And I think I'm going to start talking about how I switched my role from an admin to a JavaScript developer. Sorry. I don't know who voted for me, but thank you, because this is not really much of a technical talk like Roland, who has a very awesome talk. Okay, so I'm going to start with my life story itself, that when I was young in secondary school, I really hated school because I never thought that school environment was conducive. It's kind of boring for me. And because of that, my grades are bad. And the only thing that I liked during school was just to doodle. And there, because of my bad grades, I couldn't get into music or any kind of arts course that I liked because my grades was too terrible to get in. So what can I do, right? So there was really no choices that I liked out there. And then I'm just like, whatever. So happens that my cousin actually just kind of like asked me, like, hey, why don't you try to take a diploma in information technology? And I was like, okay, because that's the only choice I have. There's really nothing that seems good. So yeah, I got into the IT course, which is cool, but after the first week of school, I kind of hated it because I really hated all the modules and everything that's related to IT. So I was like, I must graduate here as soon as possible because it's such a boring course. And then I really hated school. I really dread going to school. And I always take excessive toilet breaks and talking to classmates who happened to be in the course because they had no choice. Oh, sorry. So because of that, my grades are bad again. And I didn't attend the graduation because why would I attend a graduation of a course I hated? So then I had no choice again, back to the bad grades mood. And I wanted to try to apply for arts, but I realized I was too shitty to become an art student. So I was like, my mom was telling me, why don't you just try applying to get an IT degree again? I was like, okay, because I have no choice again. So then, of course, I got rejected. It's expected because my grades are bad. So I was like, I'm just letting fate decide wherever my life goes. So I had a resolution. I decided to get a job, to have a private degree in business because it's a cooler degree than IT. IT is like for the nerds. I don't care. But, well, I did a lot of job huntings. I sent out all my resumes. I was like, yeah, I'm so happy. But, you know, what happened? I got rejected by several of them. And one of them is just to promote and sell an Apple IT product. I was looking forward to it, but I got rejected. So sad. But I got a response from a startup, which I thought it was a scam. I was like, oh, this startup must be a scam because of like, oh, it looks so weird. There's only a few people. It doesn't seem like established, well-known company like Microsoft or any sort of that. It's like, oh, no, I'm not going to go there. But I was like, because it's my only last choice and the only one who responded, so I'm going to go for that. So I got the interview, and there was this guy, he's a British boss, who was just telling me like, the responsibilities that you have to do as an administrator and everything. And he talks about a story, a metaphoric story about a boat and a wreck and propelling forward, which I didn't remember because all my mind was thinking, I must get that job. And yes, I got the job, which I don't know if I'm really so happy about it, but I'm really happy because that's finally a job that I could get. But I was guessing the reason why I was selected because there was no other choices there. Life's so sad. So I had to do the basic administrator tasks where I do phone calls, handling of petty cash, organizing events, sending emails. But I think I really did a bad job because I could see frowning faces everywhere. Like everyone was like so unhappy and hear people whispering like, oh, this is not good, not good. So I was like, oh, so sad. So, oh, yeah, thanks. And then one time, somehow, my British boss asked me, hey, could you modify the website and manage the content of the HTML page? And I was like, okay. Of course, because the reason why I was selected to do that, because they had no much people. And then I managed to modify it by copying Stack Overflow. And, well, thanks to them. And thanks to the past where Blogspot, Tumblr was so famous, you know, it was an in thing to have one blogspot, one blogger and Tumblr like, hey, my blog, my diary is so cool because I made so much beautiful CSS and, well, they got it. But, well, it started to have more like, oh, wait, sorry. And then he started having more modifications he wanted, like the design layout, the theme modifications. I was like, okay, I have to modify it. And that's when I have to start learning programming for real because I need to modify PHP and HTML and CSS and all of this. Then afterwards, I had the current CTO who obviously gave me a base before last time because I probably was a terrible admin. He was like asking me, do you want to learn some programming? Again, I'm assuming that he asked me to do that because there was really nobody to take care of the website again. So I had to maintain the AppRTC, which is a fork of AppRTC. It's a website which is running on App Engine using Python, and a signaling server, which is used to relay information to people. So I was like, okay, because I have no choice again. It's my job, you know. And then I had to do a lot of Google search, experimental changes, and I always love to advocate Stack Overflow, you know. Stack Overflow is your best friend. Remember that. I was like, after a while, like, wow, technology is so awesome, and I had to learn about WebRTC. If you don't know what WebRTC is, let me show you guys. Oh, no, wait. Damn it. Hang on. Okay. This is WebRTC. WebRTC is actually a free open source project that allows you to communicate with each other on the browser. Video conferencing, which is cool. You can do a lot of stuff with that. And I thought web technology was awesome. My perspective towards technology started to change a little where I think that, wow, it's really so cool. I didn't know you can do so many cool stuff to help people. Damn it. Then one time, the JS developer left. And then, gosh, damn it. Then I was like, oh, can you handle the task she left? There's a JS book for you to help you. I was like, okay, great, thanks so much. And I got it. I have to do it. And then because of that, I had two tasks, which I was an administrator working, and I was a developer, where I had to send emails, arrange meetings, and another talking about the product UI, making a user interface for investor, and like integrating PayPal for our UI. And of course, because of that, I was stressed and I was like, I can't wait to quit, you know. I was so stressed. I really like take on cakes, coffee to like just calm myself down, try and do anything to do to calm myself down. But thankfully, they had new hires, engineers, admin, and a new admin. I mean, an experienced admin, okay? Not just the one that just randomly dropped out and they came in and get a job. And then I was like, yeah, finally. Which I started giving, oh no, wait. Then I started handling my administrator work to the experienced administrator. And finally, I get this official developer title. I don't think it's really official. Then afterwards, I started talking to the new hires and everything. And they talked about Scrum, Agile, Threading, UI, UX. I'm like, what the heck is this? I'm in a foreign land. Where am I? What's all this? And I don't even know, it's just new to me. And I was like thrown in this unknown world. And then I remember wanting to ask a guy, the server guy, about having to make a change. And he's like, oh, you want to change this? Just go to this file, go and modify it and push it to your branch. I was like, what's this? What do you mean by that? It's a Node.js server at that time. I was like, huh? I have no idea. And I thought it was going to be finally over until I was tasked, assigned to do and maintain a Skyling.js SDK. If you don't know what a Skyling.js is, it's just a platform for users to actually will allow you to use the WebRTC API, but we have a platform to allow you to do connections. That's what it was. I'm just talking about the product I made, which is really cool. But It's Jira, and I had to learn about Jira, Confluence, versioning, Scrum. I was like, oh, what's that? Cool, okay. Oh, gosh, okay. Then I had to learn about software development process, which at that time I kind of screwed up a lot of times. So, like pushing to the master branch is the best correct way to do it if you need everything done quickly. And then, what is peer review? You don't need peer review, you just need to merge it. Who cares about it, man? And I Jira, and the t-shirt size, and oh, what's all this? I don't know, actually, I have no idea. What is versioning? Just need an ABC. Why do you need like this 0.x something, whatever? Don't understand. And because of that, I made a lot of bugs, and then I have to learn about what is test scripts, what's QA validation, and what's testing. Again, also, I didn't know what it is until I had to learn from someone who helped me, tell me like, oh, you can use Karma.js or like Mocha or like, Selenium. I was like, oh, okay, but how do I set them up? And one time because of that, because I do not know how to actually do proper development process and everything, I actually pushed the master branch and made changes directly on production server, which kind of screwed up the website. And it was like, oh, not working, what's going on? I was like, sorry, And because of that, I feel really bad because I secretly felt very lousy because I was thinking, well, am I really a real developer? Because I just started. And it's easy to get discouraged because you can face harsh criticism from others that makes you feel stupid, actually. But then I understood it's not to be too hard to yourself because we all make mistakes. And it's part of a challenge of life. It's through mistakes you learn what you can do and what you should not do. And then you accept and learn to move them on, or else you will learn from them. You'll be fine, the flower. Then, because of that, I never stopped learning. I never stopped putting limitations on myself. Because the moment you limit yourself and you think you're not able, you'll never achieve what you want to achieve. So I always continue with this quest of always attaining more knowledge than I already know today. And because of this, in this 2-year span, I actually came from just modifying a website to actually doing a JS SDK that actually powers thousands of people's devices. That actually helps to connect different devices, like medical, consultation, group chats, Internet of Things. All of this can be done just within 2 years for never giving up and never putting limitations on yourself. And here's like an example of like you can join this room and do a GeekCamp talk, like example, like connecting to this. Let me try to connect to this. So you will be inside the conference, like I can show you. By the way, it's just gonna be a few seconds, so just sing. If you're not connected, don't be sad. It's okay. So if you connect inside this, you can see yourself in this page. Yeah, someone's connecting. Yeah, you can connect to this page. Hi, nice to meet you. You can actually start a video conferencing just from the web. It's like cool. Okay, I'm just gonna leave the page. Sorry. Okay, thanks. And you can see here's an example. Thank you so much. And it's an example like how you can use the Skyling SDK, which is the product I built. You can do like Internet of Things, where this is actually connected to a browser, using our Android SDK to connect, using the Android SDK to connect and move things around. See what you can build. Okay, it's ready. Let's move on. Yeah, it's over. Whatever that is. Oh gosh. Oh no. Ah gosh. Okay. And you see, there's so many use cases you can do with all of these SDKs and stuff. And I was like thinking like, wow, I didn't know I can build such a stuff. You can like so many use cases and things that you can help to build and integrate things for people. Which then tells me to the end, coming to the end, that a quote that's not from Albert Einstein, obviously. Everyone is a genius, but if you judge a fish by its ability to climb a tree, its whole life living is stupid. Obviously not Albert Einstein, because Albert Einstein never said it, but people use it every day. And life is full of possibilities that if you never try, you never know what you can achieve. Just don't limit yourself, you never know. And the thing that you think that you like may not be exactly the thing you like, or the thing that you think you don't like may be actually something you enjoy. So you can always try many other things, and you're like, oh yeah, actually I like that. Oh yeah, actually maybe I don't really like that. So that comes to the end, so hi, Huya. Thank you.
Do we have any questions for Letitia?
Sorry, really. Ding.
Yes, no. Questions?
Sure.
Not so much a question as a comment. You were copying sort of harsh criticism when you disrupted a production website.
Yeah.
When I was about 21 or 22, I managed to delete a production database on a Friday afternoon. And we didn't have a backup. So my entire weekend was spent manually rekeying. Fortunately, we had an audit trail, with manually rekeying an entire database of work in progress.
It sounds very fun.
Needless to say, I now have had automated backups ever since. But yeah, it's not an uncommon
Yeah, it's
experience.
really not a...
We all have that moment where we're ah! And then get more careful.
Yeah, exactly. When you're young, you just do stupid mistakes, and you're like, oh my god. Yeah. Okay. Any more questions?
Yeah. So also a comment further his point that more often than not, the team should say that how resilient is our production environment, right? Rather than blaming the developer pushing the master and bring things down. There should be a ping, there should be ways to check production environment that, okay, something's not right, let's revert. That's quite easy to do, right? So yeah, they should ask the question, not say, hey, blame the developer.
Because it's the easiest thing to do. Yeah. All right, is there one more question, please?
Yeah, first of all, I applaud your courage for telling us your story, especially and saying certain things about arts and IT in front of this particular audience is very, very courageous. But I have one question. So you found your love for software development, problem solving, right? And this happened when you're working.
Yes.
Why do you think you didn't spot this when you were studying? Is it a problem with the education system?
School, so every time you just go to school, you just copy the codes and you just like rely on the other teammates to help you achieve your goals, and you can continue doing other things.
Where goal means pass exam. Right?
Yes. You just need to memorize. Okay. Yes?
I'm going to change the track a little bit. I'm very intrigued how you actually done your presentation. I noticed you are using your mobile to control the slides, right?
Yeah, I was using a year ago, but I refreshed my page. So.
Right, and the
It's actually a kind of a controller that allows me to navigate slides.
So you're just using that to control your computer?
Yes, but halfway afterwards, like I think my connection got off. So I use manually the key.
But you can't really cute and stimulating slides. Are you naturally talented going into those things, or just help you?
I just draw them like just for fun. Any more questions? Yeah.
How's your remote control built?
It's using the same scaling SDK that I built.
Any more questions?
I assume no.
Well then, thank you, Letitia.
Everyone can go lunch.
Despise mirrored displays, but I think it's just easier for this bit. Okay.
obligatory 3 seconds of sponsors. 1, 2, 3. Okay. You know how Letitia mentioned that Stack Overflow is really useful? Well, there are some very useful things about Stack Overflow. This is an XKCD comic that you might not have seen, or you might have seen. It doesn't really matter. The point is not the comic. If you scroll to the bottom, Randall Munroe says, Stack Sort connects to Stack Overflow, searches for sort the list, and downloads and runs code snippets until the list is sorted. This might seem like a terrible idea, but as with all terrible ideas like JavaScript, someone has done it. So you give it a list, right, and you look at this amazing little output console on the right, and you try and sort it. There you go, your array was sorted. So Stack Overflow, useful for more than just humans. Also works if you use the API. Alrighty. Cool. That was Stack Overflow. Next will be noms, or as the more cultured among us might call it, lunch. Few things before you run out the door. Don't make me bar the doors or anything. Before you run out the door and have lunch, there are drinks in the fridge outside. Help yourself to them. There is coffee. Help yourself to the coffee. Don't steal it, because the people who run the coffee booth won't be happy about that. But just ask them nicely for a cup, they'll give you a cup. The other thing is disposal of stuff when you're done eating. I'll let Terrence handle that one, and then I'll come back for more stuff.
All right, thanks, Rahul. All right, so guys, I hope you guys are pretty hungry because I sure am. All right, so with regards to food, there will be pizzas that's made available right outside here. So if you go out from this door here, you will see pizzas, you will see a fridge for drinks. If you go from this door here, you will see pizzas as well. Alright, so good news, you have both sides to go to. Okay, vegetarian friends. Alright, we have vegetarian pizzas. You want to take the door over there. Once you go out the door, you head straight down, you'll see a very nice view of the city. You'll see a label that says vegetarian pizza, that's where you want to go. For non-vegetarian friends, you can go either doors. This way here, right outside there, you see non-vegetarian pizzas. Likewise, you go out there, you take a right, you'll see non-vegetarian pizzas as well. Alright, so with regards to trash, just wanted to ask for your kind cooperation as well. Please do not throw the paper towels and trash and paper plates into those bins there, because otherwise no one's going to clear it. It's going to smell on Monday. We have black trash bags that's put around the area near where the pizzas are. This is where you want to throw them. Alright, likewise for the coffee cups as well. And for even the drink cans, also put them into the black trash bag. That's where we'll clear at the end of today. With regards to food in the auditorium, yes, you can have them consumed here. You can drink your beverages here as well. But please do not leave any trash behind. I would really appreciate that.
If you drop a slice, we're making you clean it up.
Yeah, otherwise,
just so you know.
Just kidding. But yeah, please don't leave any trash in this room here. Alright? Otherwise, the poor guys, later we have to clear it up. Please do take your trash, put it in the black trash bins as well. Alright, with that, I think...
yeah, the only last thing is that to try and avoid a massive queue for pizzas, because that's what everyone really cares about, we've tried to spread out pizzas in multiple areas. So try and find somewhere that has compatible pizzas for you. And if you eat meat, please be nice to the vegetarians. They can't eat your pizzas, you can eat theirs. We don't want to have to make you regurgitate pizzas or anything. So be nice, eat pizzas. There should be enough pizzas to go around. I think at last estimate we have 1 pizza per person. But it may be off by a tiny bit and they're not very large pizzas, so please don't eat 2 entire pizzas. Someone's gonna starve if you do that. It will probably be me who's starving, so unless you want me dying over here on stage in public, don't. Yep, with that. Food's outside, drinks are outside, food's outside that way, not much drinks outside that way. Go!
And once again, you see any entrances with a glass door, please don't go through them, otherwise you'll get stuck there. Alright? Thank you, have a good lunch. See you back later.
Right, one quick thing, if you are wondering what time you should be back in here, that is 2 o'clock.
hard NDA or not NDA. And the reason for the TV was once one of those four has signed off, then you get one hand did get into a license. So he got ideation license, so it's part of that license. His landlord all he went to do. So we bought the dish, set up. And within a couple of weeks, IDA's got a right to him and said, we're really sorry, we have to withdraw your license. And the problem was that it was a residential building. So someone has called MBA reporting illegal satellite dish. And so MBA's dilemma is they can't be seen not to enforce the law. So despite the fact that it was not a TV installation, in fact they have a license clearly in their hands.
So it looked like a satellite dish, so they...
Well, it is a satellite dish. In fact, often satellite dishes are just second-hand TV dishes. And so it's like, oops. So the solution in his case, because his employer was a he was going to sign off. So he obviously doesn't give his employers good industrial building. He signs off, so MBA signs off, so IDA signs off. But it's that level of regulatory complexity that I don't particularly want to go into. There's not much risk of anybody bringing MBA or IBA complaining about an illegal cardboard box. And in any event, a cardboard box is not useful as a long-term satellite dish because it's not rainproof. So it's not an engineering problem. It's a sort of hack to work around a not even regulatory but a public perception problem. Yeah, this is not a dish. This is a cardboard box and some alfoil. It's like something you'd see in like the fact that it can receive comms from the moon is neither here nor there.
So you need a license for any kind of satellite dish anywhere at any time?
It turns out the effective answer, given what happened with this ham, is in practice every satellite dish in Singapore needs an MDA TPR license. Which in practice means every dish.
Yeah, and directional antennas just aren't covered because they don't
look like dishes.
Yeah.
It's not enough that justice be done. Justice must be seen to be done, and it's the same problem. It's not enough to
cares about justice being done, right?
Well,
What matters
in
is,
some cases,
does it
it's
look
only
like,
what matters.
Does it look like you're doing something?
But the same for law enforcement. It's not enough to enforce it. It's just going to be seen to enforce. So MDA can't be seen as going to one eye. So that's the regulatory
But
problem.
on the other hand, like if you're clearly not receiving television, like I know the cap out.
But MDA is not interested in having now.
Yeah.
But yeah, it's a couple of boxes. No one's going to mistake it. And in any event, you can't install them locally. It's the way it works. So it's a neat way of getting around the problem that MDA has with being seen. So that's the theory. At some point, you say, no, you can't use cardboard boxes.
No, right? Like nobody tried it first.
Well, but bear in mind, I mean, everything we do is subject to IDA license anyway. So it's, if it creates a problem, then you can reasonably expect to get a left line case. You have to stop now. But that happens. They are so busy they don't even.
But I think it's like the problem is that in like getting permissions for listening on the spectrum or something like that's kind of you just can't have the dish and.
Well, it's even beyond that. I mean, I sort of wrote to IDA to let them know what I had in mind, to ask if they felt that this is something that I needed permission for, and if so, what has to happen, which is like they're dealing with the licenses, they're dealing with the IDA and INDA. It's like, yeah, we know who the hands are, we know where they live. They've gone through significant hoops to get their license in the first place. They're not fiscal, so who cares? As long as no one's complaining, they would rather not spend any time on it. And it's a managed problem, right? It's the same 3 people, 4 people who deal with the telcos.
Yeah.
So the telcos are issuing checks on tens and millions of dollars for spectrum use. And we're paying runs for phone devices and field analytics.
In all Singapore.
And so, you can see why they might not be badly enthusiastic about dealing with this. It's not bad, they don't dislike it. They know we're sort of pretty serious about what we do, but it's like, please don't take complaints. It's a bit like the thing with the Apollo thing, where FCC's attitude or that NASA attitude was, amateurs are listening in, it doesn't really matter. The concern is that it's recording or production. And partly because there was no security. So there was an agreed score in the room at mission control. And so there was an agreed phrase, I forget what it was, that was in fact a crew member asking for a confidential medical conference per score. And so after this happened about 3 times, one of the gentlemen was like, this, whatever it was, is that actually, and yeah, it's the only time that the professor asked to leave the room. So there's nothing else going on that's military in the rocket programs, yes, not at all. And so, yeah, the journalists sort of guessed the NASA stuff, yeah, that's in fact what's going on. And they're like, yeah, okay, that's cool. So, for that reason alone, it's a problem. So legally that's not fancy, but that's not what that's not going to do. But it's much more matter. Because if we're not creating complaints, and if we're not protesting against what we're doing, okay. So I'm not really happy about it. I dislike. Effectively having to operate slightly outside the way the law is written. I'd rather they wrote the law that sort of matched the conduct that was expected. Essentially, the work rules match pretty closely with expected conduct. But so it's interesting. Very nice thought. Did the maths make any sense? I decided it's a technical crowd. I'm going to risk the middle 8 minutes of the talk dealing right in the guts of fickle power. But there's only one other person who I know has the technical to do it. She's on. Where's Sandy? But she was more, did it make sense? Fear is always sort of running away with some insane technical topic. Right, you will, yeah. That's what the spec sheets say. What it actually works, God knows. Yeah, pizza, what you?
Yeah, I have heard it's horror stories that try to use, but it's basically vendors selling amplifiers that almost work or work and then they explode, which is so much fun. Well, I think just blow out the fuse, right? Which is so much fun when you put it in a case and put it somewhere. I don't know, maybe somewhere very far. Anyway.
Orbit.
No, orbit. No. I mean, it's just ground station.
And a friend here who does satellites for a variety of research purposes ran up against this with they're buying modems, and for South African companies they have this nighttime modems. So he's buying from a South African manufacturer, which is fine. Their gear is reliable, but it wasn't working. They're like, is there a problem with the software that we put into the USRP on the ground side, or is the satellite side modem not sending properly? And this is 6 weeks before launch. We might not have the S-band down. They had a UHF down as well, but the S-band down has much more bandwidth to bring down images. And they were looking 6 weeks from the launch. They were looking at a very real possibility of not having a working broadband downlink.
And then it's somewhat working here.
Yeah, it's Microspace Rapid. This is the second satellite, and its purpose is low light. So it's not infrared; it's visible light, but nighttime. So yeah, you won't talk about it with customers, but it's not hard to guess who it might be. But so yeah, it's a satellite this big, and my big fear, the one I didn't talk about, is the side lobes. The amount of noise at 2.4 gig is enough that often in office buildings 2.4 gig is not useful for Wi-Fi. You just move up to 1.5 gig. So I'm a bit concerned that my box, if it's anything other than pointing straight up, is going to have side lobes that are bringing in 1,000 Wi-Fi devices, which will of course. Oh, more shielding, but more like a sort of giant ball.
Yeah, the giant ball. Yeah, apparently it helps a lot for focusing.
I think it's certainly for isolation. Not so much the focusing is a different question, but it's the isolation. Yeah, if I could find,
like an aperture or something, right?
if I could find, I don't know what I could reuse. There's something I could repurpose that way. But all I need to do is prevent anything in about that cone from being received by the preamp.
Or you could just make it up glowing or something.
It's certainly an option. You can try. I'm going to get some pizza.
Roland.
Hello.
If you're looking for pizza, you might have to wait for a little bit.
Oh, there's still a queue?
We have a second batch incoming, but we're out of the current set of pizzas.
Jesus.
People just
The locusts have arrived. Okay, in that case, I shall go and get some coffee.
Probably a bloodbath out there by now.
Yeah, there are people trying to eat each other as we speak.
That's certainly one of the options. It works for locusts too.
Yes, it does.
Hi, I'm Dr. Farni and I make Nixie tubes. I discovered Nixie tubes in 2011, and when I found that these beauties were no longer in manufacture, I decided to try to make it myself. I had no previous experience with vacuum technology, so I had to learn all myself. I started collecting vacuum pumps, playing with glass and burners, making glass-to-metal seals, and exploring gas discharge. I soon moved to a garden shed I built to accommodate all the equipment I collected. In 2 years, I had a working prototype and made a 2-tube plot for an art exhibition in Shanghai. It took me another 2 years to transform the Nixie tube prototype to low-scale production. I needed more room, so I moved from the garden shed to the local castle. That enabled me to build cleaner lab and finish the production equipment. New vacuum pumping station, induction heaters, glass working equipment, and so on. I also hired first employees to help me with the manufacture. In 2016, over 4 years from the start, we finally have steady low-scale production, and it seems that we succeeded and have revived the Nixie tubes. Thank you for attention, and now enjoy the video.
Yeah, Sector 7. It's like one of those good process DSMR. Yes. This is like perfect for breaks. Sort of like, yeah, perfect. Yeah, I think it's better for later one because you talk a lot. Or unless we need to like mute that. The stage talk at the start. And then actually it's pretty clear as well.
it's an idea of how they make Dixie tubes. If you don't know what Dixie tube is, you should Google it. They're pretty cool.
They're like LED displays, like
Old school.
old school.
Very
Real.
From like 70s.
Wow. Does the Dixie tube block?
Yeah. So back when you didn't want to have transistors, and you just choose a
Did you ever wonder why, in North America, televisions run at a frame rate of 29.97 frames per second? I mean, what a ridiculous frame rate. I came across the inconvenience of this number recently when I was making a video and I was trying to manually assemble some frames back to some footage. And it got me thinking, where did this come from? And I couldn't find a nice, coherent, concise explanation online, so I had a bit of a dig into the technical details, and I thought I'd make a video explaining how this came to be. It comes down to how these old CRT screens used to work. At the back is a cathode ray. It sends a beam of electrons forward. Wherever they hit the screen lights up, and then electromagnets back here can steer that dot around on the screen. To produce an image, you need to scan it across the screen. And if that dot is small enough, and if the dot is moving fast enough, you can vary its brightness. And because of the way the human eye works, it will perceive the brightness as an image. And so as you can see here, a rapidly scanning dot is producing a picture of me, and then another picture of me. In fact, there are infinitely many of me. That is pretty good value. The electron beam didn't actually do the whole image in one pass. It took two passes. The first pass, it would put the top row in, and then every second row all the way down, the odd positions. It would then do a second pass and fill in the even positions. And this is what's called interlaced video. Because of the human persistence of vision, we wouldn't see two different passes. We would just see the complete frame. And in North America, TV was broadcast with 525 horizontal rows, which you may have noticed is an odd number. Each pass of the beam would do 262 and a half rows. The weird half thing was because of the geometry of how the beam gets back to the top, and you want to take the same amount of time for both of the passes so everything stays in alignment. But that's the basics behind interlaced video. When TVs were first built, it would have made sense to do two of those passes 24 times a second to match what cinema movies ran at. They were 24 frames a second. However, these home appliances were plugged into the normal household electrical supply. And in North America, that's alternating current running at 60 hertz. So to make them easier to build and to avoid interference with other things, they used the electricity to time the scans. And because it took 2 scans of the beam for every image, it meant your TV was running at 30 frames a second. What a perfectly logical and sensible frame rate. The problem was with the introduction of color. The 30 frames per second system was for black and white TV, and in 1953, color TV hit the airwaves, and that ruined everything. TV in the 1950s was sent as an analog signal over radio waves. Each TV channel was given its own spot in the electromagnetic spectrum, specifically a 6 megahertz window to send all of its data. Now, the first quarter of a megahertz it couldn't use because it's kind of wasteland, a buffer between channels. It couldn't really use the next 1 megahertz either because it was a build-up to the picture signal. After that, you get all the interesting data about the picture, and finally, 4.5 megahertz later, you get the audio signal, and then after that, another wasted quarter of a megahertz of wind down. Then above that, you would get another wasteland and the next station above it. They were packed in fairly tight. So in reality, each channel didn't get 6 megahertz. They just got this one 4.5 megahertz gap to send all of the image and audio data. When color TV came along in 1953, the color data had to be put somewhere in that 4.5 megahertz window. But it needed to be positioned carefully so it didn't disrupt the pre-existing picture and sound information. It looked like this was going to be a major problem. The color signal did interfere with the picture and sound signals in a way that produced visible artifacts. It was distorting the picture, and that was not acceptable. So the technicians had to find a way to fix that. And thankfully, there's a thing called line-by-line phase reversal. Even though I don't fully understand how that works, I do know what the criteria are to be able to use it. And it comes down to the 2 gaps. The gap between the picture frequency and the color frequency, and the difference between color and sound. In order for line-by-line phase reversal to hide the artifacts, both of these distances had to be an odd integer multiple of the horizontal frequency divided by 2. The horizontal frequency is just the number of horizontal lines being drawn every second. We know that if you add these two differences together, you get the complete 4.5 megahertz window for the entire signal, and we can now do some simplification. Well, we know if you're adding two odd numbers together, you're going to get an even number out the other side. We can move the half over there, and if you half any even number, you're just going to get some integer. And so the moral of the story is that we need an integer multiple of the horizontal frequency to equal our total interval of 4.5 megahertz, which is, of course, just 4,500,000. Well, let's see if it works. The horizontal frequency is equal to, well, every frame is 525 horizontal rows, and we're running that at 30 frames per second. If you multiply them together, we get 15,750 out the other side. That is our horizontal frequency. We can then try dividing both sides up here by the horizontal frequency, and we hope to get an integer out the other side. Very sadly, we don't. We get 285.714 and then a bunch of other digits. And the poor engineers must have been like, oh, that's so close. Imagine if that was 286. That would solve all of our problems, but it's not. For that to be 286, we would need a different horizontal frequency. In fact, we would need a horizontal frequency of 15,734.25. And we haven't, well, we would have that if instead of a 30 frame per second rate, we had a, you got it, 29.97 frames per second. And so that's what they did. They adjusted the frames per second to make this number here an integer and remove the interference between the new color signal and the old picture and sound signal. So there you are. North American television has a frame rate of 29.97 frames per second, because if you multiply that by the number of horizontal rows in each frame, and then you multiply that by an integer, happens to be 286, you get out a whole number which matches exactly the frequency window this data is sent to. This system of broadcast is called NTSC, and it was put in place in the 1950s by the National Television Systems Committee. And so now you know what NTSC stands for. It stands for not the smartest choice. Surely there must be a better option than 29.97. Well, let's have a look what happened in Europe. Europe has PAL television that's based on a 50 hertz power supply, and so at 2 scans a frame you get a 25 frame per second rate. PAL has more horizontal lines than NTSC. It's got 625. Whenever you have someone going on and on about how PAL is better quality than NTSC, it's because it's got an extra 100 horizontal lines. It has technically got better resolution, and in Europe there's a slightly bigger window to send the data off. There's actually a full 6 megahertz window just for the data that's actually sending the TV signals. So the PAL technicians must have been thinking, oh, come on, how close are we going to be to an integer multiple? And it turns out exactly 384 precisely. And you might think, wow, they got lucky, but in fact, this was deliberate. PAL came into place because of color television. Europe had a look at North America and went, what a mess. Let's just do a new system from the ground up and make it work. And that's why in Europe to this day, we have a nice and tidy interlace standard, whereas in North America, it's this ridiculousness. The question now is, was there a better option? Instead of changing the frame rate, what if instead they changed the window over which the data is sent? What if they just moved these out slightly to make these integer multiples? Unfortunately, that wasn't possible. The standards for this were immovable. They were not allowed to go outside of that 4.5 megahertz range. The only other thing they could change would be the horizontal lines. And this, in my personal opinion, is what they should have done. So let's say we want to keep the frame rate at 30 frames per second, and we're going to change the number of horizontal lines. How many are we going to need? Well, assuming we only want to increase the number of lines, we don't want to decrease them and lose quality in the new standard, and assuming we still need an odd number, so we get the half line geometry for the beam's movement, then the next compatible number of horizontal lines above 525 is 625, with a nice multiple of 240. Yes, the NTSC standard could have been the same number of lines as PAL. We could have had two much more compatible standards if they had changed the horizontal lines instead of three. But they didn't. They changed the frame rate instead. We've been stuck with this ridiculous number ever since. Although we can't be too harsh in judgment, their motivation at the time was to make the transition as smooth as possible, and by slightly tweaking just the frame rate, this was very backwards compatible. Almost no one would notice this change. Their theory was, if they do their job correctly, no one would be sure they had done anything at all. The final moral of the story is just that conventions hang around for a very long time. Because of human nature, we can't have abrupt changes in technology. People need to do transitions from one to the next. Standards have to be continuous, for some definition of continuous, and that makes them incredibly tenacious. Now, I know a lot of people who watch my videos work in the tech sector, and you're responsible for coming up with standards and conventions. And a lot of young people watch these videos. You're going to come up with the conventions and standards of the future. So all of you, please, when you're coming up with new ideas, just spare a thought that your grandkids may one day still be locked in to the same standard. Although that said, I still got my video made despite having to deal with 29.97 frames per second. If you're curious, it was the one I did with Henry Segerman with the spherical cameras, because we had to export all the frames, mess with them in Python, and then put them back together. I'll put a link to that video in the description. So, you know, people come out with conventions. I guess, actually, we don't care. A convention that exists is better than something that doesn't. So if you can bodge it together and it works, go for it. I mean, don't worry. The people of the future will find out a way to deal with it. Okay, according to my YouTube statistics, at this point in a video, of all the people who've watched it, only 30% of them are still paying attention. Most people watch the interesting bit, and then they don't pay attention when I'm just rambling on at the end. And so those of you who are still paying attention, you are my people. And so I have a special announcement just for you. You're all incredibly supportive, and what people have asked, when am I going to set up a Patreon page? And I've finally done it. I have set up a Patreon page, and this is kind of a soft launch. I'll do a proper launch later, and I'll follow Patreon good practice by having a video about what I'll be doing. But for now, I thought I'll just mention it at the end of this video. If you'd like to, please do click the link in the description. Go and check it out. If you're not familiar with Patreon, you can support me a bit like you would a Kickstarter, but it's ongoing. The idea is people who can afford it donate money so I can do these videos better, and in return I have all sorts of rewards. So have a look at it, give me some feedback, let me know if there's things there you do want, things there you don't want. I'm going to have fun making a bit of extra content for Patreon. In fact, I'm going to do a behind-the-scenes video of this video I've just made, because you wouldn't believe the ridiculous tech around me it took to make this all work. And because I haven't got any Patreon supporters yet, I'm just going to put it on my Patreon channel, and anyone can see it. So do go check out my Patreon. The link is at the very top of the description. Unsurprisingly, I would love to make more videos and do them better, and so your support is hugely appreciated. So go check it out. I would love some feedback on it before I do the proper launch. Let me know if the rewards are what you want, or if there's anything else I can add in there for you. I really appreciate you all supporting these videos.
you to go and meet this guy. He's damn funny.
Okay, yes, sure.
I'm sorry, I didn't need it.
Say those smartwatches as well. Good fun.
Never, it's okay.
Sort of Zen. So, I look forward to well, the other thing is, for this digging into the hashtag was intentional. From an art science audience, I might just skip that slide.
So a quick reminder that if you would like to win one of these lovely little headphones, you should follow the URL that is on the coffee cups. If you don't have a coffee cup, I'm sure there's a bunch in the bin, I guess. But no, more seriously, it is pnd.ly/devcoffee. Just seriously, go find someone with a coffee cup and read it out loud, it's easier. Alternatively, if you don't want to go there, you should either tweet or make a post on Instagram with the hashtag BandLab and the hashtag GeekCampSG, and we'll pick the ones that we thought were the best polls. And you get headphones. Before we start with our next talk by Shippen, you can eat in the venue. If you're hungry, feel free to go out, grab some pizzas and come in, not during the talk. So if you want to go and ask about the time, or between talks, it's a good time. There's also still lots and lots of pizzas, lots and lots of drinks. Help yourself. And that's about all I have to say for now, so Shippen, take it away.
Hello? Can you guys hear us? Okay. No. So, let's get started. Okay. Let's start. Okay. Hi everyone. I'm Shippen. I'm a software engineer at PayPal, and today I'm going to talk about create a 3D game engine for Pebble so that developers can create 3D games for Pebble Watch easily. Apparently this is totally not related to my job at PayPal. It is something that I personally find very interesting and feel worth exploring on. So I got my Pebble Watch around 1 year ago, 1 year and 1 day to be exact. I saw this from my Facebook timeline yesterday. So at that time, my wife bought me this Pebble watch as a gift. It was awesome. And the watch has a color display, which is always on. And there's an app store for it. You can download a lot of apps on your watch. And the battery lasts for 5 days. That's actually very good. Not like you have to charge your watch every day. That's kind of painful. And personally, I'm very into 3D computer graphics. I have developed some games before for both PC and mobile platforms. And after I have the Pebble watch, I was thinking, hey, how about create a 3D game engine for Pebble so that others can create 3D games for Pebble. That sounds interesting. So 3D game engine is still some concept that's kind of blur. So what we really need to do here is these 3 things. First, 3D games are basically showing you a series of 3D images. So first, we need to create a generic way of rendering 3D images for Pebble. Second, it needs to be very flexible. So developers can create game logic, their rendering logic with this platform easily. And last one is high frame rates. For PC games, it's usually 60 FPS, but that might be a bit hard for watch, but still we want to have high frame rates. So these 3 we want to do. And this is what I am trying to achieve here. Basically something like this. But obviously it's a bit too hardcore for a watch. And what I end up creating, it's not this good, but something similar. And I will show you a quick demo for it. So before I go to the demo, let me quickly explain what I'm going to show in the demo. So this is a 3D model, a car. And the model it actually looks like this. And what I want to do is I want to display this 3D model in my watch and make it rotate. Basically, that's about it. It's not really a game, but it's more about demonstrating the concept that it can be extended to a game. And this 3D model is OBJ file. If you look at it with the text editor, you will see that the 3D model itself is actually a list of 3D coordinates, vertices, points like this. So what we need to do here is we need to render this list of vertices on a watch. So that's what we try to do. And let's go back to the demo. So this is the main menu for the watch. Everything here are the apps I have installed on my watch, and Pebble 3D is a demo I created. Now it's loading. Yeah, and this is what I achieved for, it's pretty cool, huh? The graphics is still very simple, but it is something very interesting, I mean, on a watch. But this video from here is actually fast-forwarded a little bit. The actual speed is not so good. I'll explain more in details later. Okay, so basically this is a demo. We want to design a 3D game engine for Pebble. So usually we need to start with hardware specs. And here, let's review the hardware specs for Pebble Time first. Pebble actually have several versions, and the one I have is Pebble Time. So I go with this one. First, the display. What I really like about Pebble is it has a color display which is always on. That is very important for me. So for the display Pebble has, it's actually support 64 colors. It's a e-paper display. and the resolution is 144 by 168 pixels. Let's look at the processors it has. The CPU for Pebble is actually a STM32. That's actually one of my favorite processors for embedded systems as well. It can run with 180 megahertz, but for Pebble, it limits it to 100 megahertz because I think there are some constraints on the battery. There is also a Bluetooth module for it. And what really surprised me is that it actually has a FPGA chip on it. Anyone know what is FPGA? Cool. So I didn't really look at the specs for the FPGA chip, but judging from the name, LP1K, I think it should have 1,000 slices on it, which is quite cool. Pebble is not open source, so I don't really know what they're doing with the FPGA, but it really surprised me. And no surprise here that it doesn't have a GPU or a graphics card, which I don't think any watch will have that, but it's not an issue for us. We can still build our 3D engine even without a graphics card. Okay, so next we have look at what the hardware specs we have, and next let's look at the software specs. For Pebble, they actually provide us a lot of APIs that we can use. Basically two types. One is watch-side APIs. Basically, you write the programs, and these watch-side programs will run on your watch. And there's another part which is phone-side APIs. So using these APIs, you can write the app runs on your phone. And the watch-side apps and the phone-side apps, they can communicate with each other through Bluetooth messages. For watch-side APIs, they have C. So you can write apps in C, and they will run on your Pebble watch. And they also have JavaScript API. So it's not really JavaScript, it's JavaScript. Basically, it's JavaScript for IoT, which is designed by Samsung. And there's also phone-side APIs. So so this code will run on your phone, basically. They have JavaScript version, iOS version, Android version. Pebble also has a cloud IDE, which is very simple to use. You don't really need to install anything. Go to this website. You can just create an app there. And it's really amazing that there's a run button. You just click the run button. It will open an emulator inside the browser. And you can see the result in real time, basically. That's very cool. But sometimes this cloud IDE is not very stable, so there's also local version. You can install the Pebble SDK on your local, and it will work as well. So I'll just quickly show you how to run it on your local. So it creates an emulator here, installing the app, and it's running. Yeah, this is the same result as you see just now, but it's running in the emulator. This is a little bit bigger than the previous one, but okay. Okay, so we already know about the hardware specs and the software specs. So let's design the 3D game engine for Pebble. And before we do that, let's review our goals again, just in case if we forgot anything important. We need to have a generic way of rendering 3D images. It should be flexible, and we want to have high frame rates. And to do that, we can do it in two ways. Just like what Pebble APIs provided us, we can have the phone-side rendering or watch-side rendering. So for phone-side rendering, what we're doing is we create some app on your phone, and that app will read all the 3D vertices and generate a 3D image for you, and send the image over to a phone to display. That is pretty straightforward. And there's another way you can do this. It's by watch-side rendering, which you need to send the 3D vertices to a watch, and your watch will process the 3D vertices and generate the 3D image from these vertices. Both ways should work. And before we actually jump into these implementations, there are something we should know from this. So for phone-side rendering, it's obviously your phone has more computing power than your watch. So the rendering image on your phone should not be much of an issue. But for sending image over to watch to display, that part, we might have some issue because it's using Bluetooth, and Bluetooth is not famous for high speed. And rendering on your watch side, there might be some limitation on the vertices because although Pebble has a very powerful CPU, for each app you only have 24K to program. So that's actually a limitation there. So let's look at phone-side rendering first. So what phone-side rendering does is actually something like this. We have the 3D model on your phone, and the phone reads the vertices and renders the 3D image, and then we send the image over to your watch to display. Basically, these 3 steps are pretty straightforward. And let's look at the Pebble display again. We already know that it is 144 by 168 pixels. For each pixel, it's actually represented by a byte, and a byte is 8 bits, right? And for these 8 bits, they have 2 bits for red channel, 2 bits for green, and 2 bits for blue. So 2 times 6 is 64. So that's how it supports 64 colors. And there's also 2 bits for alpha, but it's not used in Pebble actually. So let's do some calculation here. Each pixel will take 1 byte, and 2 bit red, 2 bit green, 2 bit blue. The display resolution is 144 by 168. So 1 image frame will actually take around 24 KB, which doesn't sound like a lot of data to transmit actually. Just 24K, how hard is that? And let's look at the Pebble Bluetooth module again. It has a TI Bluetooth module. It supports both Bluetooth 2.1 and Bluetooth 4 LE, but the BLE one is just for notifications. So we cannot use it for our use case. So we need to use a Bluetooth 1.1. And for that one, the max data rate is around 3 Mbps. So let's translate that to KB. So that's around 360 KB. But this is like the maximum value because in the data rates, the bits are not just the information you need. There are also information for checksum or baseband encoding, stuff like that. So not every bit you can use, but maximum it should be 360 KB around that per second. And 1 image frame, we already saw this previously, that's 24K. Hey, great, we can get 10 frames per second. That's actually quite okay for, not so okay for a PC game, but it should be okay for a watch game. So I implemented that, and when I launched the app, this is what I got. Actually, it's stuck here. It's not moving, and there is actually a function in Pebble that you can determine what's the maximum buffer size that you can send through Bluetooth within one message. It says 8K, but I tested it. Maximum I can send is just 1.8K. Might be something wrong with their Pebble OS, but it's not open source, so I don't really know. I mean, nobody would know what's happening there unless you're from Pebble. Yeah, that's a bad part about it not being open source. So what I have to do is something like this, kind of painful. So I have to send one image frame in 14 messages. So you see the blocks here, the red one, green one. So each time I can just send one block to the watch. And each time I send the block to the watch, after receiving this block of data, they will increase some counter and request the next block from the phone, and the phone will send it over. And repeat this process for 14 times. We get one frame of image, which it's going to be very bad. But how bad it is, let's see. Okay, so I already talked about the sending image to your watch, this part. The next part is actually 3D rendering. So somebody needs to render a 3D image for us, right? So we need to do this 3D rendering part. I'm using PebbleKit.js, so it's basically JavaScript that's running on your phone. Beside the pure JavaScript part, it also has some extensions on it. It supports things like WebSocket, HTTP request, geolocation, and local storage. But again, no surprise here, it does not support WebGL. So without WebGL, how do we generate a 3D image with JavaScript? Actually, that's also fine because we can create our own WebGL with pure JavaScript. It's actually not so hard as it sounds. So let's look at this dolphin. It's a 3D dolphin. It's 3D bottom, basically. So if we look at it closely, we'll see that it's not a dolphin. It's actually a group of triangles. So let's say if we have something really complicated like this bunny here, if we want to show this bunny in 3D, but we only have triangles, what we can do is we just keep adding more triangles to it. And if we have enough number of triangles, it will look like a realistic bunny here. So that's the same thing we're going to do. For the 3D renderer we create, we actually just need to have one function to draw a triangle, and with that we can do everything we want. And although these 3D models are in 3D, but our screen, our display is always in 2D, right? So ultimately, every 3D triangle will be mapped to a 2D triangle. So actually, what we really need to do is to have a function to draw a 2D triangle. That's pretty simple, right? And that process is called rasterization. I won't go into details how to do it, but basically you have a 2D triangle here, and you want to draw it on the screen, but your display are created with these pixels, right? So basically, you need to have a function to draw a triangle into something, map it to something on your display. That's all we need to do actually. And let's say we already have this function to draw a 2D triangle on your display. Well, the rest we need to do are very simple. So here is a graphics pipeline that normally all the 3D applications will follow this way, and same for the 3D renderer I created for Pebble. So it's a graphics pipeline like this. First, we have a 3D model, right? And the 3D model will be actually a list of 3D triangles. And then there's some processing on each vertex. And we map it to a screen space, which is in 2D. And after we have that, we draw this 2D triangle onto the display. Basically, that's all we need to do. And if you're familiar with OpenGL, actually the vectors processing part is also called vertex shader. And the fragment processing part is also called fragment shader. Okay. For texture part, I didn't include it in this demo because Pebble Watch, it only supports 64 colors, which is not so colorful. So I didn't include texture in it, but I have a demo with textures with JavaScript here. It's actually a previous talk for a JS talk, and thanks to Engineers.SG, they also recorded it. So if you're interested, you can check this link out. And yeah, the size here is actually the same as Pebble Watch, but this one I added the texture into it, so it looks better. But ultimately, it's the same thing that I have on the watch. Okay, so now let's look at the performance. I've added some logs to the rendering and the sending data over part. As you can see here in the red box, the 3D rendering part actually just took around 240 milliseconds, which is still okay. But sending the buffer over, it took 8 seconds. So it means that if you're playing a game with this system, you need to wait 6 seconds for each frame update, which is not really tolerable. And this is tested with real device, with iPhone 6s and Pebble Time. So how can we improve this? I think there should be better solutions than this, but the most straightforward way would be just reduce the image resolution, right? So originally, we are sending an image with a resolution of 144 by 168, and that would require 24 KB of data. So let's reduce the size. If, let's say, reduce the size to 36 by 42 pixels, what the data we really need is just 1.5 KB, and that's less than 1.8. So yeah, so after reduce the resolution, we can send the image in one message, which is great. But because of the resolution is so much lower than previously, the image won't look as nice. So here's a demo recorded in real time. So there's no fast forwarding for this. It looks like this.
Yeah. It looks like something from Super Mario because it's very the resolution is very bad. But the performance is much better for 3D rendering part because the image size is reduced. It takes less time to render the image. Previously, it's 240 milliseconds. Now it's just 130 milliseconds. And for sending the buffer, previously we need to do it in 14 messages, and now we can send everything at once. So the sending image part, it will only take around 400 milliseconds. So overall, we will get something like 2 FPS, 2 frames per second, which is not that good, but still okay for a watch game, I guess. Yeah, but again, the result will be not so good as the previous one. On the left side, it's with full resolution. On the right side, it's reduced resolution. You can see the difference, and here as well. Yeah, but yeah. Okay, so next, watch side rendering. I didn't really have enough time to finish this part. I did some experiments on it, but it's not finished actually. So like I mentioned before, Pebble, they also support JavaScript running on your watch side with JavaScript support. But the JavaScript is not running very well actually. The performance is quite bad. So when I port my phone side code to watch side, it compiles, and when I run it, I always get these memory warnings. So the app crashed, the emulator crashed. So I guess for this case, we still have to use C for these kind of high performance applications. There's actually one app from Pebble App Store that's doing this. This is rendered with watch side rendering. Frame rate is much better, I think. From the screenshot I got here, it looks like 3 FPS to 4 FPS, which is quite okay. And but the bad part for this is you only have 24K to program for your Pebble, so there will be a limitation on the geometry part. For this app, it says there will be a limitation on 300 vertices, while the app, the demo I created, the model has 6,000 plus vertices, so there's always trade-offs and compromises. Okay, so summary. This is the goals we listed at the beginning of the talk. We want to have a generic way of rendering 3D images for Pebble. Check, we did that. It's flexible, check, we did that. But high frame rates, I put a question mark here because 2 frames per second, maybe not that high. So, but again, there are ways to improve this. You can, so now each pixel takes 1 byte. Maybe you can reduce it to 1 bit per pixel, something like that. Or we can do some other stuff to make it better. That's definitely possible. Yeah, that's about it. Thank you. Questions?
Did you try to send only image diffs instead of sending the full bitmap every time? Just send a diff of what changed that might reduce your latency a bit.
Yeah, that should work, but I didn't try that because it's really a side project and don't really have that much of time. But yeah, if I try that, the performance will be much better. Yeah, that's for sure.
I'm intrigued by the FPGA. So I had a quick look while you were speaking. It's a line of about 5 different models. And the number of cells in each model is equal to the number of horizontal pixels in each HD video mode.
Oh.
So it looks an awful lot like they're set up to be line at a time video output devices.
Okay.
I don't know anything about Pebble, but I wonder if they could be encouraged to be a little more open about what's happening there, because you've got a very powerful machine there. To triangle rendering.
Thanks for the information.
Yeah, and actually, if they can open source the design, maybe we can do a lot of cool stuff with it. It has a PGA chip on it. It has a very powerful CPU, and yeah, they really should open source it.
Thought of making a Super Mario game after
that? Super Mario, I think there's already a Super Mario for Pebble. Yeah.
Any other questions?
Can you do a video compression or something like that? Send
over? Yeah, but video compression, you need to compress it, and then on your watch you need to decompress it, and that part might take a while. So, sorry?
The codec itself will take a while.
Yeah, the codec itself will take up.
Questions? No?
Curious about the application. You said it was 24K per application.
Yeah.
Code and data?
Yeah. Code and data.
Yeah, so that's why if you do the watch side rendering, you would definitely have a lot of limitations on the geometry part. Yeah. Yeah.
I won't try to overclock the.
Yeah.
You do a new model, and you basically want to replace the crystal and see, whether, of course, some of the SPI bus, whatever, we will have some error, but maybe some people, whether some sort of development kit associated with that watch, which you want?
Sorry, I cannot hear you properly.
Development kit?
No, there is no development kit for Pebble.
And it's not open source, so you don't really know what it's doing inside it. And yeah, overclocking might be work, but you need to do something hacks on it.
Is actually driving the LCD frame buffer, basically.
Yeah, that should work.
Anything else? Well then, thank you, Shubham.
Okay, thank you.
At 1:45 on the dot. 2:45. We will start at 1:45 tomorrow, of course.
1:45 Bangkok time.
Because we just want to be here all night. Obviously.
One of the nice contrasts with this versus, say, Cross Asia. I mean, I love doing Cross Asia. I'm pulling around 200 speakers in 3 days.
So like the one thing I initially wanted to do but then I realized that we won't have quite enough buffer. Like we have no buffer. And moments of my overruns are 5 minutes. So instead I decided, well, we'll just have one less speaker and a lot more buffer, because it's funny that you can't get people to talk to each other. And if they don't get to talk to each other, why are you here? Right? You wouldn't want to come if you couldn't interact with them. You can actually be recording. You get
All right, children slash not children, time to settle down. Because up next, we have Donald Trump trying to make systems programming great again. He's going to build a wall and keep those buffer overflows out. Yes.
All right. How many of you have touched systems programming since university? Yeah, I just see a couple. You know why? Because it sucks currently, right? Well, yeah, it does. But just to clarify before I go on, though, this is my only humble thing I'm going to say today. I'm not an expert on Rust, so if you see any issues, or please approach Rahul, who's done far more Rust projects than I have. But with that, let's go ahead. All right, so who am I? I'm Umar. I'm an iOS developer at Garena. I don't do Rust at work, but that's OK. I'm still going to talk about it anyway. All right, so why? Why are we going to talk about Rust at all? How many of you have seen this? All right, good. A few people have. For those of you who haven't seen it, this baby is Heartbleed. It's a very cool bug with a logo. How many of your bugs have logos? No, right? Why does it have a logo? It's because it's a bug in OpenSSL, which most of us use actually. And it's a bug in OpenSSL that results from, believe it or not, a missing bounds check. You know what a missing bounds check is, right? If length is less than some length, yeah, they missed one of those, and that caused this bug. Why are you making noise about Hillary using an insecure email server when you have bugs like this floating around, right? And to be honest, this is not the only bug in such a vital library that's used everywhere. No, it's not. There's this one, Shell Shock. Quite big recently. Also has a logo, right? Cool. There's a thing going on here. There's go-to-fail. Everyone heard of go-to-fail? There's a bug in Apple's implementation. It's basically just had two go-to statements. This doesn't have a logo, so I used the code block itself as a logo. There's this new one called Sandworm, affects Windows systems. Yeah, I know, right? And I don't know who comes with the logos. So, anyways, for all of this, right, you have all these big bugs in these common libraries that everyone uses, and we see a problem here. There's a big problem. What's the root of this problem? Like, why is it that something that's so core and so important to us is done in a buggy fashion? This should not be the current state of things, right? We need to change. The problem is languages like C, C++ that are used to implement these libraries give you a lot of control. Too much freedom, like too much. I have two very famous quotes from two of the greatest philosophers of the 21st and 20th centuries. The first one is Bjørn Stroustrup, the creator of C++, who says, C++ makes it easy to shoot your whole goddamn leg off. Now, when the creator of C++ says that, you know you got to take him seriously. All right? I also have another quote from another other greatest philosopher of the 20th century, Uncle Ben, who says, with great power comes great bugs. What exactly are we talking about? What kind of bugs are we talking about? I'm going to focus on memory safety. What exactly about memory safety? First thing, buffer overflows. Because you have direct access to memory, and you don't have a bounds check, or you're missing a bounds check here or there, you might corrupt objects that are adjacent to you in memory and change what they're actually holding. You might have buffer overreads, where you read something, you miss another bounds check, and you read something that's beyond what you're supposed to read, revealing sensitive data. Actually, that's what happened in Heartbleed. You have dangling pointers, one of our favorite bugs, whereby you have an object to something, you forgot to deallocate, but you lost a pointer. Oops, sorry. It's going to be there. It's going to cause the memory leak. Too bad. You have double free, which might corrupt you. So you've tried to free an object twice. This thing can corrupt the heap in certain implementations. And there's plenty more. There's a lot more, right? And for those of you who are wondering, I haven't seen this at work. I mean, most of us don't deal with this, right? Who's had to deal with this, actually? Aside from Rahul. All right. Yeah, GC, bro. Like, garbage collector. Yeah, we have those, right? Why can't we use those everywhere? Screw all this memory management. We should use GC everywhere. So garbage collection. Why not? Why not garbage collection, right? So when I'm talking about garbage collection, I'm going to be talking about generational garbage collection, mark and sweep, JVM style, pause the world kind. Right? You halt the world and you do your garbage collection, like this truck passing around. Imagine this truck passing around, this stops everyone there, collects all the garbage and goes away. That's the kind of GC I'm talking about. All right, problem with GC though is for systems programming, GC has non-deterministic destruction. This is important. I have a resource, a video file. This can be gigabytes large. And I want to make sure it's destroyed by this particular frame so I can load something else in buffer. I can't do that with GC because I don't know when my GC is going to happen, when stuff is going to be invoked. So if I'm constricted in resources, I have a problem. I need to have deterministic ways to know when my stuff is going to be released. Another issue, GC needs a lot more memory to be efficient. This is not me saying, this is a direct quote from Chris Lettner, the god of compilers. To be honest, GC needs around 3 to 4 times more memory than your actual application in order to be very efficient. Otherwise, it will lead to bad performance and thrashing. So, meaning that when you're talking about memory-constrained devices, like ARM, Pebble, for example, talking about like mobile phones, you can't use GC there, right? Because you just will have like a few megabytes of RAM. Another issue that's not as often talked about is battery efficiency. The problem with GC is that because it often has to do a sweep across all your memory, it will do a lot of RAM reads. And all these RAM reads will eventually affect your battery performance. And this is another reason why you can't have that many RAM reads, your battery performance will go crazy. And you ever wondered why Android phones suffer in battery like a lot more than iOS phones? This is one of the reasons why. Not exactly the only reason, but this is one of the reasons why iOS phones do slightly better because we don't have a garbage collector in iOS. Then, now imagine if I'm on an airline, I'm an air traffic controller, and there's a flight about to land in the next second, and then I have a GC pause. Not very good, right? Like your plane might crash. Like you can't have GC pauses in hard real-time systems. So with all these factors in mind, we realize we can't actually use a garbage collector at all, which is why we're stuck with the current state of affairs, whereby we have to worry about all these memory bugs. And that's where Rust comes in. So yay, Rust, hello world. Easy, right? Rust hello world is easier than C hello world. So we've been already. We're at a head start. You don't need the hash include, IO, blah, 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 blah. It's easier than C++ ones as well, right? No need the using namespace standard, et cetera, et cetera. All right, so since we already win, I'm going to stop now. OK, never mind. Yeah. All right, so what is Rust exactly? To those of you who've never heard of Rust, actually, who's heard of Rust before?
Is it the thing that you get when iron oxidizes?
Yeah, you got it. It's pretty close. It's like an old car. And those, OK, so around half of you have heard of Rust before. Those of you who haven't heard of Rust before, Rust is a systems programming language that is focused on 3 goals: safety, speed, and concurrency. And today, we're going to be talking more about the safety aspect about Rust. This talk is not a bottoms-up tutorial about Rust. So I'm only going to cover specific salient features of Rust specific to memory management that I think are very important. The rest, I mean, you can read the Rust-lang book. Also, to those of you who are wondering what is a systems programming language and how is it different from an application programming language, well, the systems programming language is the thing that's used to build the libraries your applications will use. So your OS, for example, will be written in a systems programming language. Your garbage collector will be written in a systems programming language, et cetera, et cetera. So it's the stuff upon which you build your stuff. Okay? That's why you probably won't see a lot of applications using Rust as much, although there are some, naturally, because every language has a web server implementation. Rust also has a web server implementation. Take that JavaScript. All right. So let's look at a bit of Rust code. So here's some simple Rust code. One thing I'm going to focus on is everything in Rust is immutable by default. So when I do let x equals 10, I'm literally defining a variable called x. And if I try to reassign it to something else, it will throw a compile time error, because it will say that I cannot reassign an immutable variable, which is awesome. Immutability by default is something that we should have had in C, C++ a long time ago. It's something that people now say you should use in C, C++ because you should use const everywhere by default, unless you don't need to. But it's something that was a mistake in C, C++. It has now been fixed by the Rust gods. So if you want to have a mutable variable, you need to define this keyword mute before the variable name, which will make it a mutable variable, and this will not fail at compile time. Okay? So this is good. So far, so good. By the way, if any of you have any questions during one of the code snippets, just feel free to ask. All right. Okay. Next thing about Rust is strongly typed with type inference, which is very sexy. That means that I don't need to annotate everything with a type. The compiler will infer the type for me. So if I define a variable y, for example, that's type which has the value of the meaning of life and everything, it will be inferred to be int32. But I can also specify it. And naturally, Rust supports all your numeric types. And if you notice, like, you have to tell Rust like what's the size of the integer that you're going to deal with. This is important because you're dealing with systems programming language. You don't want it to abstract out stuff. So strongly typed, got type inference, good. We're looking a bit like Haskell actually in all those nice, sexy new languages, right? All right. So just to carry on with the example, I'm just going to introduce one more construct so that it'll make the memory part easier. I'm just going to introduce vectors. A vector is a resizable array, okay? Similar to a C++ vector. You can put stuff inside it. It's got O1 access for O1 element access, O1 push, pop, etc. And the way you declare a vector is use this thing. Hold on. Use this vec exclamation mark, which is actually a macro. Oh yeah, Rust has macros too, like Lisp. And these are not macros like preprocessor hacks. This is a proper macro system. We're not going to talk about that much more about macros in detail, but just to let you guys know, it's thought through. It's not an accidental add-on, which C preprocessor looks like sometimes. So this thing is a macro. This thing will basically create a vector with these elements, all right, of type int32. The interesting thing about vectors is that their content is stored on the heap. Just keep that in mind for now. We're going to go into that in a lot more detail in a bit. Okay? To those of you who don't know, anyone who here does not know what a stack heap is? Stack heap. Anyone who does not know? Yeah. The difference between a stack and a heap, especially when it comes to a programming language, when you're running code, or you're having like where will your program memory be held in stack heap? Never mind. I'll go into it later on, so it'll be clear later on. All right. So let's jump to the cool parts now. The memory model. All right. Rust's philosophy in general is this: zero cost abstractions. What does that mean? That means all the features that Rust has should not have any performance cost, should not have any additional thing that will hinder you from using it as a systems programming language. That's why Rust does not have a garbage collector, because you know a garbage collector will not make it a good systems programming language. So with that in mind, let's jump into Rust's memory model. And the first concept that we have in Rust's memory model is a concept of ownership. So what does ownership mean? Well, you own something, right? That's ownership. That's literally that's what it means. Like you own it, so you take care of it. So in general, variable bindings, like V over here, will have ownership by default of whatever resource they are bound to. Okay? And when the binding goes out of scope, Rust will free the bound resources as well. So if you guys have done C++, and you know you allocate some memory on a heap, you need to have a free statement at the end, right, to clear the heap memory, right? In general. For Rust, you don't need to. Because in Rust, if you are owning a resource, the moment your variable binding for that resource goes out of scope, Rust will free the resources on stack or heap, whatever, it doesn't matter. Yes?
How do you prevent it from doing so?
All right, I'll get into that in a bit. That's a very good question, and that's a very legitimate concern. That's something that will be held very, very soon. Okay? So this is the default behavior. That means you don't need to add pesky free statements, etc. later on. So in this case, V on heap will be cleared up. Just to give you guys a bit more information on what's actually going on in terms of stack heap, and those of you who don't know what stack heap is doing over here, I have a very pretty and sexy flowchart diagram here that I made. All right? So over here, these are two statements that I have in two expressions in Rust. First expression, I declare a vector of 1 to 3. The second expression, just for reference sake, is just an integer, right? So what's actually going on in terms of programming? What happens at runtime here is we have a stack. This is the stack, and this is a heap. The green is a stack. The orange is the heap. In the stack, Rust will actually say that this label V is something of type is a vector object on the stack. Is a vector object on the stack. This vector object contains an address to the actual data on the heap. So the address is 0x100, and on the heap, the address 0x100 contains the actual data inside. Okay, and this stack object also contains the size, and it will contain a few other properties that you might need access to, because you don't always want to go to the heap all the time. Getting stuff from the stack is usually a lot faster. So that's why it will store some information about it, about this data structure on the heap, on the stack itself. Okay, that's how Rust does stuff. That's how Rust vectors work. Okay, for comparison's sake, I have the variable I over here. I is something of type int32, and the value is stored directly on the stack because it's a primitive type. All the primitive types will naturally always directly go on the stack. Okay, this is something that's the same thing happens in C and C++. The slight difference in C++ is generally over here you won't have a stack object, but your variable will have a direct address to the pointer on heap. In this case, we just have some additional information on the stack that Rust can use for optimization purposes, because this stuff is a lot faster to do this way. Okay? So this is what's happening. So ownership sounds good in principle, but just now Roland pointed out a very good thing, that how do you prevent that from happening? Rust has an additional rule. The rule is there is only one binding to any particular given resource. So you can only have one binding at a particular point in time. That means if I have code like this, where I declare my vector V, then I have another let v2, and I assign it to v, which seems innocent and straightforward, and I try to print my v, this will actually give me a compile time error. Yeah, I know, right? What? So the compile time error is that you are using a mood value v. So, okay, another thing about Rust, I apologize. Rust compile time errors kind of suck. Like they're working on it, but right now they kind of suck. So why does this fail? It fails because I'm not satisfying my one rule for ownership. I have two bindings to the same vector, and I can't have that in Rust. I can't own, if you're owning something, you can't have two bindings to it. So let's look at it again at that nice flowchart level. In this chart, I have v1, v, and v2, the same vectors, and this white arrow means ownership, okay, in my sexy little diagram. This white arrow means ownership. And I can't have two of these at the same time. I can only have one of these. So yeah, only one owner. All right? So if that's the case, then how will I do stuff? Like, if I have a function here, for example, and I pass, like, I define this function, take, and this function does something with v, right? So does something with the vector v. And this is technically a new binding because I'm passing something as an argument, and this is a new binding now, right? The name can be different, but it's a new binding. So when I do this, also throw compile error, because I have two bindings to the same resource. So how do I pass stuff around, right? This is more screwed up than C, C++, any language that you have possibly seen, right? I mean, I can't even do this. Sucks. Yeah, that's my initial reaction when I saw this as well. But there's a very good reason for this. And the reason is, let's say I'm counting the number of votes that Trump has. All right? Okay? So I have a vector here. Number of votes I have. Imagine this is a lot bigger than it actually is. It's not just the wife, the daughter, and the son. All right? Imagine there's a lot more people here. And let's say I want to fake a few. All right? Because that's cool. So I declare a mutable vector. Let's say I can do this. And then I push. So, aha! Now my vector should change, right? This will actually not compile. And the reason it will not compile will become clear now over here. So say if this did compile, what will happen at runtime? I have my fake more vector here, whose size is 4, right? Because I added something. And I added let's say I mutated my heap. If you notice, this thing is now wrong, right? This thing is wrong now. My object has been corrupted. And a lot of memory bugs happen like this, where you move stuff or you mutate stuff that may also be referenced somewhere else, and then boom, you get like index out of bounds. You get on iOS you get exec breakpoint, etc., exec backdash bad access, etc. So that's the reason why you can only have one ownership. So every binding can only own once. Okay? So, I mean, this is not really new. To be honest, this problem exists in C, C++, and we deal with it. We have a way to deal with it. It's called copying. Just have two copies of the array, right? And then we can do whatever mutations we want. Because they're two different copies, they won't cause data corruption, right? So, and if you notice, if I'm just using a primitive value, like I just have 1, and then I assign v2 to v2 equal to v, this will compile actually. And the reason it compiles is because primitives implement copying. So primitive types, well, you can copy them around. And actually, every data type can implement the copy trait. Copy is a trait. Trait is a protocol, actually. So you need to implement a method of this trait, and you can have copying. So I can copy everything, right? Which is nice, works fine. It's inefficient as crap, but it works, right? But because it's inefficient as crap, I wouldn't want to do this in actual production code. So how do I pass things around in a function? Well, I have to do something like this. So since I can only have one binding, every time I reuse something, I have to return it back. So it can be reassigned and reused. So let's say I have a function called foo, because that's a good name for functions. And this thing takes a vector v1, v2, and does return some result. The result it returns, once again, is the meaning of life and everything. And it returns the two vectors back. So if I use it in this way, where I define vector v1, v2, then pass it to this function. Then I can reassign the result back. Throughout this flow, I only have one binding to my vectors, like only have one binding to each vector at one time. So this thing will compile fine. So this is fine. This works. But I mean, what? Like why? Like this is not correct. This is not right. This doesn't feel right. Right? So to solve this problem, Rust has another concept, which is called borrowing. So what does borrowing do? Borrowing allows you to have a reference to an owned resource, and when it goes out of scope, it won't actually deallocate the stuff, deallocate the actual reference. So a reference will borrow ownership rather than owning the resource. So in this case, how do I know it's a reference? I have the nice AND here. And whenever you have a type that's prefixed with an AND, that means it's a reference. So I pass these two by reference, and then I don't need to return them back because I'm passing them as reference, so they won't be deallocated. And this thing will work fine. And when I want to pass something as a reference, so I want to pass its own type as the reference, I just prefix this and this thing will work fine. Okay? So that's all. Hopefully that solves your question about how you deal with that kind of problem. Yeah, it's not going to be deallocated. So just to give you, like for my sexy chart over here, the dotted line with the black arrow is reference. So over here I have owner, reference, and this thing. These things are both pointing to the same thing, but this thing is a reference. So when this thing goes out of scope, this won't be deallocated. All right? Yes?
When the owner deallocates, does the reference now become the owner?
Good question. I'm going to deal with that next. Very good question. Okay. So, but before I deal with that, I'm going to deal with another issue first, which is what happens if my reference decides to mutate something? In the previous example, I was trying to add some votes, right? Let's say I try that over here. Again, I pass something as a reference, and then I try to push. Ha-ha. Aha. Cannot compile. Why? Because by default, references are immutable. So you can't mutate stuff. If you want to mutate stuff, Rust makes it hard. It makes it hard. You have to do something like this. So what exactly is going on over here? You need this thing called an and mute. And mute means mutable reference. Okay? So over here what I do is I define a mutable variable called x. Don't worry about the brace for now. I'll explain why I have this later. And I define a mutable reference to x called y. Then I change the value inside the thing. This is how I deref the reference. And then when I print this x, now my x will actually have changed to 6. Okay? So yeah, like I mentioned, a mutable borrow from an immutable value will give you an error. Oh, so one thing is, note that my x has to be mutable. If my x is not mutable, it will still throw a compile time error. Okay? Which is great. Makes it especially hard for those pesky memory bugs to cross the border, right? All right. And yeah, you need the star to access the content for the reference. To those of you who are like me, wondering, who like clean code, and are wondering what the hell is with the braces, there's a few more rules. Sigh. The rules are borrowing rules. The first rule for borrowing is that any borrow you do must not last for a scope that's greater than the owner. That means that that answers your question previously. What if I have something that's outside of my reference is outside of the scope of the owner? What will happen? It will not compile. It'll give you a compile time error. That's the first rule. The second rule, you can only have one mutable reference. Yeah. So you can have one or more immutable references, like as many as you want, doesn't matter. But you can only have one mutable reference at a point in time. Yeah. And this is enforced at compile time. So if you have this, the compiler will throw something at you. Like it'll say, screw you, I'm not going to compile this shit. So actually, this is good. Because if you think about it, this is the definition of a data race. A data race, in computer science parlance, occurs when you have two or more pointers accessing the memory location at the same time, and one of them is writing, one of them is reading. You don't want that, right? When something is writing, you want all the reads to stop. You don't want anyone reading at that time, right? So this is actually pretty good. Actually, this is preventing data races at compile time, which is awesome. I don't need to have all the stupid blocking, locks, all those mechanisms that I have in order to manage data races at runtime myself. I don't need that anymore. This is pretty awesome, actually. Although it makes writing Rust code 90% of the time fighting this. So let's relook at the example I showed you just now. Here's the example without the braces. Okay. So I define my mutable variable x here. I define the variable y, which is a mutable reference to x. I change this thing here. And then I print x. And then that's it. That's all I'm doing. Innocent looking code will not compile. All right. Why will this not compile? This will not compile because we are breaking the first rule. Actually, we have more than one reference pointing to this thing. Or rather, we have a mutable reference and an immutable reference in this case. The y is the mutable reference, and y goes out of scope at the end of this block, right? The print line will also create a reference, because print line won't borrow, because you don't see return, right? It can't borrow. So it can't own, so it'll borrow. It has to take the reference in. And because this thing creates an immutable reference, at this point in time in scope, you have two references, one mutable, one immutable. And this is a data race. And this thing, that's why, will not compile. Okay? Second rule, references must not live longer than the resource that they refer to. So here's an example. And this kind of code is something that happens. This is Vishnu's case, actually, whereby I define this reference called y. And then inside this block, I assign, inside the scope block, I assign x equal to 5 and do this. Y is equal to this reference, right? Not compile. Because x does not live long enough for y. Basically, the owner needs to live longer than the borrower. All right? You can't borrow something without an owner. That doesn't work. Rust will screw you. Okay? So that's the memory model. There's a few more things as well, which I haven't talked about. Just things to manage lifetimes, which I won't go into it right now. But that's the gist of it. This is all you need to know. So now I'm going to continue like a few more features that Rust has. Rust has structs. Structs look like structs in any other language. They are structs, just a collection of data types. And the way you declare them is you just declare the name and the type. The interesting difference in structs in Rust and other languages is, let's say I want to mute. When I create a struct like this thing is immutable because it's a let, not a let mute. If I want to create a mutable version of this, I have to do this, mute. And then I can change the x value, and I can change the y value. To the more people, to the guys with more keen eyes, or to the guys who do a lot of OOP stuff, you notice there's no field level mutability. What that means is I can't specify specific properties to be mutable or immutable. If I have a user struct and I want user ID to be immutable, but I want the name to be mutable, how do I do that? I can't do it out of the box, actually. In order to achieve something like that, I need to use a pointer, a mutable pointer to the actual thing in order to achieve that. So it's a bit more complicated. By default, immutability is a property of the binding, not of the actual data. Okay? So that's how structs work. Because Rust is cool, it doesn't have classes. So but your structs can have methods. So over here I have a simple struct called circle, xy radius, has the simple method called area, the nice boring example from an OOP textbook. And if you notice, the only interesting thing in this example is this. If you notice our good old friend and self means it's an immutable reference to self. Meaning that if you change anything inside self, compile time error. Okay? If you want to mutate self, you have to use and mute self. And if you want to own self, then you have to use self. Yeah. Yo, dog, I put a self in yourself. So the way you call a method is very simple. Like any other programming language, you just dot method name. That's it. Okay. So one more thing I'm going to talk about, which you guys might not have heard of that much, is static versus dynamic dispatch. How many of you know what static dispatch is? All right, not that many people. Okay. So static dispatch means that if you have a function or a method, it has a fixed address in memory. So when I call this function, I can just go directly to that address. I don't need to dynamically calculate the address of that thing. Okay? That's what static dispatch means. Dynamic dispatch means the address of that function needs to be evaluated at runtime. It's not available at compile time for you. Okay? So to those of you who do JavaScript and don't care about this, we're wondering, why do I need to worry about this at all, right? Actually, these things matter a lot in a systems programming language because there's different levels of optimizations you can do with the static dispatch. And Rust, by default, will use static dispatch. And static dispatch allows you to do several optimizations, like inlining. So what do I exactly mean by inlining? Let's look at that. Let's say I'm stupid and I define a function called add, all right? Because I don't like the plus operator. So I want to have a function for it because let's say I'm a functional programming geek. So I want everything to be functions, right? Because I am a functional programming geek. Anyways, so let's say I define this function called add, all right? Now this thing just takes in, return in, and in the body. Oh, one more thing we know about Rust functions, you don't need to add a return, right? By default, the last expression will always return. Okay, that's cool. Sorry, what? It'll compile time. Like unless the function does not return anything, because the function's type definition is specified here. If you don't specify anything here or you return void, it won't throw an error then. Okay, so good question. Rust is fun that way. All right, so this is how I call this function, right? So let's look at what the output of this would be in assembly code if the compiler was not inlined. So if it's not inline, the compiler will generate some assembly like this. Whoa, what is this? Right? Okay, let's just go through this very easily. Basically, we have the gist of it is we have a lot of instructions. The first instruction is to set the pointer to know where this function is. Then you need to push the arguments. Then you need to call the instruction. Then you need to put the result in another register. And then you need to pop everything back. That's generally how function calls work in assembly, right? To those of you who have done some low-level stuff, this is probably like child's play. Okay? But this is what happens every time you have a function call. So if I have a simple function, then this is actually pretty expensive, right? Function calls are expensive, that means. I shouldn't have function calls. So what can I do here? However, if this thing is inlined, inlining will just reduce it to this. So inlining, when you inline this, it'll actually just compile to an add instruction, that piece of code. And the reason for that is what inlining will do is it'll actually expand the function body inside. It'll actually expand the function body at the point where you're calling it. So it won't actually be a function call. It'll just be kind of like a macro expansion, which allows the compiler to do several kind of optimizations, which is pretty awesome. So generally, a lot of high performance languages will try to use static dispatch whenever possible. That's static dispatch in inlining. However, even that has problems. If you have dynamic dispatch, there are some cases where dynamic dispatch is actually more effective. So, for example, and this is where I'm going to touch a bit into Rust protocols, just a bit. So let's say I have a method called do something. And this do something is defined. So if I want to constrain my argument type, right, to some type that implements a protocol, the way I do it is this way. So my x is of type t, where t is a generic type. And this generic type conforms to this protocol called foo. All right? And in this protocol foo, I've defined this method called x. So that's why I can call this method directly. So that's how Rust's protocol types work. Okay? And let's say I have this, and I define the same method for U8, for byte, and for string. The way the Rust will generate code is it uses this thing called monomorphization, which sounds like a load of baloney, but basically all it means is that it'll stupidly generate functions for all the different types. So for every type that conforms to this protocol, it will actually generate a method. And this is cool because it allows static inlining, but it's not so cool because it can bloat code size. Because if I have a protocol and every type conforms to the protocol, my code size will be immensely large. And this will actually result in more instructions. And if my code size is limited, like it is on the Pebble my friend showed you earlier, then you're doomed. So generally, in these cases like this, dynamic dispatch might be more effective. Rust actually allows you to specify which type of dispatch you want to use per function, which is pretty cool. So yeah, that's why it's awesome for this kind of stuff. OK, next thing, just going to go through, is Rust enums. Rust enums, go ahead first. Yes, by default.
No matter the length of the function,
I mean, the compiler will obviously do some optimizations. It's not guaranteed, yes, but you can guarantee it. Because they have a meta information you can add to a function, and that meta information you can specify that you want it to be in line, or you don't want it to be in line.
Irrespective of the length, it would honor the request.
Yes, correct. Because it assumes that you are smart enough to know what you're doing, so it will follow that request and it'll make it in line or not in line. But it allows you to configure it. By default, it has some smart way to do it. So for enums, Rust's enum types are very powerful. C, C++ enums only allow enums to be integers. In Rust, your enums are what we call tagged unions. They can have data inside of the enum. So this is pretty powerful. If you can associate, so if I have like something called a message, which can be of type quit, change color, move, I can have data inside this thing as well, which is pretty powerful. Like you can imagine, if you've done like things like Haskell, if you've done programming languages like Haskell, Swift, this is a new hotness. Every hot new programming language has this. So if you don't have this, then you're a sucky programming language. And this allows you to do very powerful representations. Like it's very easy to represent an abstract syntax tree for a programming language. Yeah, go ahead. Yeah, sort of, yes. But union in C is what you call it's unlabeled. You've got to get
access correctly, but it's
like a union in C, yeah. It's like a union in C, except that in union in C, if I'm not wrong, there is some limitation on what types you can have a union of, if I'm not mistaken. Over here, your type can be anything, and the container can be anything as well. So you can represent, it can be anything you want. Like to those of you who've done functional programming, this is actually quite familiar. Those of you who've done ML, Haskell, Swift, etc. All right, last topic for today. Strings, everyone's favorite data type. Strings are awesome, right? Everyone uses strings for everything. So C strings, those of you who dealt with C string know a C string is just a buffer of bytes with a null character at the end, right? Rust strings support UTF-8 by default because that's the new hotness as well in programming languages. If you don't support UTF-8 by default, you are sucky and I should not use you. So Rust strings, what does that mean actually? Is I'll go a bit more into UTF-8 in a bit, but let's say I just declare a string like this, like hello there. What's the type of this string? This thing is a static string, right? A static string is actually just of type str, string. And this is statically allocated, and it's available throughout the entire duration of the program. So this will actually be in your data segment, in your code, okay? So you don't need to worry about memory management for this one. It's always available. Rust also has another type of string called string. So there's two types of strings. One's a statically allocated string, which is str. The other one is a heap allocated string, which is growable, which is called string, confusingly enough. All right? And for this string, I can do mutations and whatnot. So if I have this thing and I want to push hello world, this is how I do it. Okay? So this is confusing. Two string types. Looks like a recipe for trouble, right? Another issue with Swift strings that you might not have issues. Usually when you do strings, you can just use an index and get a character out, right? It works like flawlessly in all programming languages.
Except when you have Chinese in there.
Exactly. So Rust strings do not support indexing. Why? The reason for this is actually in UTF-8, indexing does not actually mean anything. The reason is in UTF-8, the same character, your character in terms of human representation character, does not necessarily occupy a fixed number of bytes. So you can have, if you have a Japanese character or a Chinese character, you can have many bytes inside. If you notice like all those tons of new emojis they come up with, have you ever wondered how they're encoded? It's because the data itself actually can be multiple bytes. So if you think of strings that way, string indexing is an ON operation. It's not an O1 operation anymore. Because you have to walk through the entire string to find out what's the grouping, how to compose all these characters together, and then find the nth character of a string. So that's why Rust doesn't hide this from you. Generally, most languages will hide this from you. So if you're dealing with localization, like we do a lot, and you do like you try to index something that's actually not a valid character, you'll get a very funny result at the end of the day. Like if you have Chinese language stuff and then you access the third element, you'll get an invalid string. And you have to be very careful if you're dealing with like stuff that's non-ASCII. So what Rust does, it allows you to look at stuff from whether you want the bytes point of view or you want the characters point of view. If you want the bytes point of view, like in this case I have Hachiko, and these are, over here I print the raw bytes inside here. So if you notice, the bytes are a lot more than when I print the characters out. Okay? And this thing, you need to be aware of this when you're dealing with strings. And actually, this is not a new thing. In Swift as well, it's also a new sexy programming language. It's the same thing, similar concept, because UTF-8 is important. So with that, the next section is foreign function interface, which is how do I call Rust from other languages? Because if I'm doing like a large project like on iOS and I want to use Rust, I can't use Rust because I don't support, UIKit doesn't support Rust. So how do I do it, right? Rust allows you to communicate with C, which is awesome. And how you do it is you do something like this. You can define an extern method. And if you define this as an extern, you can actually call this method in C. And Rust, so Rust functions can also be called from C. And you can also call Rust, you can also call C functions in Rust. So in this case, I define this function in Rust. And this is defined somewhere else in some C library. And I can call it directly. But I have to use this unsafe modifier. What unsafe does is it says, OK, I'll let you handle your memory. I won't touch this. You're in charge. And you can do whatever you want to do inside an unsafe modifier. So this will allow you to call C code and to interface with C code. And you can also expose your functions to be called in C code. So in this case, I have a Rust hello world. And if I call this function in C, it'll actually print out, return to me a void star array of characters, because that's what C likes. And this thing will work in C. So that's just I don't want to go into detail, but the point is you can do it. So you can have, keeping that in mind, and the fact that Rust supports a very large number of architectures, because it's using LLVM under the hood. And so any architecture that that LLVM supports, Rust also supports. Means that we can work almost anywhere. So if you think about it, if you want to write cross-platform code on Android and iOS, for example, you want to have some common library, you can implement it in Rust. And you can have bindings to call this library in iOS, Objective-C, or Android in Java using JNI. It's possible you can do that. So it makes it very exciting, actually, to use. You don't have to just use it for systems programming language, although that's what it's designed for. With that in mind, that's it. That's the end of my presentation. Any questions? Feel free to ask. Roland.
Two observations. Firstly, thank you. I've not gone through Rust before. And having been through the hell of synchronized blocks in Java, I'm not yet convinced, but I get why mutability by default. And it's exactly that problem, that it's too uncontrolled. The other was garbage collection. And I was going to say that you're out of date by about 15 years on 3v4 claims, but actually you're not. Android, for some reason, did not adopt the hotspot VM until 2014. And so, up until 2 years ago, what you were saying was correct. Now it is the case that there is no sweeping, and that there in general operations no sweeping, and also that there's no sudden stop. It does a small fixed amount of work at fixed intervals to keep the heap out of control, which on desktop's been true since 2000. So I hadn't realized. And there was a point to this which I've now forgotten. I'll come back to you.
You're right about the optimizations that have been made. But having said that, it's always going to be not as efficient as you manually managing memory yourself. Like the point is, the GC will always have some lag.
It depends what you're measuring exactly. If you're doing if you're in a hard real-time function and you're extremely bug sensitive, then the train garbage collector is actually a good trade-off, except that it further doubles your memory requirement. So you've got to.
That's correct.
You get what you pay for.
That's correct. Then again, to be fair, if you're doing hard real-time, why are you running something on Linux in the first place? So unless you
fight.
So there's that thing.
Questions? Yes.
So you mentioned that concurrency is one of the big tenets.
Yes, correct.
So how does this kind of linear memory management fit with?
I didn't go into a lot of detail in concurrency because there's a lot of concurrency primitives they have for you to do concurrency properly. But the big thing that memory management helps is because of the immutability and the memory model that prevents data races anyway. You don't need to worry about stuff mutating state across multiple threads. So by default, your everything is thread safe anyway, right? Because you don't have a data race, so multiple threads can access everything nicely. If you have a data race, compile time error. So like one big chunk of problems that occur from concurrency is solved already. There are obviously other problems with concurrency that Rust does solve. But that one I didn't go into much detail myself actually. But
so the rules they apply with multi-threaded.
Yes, correct. They apply to multi-thread context as well. That's partially what they're designed for, kind of. If you're in one thread, then it's less of a problem. But this is actually more for when you're multi-thread, you can have data races quite easily. So this is kind of designed for that thing in mind. Yes?
What exactly are the advantages of using this programming language which you are not already getting from C++ or Java or any other programming?
And the advantages are my first slide, which is like all the potential memory bugs that you get when you use C++. Like if you use basically there's a lot of memory bugs that can occur because with manual memory management when you don't have these kind of controls. You can have, like I mentioned earlier on, dangling pointers, buffer overflows, buffer overreads, and these things the programmer has to manually check and have those bounce checks everywhere that function that thing is taking. If you miss a bounce check, you have a vulnerability.
Those problems are already solved in Java, right? So what exactly is this language giving as opposed to which is not already there?
And solved in Java, you say? Like, as in, it's solved in Java because Java has garbage collection, but we can't use garbage collection in this case because we're talking about systems programming languages. So we don't have an environment where we can use garbage collectors because of the numerous reasons I mentioned earlier on. But C++ still have those problems. OpenSSL still has a lot of unsolved bugs, which I'm sure most of you are aware. Every couple of months, I see a Hacker News article on, new OpenSSL vulnerability found, yay. And it's not just OpenSSL, it's a lot of other C++ libraries that often have these vulnerabilities exposed. So it's an ongoing problem. It's like playing that game where you keep whack-a-mole. You whack one bug, then another one pops up after some time. So having this kind of programming model helps prevent that to a large extent, because your compiler is checking for these kind of bugs, so which is more effective than your programmer checking for it. Yeah.
Actually, let me try to take a stab at answering this lady's question. Okay, so there are techniques to solve these problems. For example, you use STL and use carefully to avoid these problems. Okay? But it requires you to use C++ in a specific fashion. Whereas with Rust, the language itself prevents you from making these mistakes.
Okay, but generally it's like when you're dealing with C++, especially the main pain point people generally say is because the pointers and the way in which you access the pointers is worse. But looking at the code samples what you have shared with Rust, I don't think it is any less difficult as compared to what C++ pointers offer as well.
Correct. You're right that it's difficult, but it's safe by default. Because what you can guarantee is that you want a memory bug. That's the guarantee that you have. But C++ may not be difficult, but there's no guarantee that you will have a memory bug or not. That's the main thing that they're trying to solve at compile time. So, yes.
What about testing?
Testing.
Unit tests.
I mean, Rust has testing frameworks, and Rust actually comes with a very nice build tool called Cargo, which allows you, which basically sets up your project for you. It sets up a testing directory. You can write all your tests there. So it has built-in support for testing. And the whole ecosystem is actually quite mature, because the reason I didn't mention this earlier, but Rust is actually developed by Mozilla. And they are using Rust to implement Servo. Servo is their rendering engine, new rendering engine for Firefox. And they actually designed Rust to develop Servo. So it's something that has very real use cases. So that's one of the reasons why the ecosystem is actually quite mature now, at least when it comes to things like testing, build tools, dependency management, etc. It's actually very, very mature. It's way more mature than C++ even, actually.
Just a quick note. There are some bits of the server project which are currently in the nightly and the developer builds of Firefox in production today.
Yeah. And if you want to contribute, actually, you can. There's still in development. If you want to contribute to like a browser, this is your chance. Yeah. Good question. Very good question. It's a very difficult. I wanted to include closures. They have their own set of memory management requirements and memory management rules, and I didn't include them because I would run very, very over time. But very good question. I recommend the Rustlang book chapter. Yeah.
Let's say you have a tree and you have your child nodes, you want to point to your parent.
Yes.
But then you have multiple reference to the same.
Yes, very good cycles, right?
No, just a child pointing back to the parent. You have two children.
Yes. So, in general, if you have a cyclic kind of data source or cyclic kind of object, Rust's borrow checker has issues when it comes to dealing with, when the borrow checker will give you problems. The way to break those cycles is Rust provides a reference counting library as part of the core implementation. And if you want to do something of that sort, you can use the reference counting library to develop a weak pointer to your parent, which doesn't increase your reference count if you've done with reference counting before. And that's one way for you to have such kind of cyclic data sources, data objects that deal with their parent and stuff like that. But you need to do something of that sort. Out of the box, it will give you issues at compile time.
So GC essentially solves the problem?
Yeah, GC will definitely solve the problem. Cyclic object references is a problem that GC solves. In non-GC environments, so in Objective-C, for example, we use automatic reference counting, where you specify at object graph level which reference is strong reference, which reference is a weak reference. And a strong reference will increase your reference count. A weak reference will not increase your reference count. So that you don't have a memory leak there, because a cyclic reference will cause a memory leak otherwise. So you need to use reference counting to manage that.
Any other questions?
Yeah.
Can you give more examples of maybe big programs or platforms that have been built by Rust?
Okay, good question. The biggest there's a list of them on the Rust project, the Rust project README, but the biggest project by far is Servo, but definitely the browser itself. There's a server implementation in Rust, which I can't remember the name of it. It's supposed to be very, very high performance server for like standard web stuff. Then another interesting project that they're doing is they're trying to redo all the core utils in Rust. So all your core Unix utils, move, ls, all these they're trying to re-implement them in Rust, which is an interesting starter project. If you want to start Rust, I'd recommend you take a look at that, see how they implement it, then you can get a nice example of how to do things in Rust. But as far as other big projects goes, I am not sure at the moment. I need to check the internet. I don't have Wi-Fi right now. So yeah. But the biggest by far is definitely Servo. Rahul, do you know any other big
ones? None that are announced. Well, there are some people like, hey, we might think about redoing this in Rust, but no one's outright come out and said, we are doing this in Rust. And the reason for that is fairly simple. Rust has only been 1.0 stable for about a year now.
Yeah.
So if you are rewriting a big project in Rust, you wouldn't announce it yet, because you would only have started maybe 6 months ago.
Yeah.
Nobody ever uses 1.0 anything, except for Go, which for some reason people started using in 0.7.
That's Google. Rahul wrote a DNS library in Rust, which you guys should check out. Is it on?
I also wrote a library that talks to NEA's API in Rust, which apparently there is no. The XML parsing libraries for Rust all work based on events. There's no way to get a tree, so I had to write that as well.
Nice.
Not fun. Because you know that cycle thing you mentioned.
Yeah. It's painful.
They all work on the basis of what? Symmetry?
Events. So
events,
you get events like element start, element end.
Jax passes, yeah.
And things like that.
I forgot the name of the course. It's called
Jax.
Yeah.
Yeah.
That's it. Yeah.
Any more questions? Yeah. Okay, you're mentioning that the mentioned project where they rewrite the utils.
Yes.
From Rust directly in core system calls.
Yes, correct. In core system calls. Because once again, Rust allows you to call C functions. So you can call all your system calls here. There was another project I saw where they did Objective-C, try to run Rust as an iOS app written in Rust. And the way they did that is that they call Objective-C using the Objective-C runtime methods, where they call the runtime methods C runtime methods directly, basically. So as you can do cool stuff like that.
Well, that's why all we have questions. You can talk to Omer afterwards. There will be breaks, of course. Thank you.
All right.
And up next, Justin is going to talk to you about the Hyperledger project. What is that? Well, I'll be going to tell you. It's not just a super ledger or a mega ledger. It's a hyperledger. It's just hyper.
It's all the hype.
It's all hype. How do you want it? Whoa. Let's do that. How are we doing for time? Do I still have to finish in at that time? Okay, so I get the delay.
Yeah, you get your.
Okay. All right, let me know when. All right, hey everyone, my name is Justin, and today I'm going to share about Hyperledger. How many of you guys have actually heard about Hyperledger? Okay, very few guys. How many of you have heard of, or rather done blockchain then? A bunch of you guys, right? Use Ethereum, maybe? One of the implementations? All right, how many of you understand what blockchain is? How about that? Okay, great, more people then. All right, so this is actually the third presentation I've done. The first presentation I've done was a very early overview of Hyperledger when the Hyperledger project was just announced. And there were actually no source code. And that was back in Force Asia when I first introduced Hyperledger. The second presentation I did was in Berlin when there was actually source code to show and stuff like that of an implementation of Hyperledger. So today, what I'm going to do is I'm going to give an overview and also hopefully get right into the code as quickly as possible. and actually share with you what changes has been made and done and what's going to happen going forward in the next 3 to 6 months in the Hyperledger project. So that's what I'm going to cover today. So for those who don't know what blockchain is, in a very simple sense, a blockchain is a distributed database, as simple as that, right? But it is a distributed database with elements of smart contracts, with elements of authorization, authentication, membership services, and things like that, that you would not have found or you would not find in a distributed database. And that's exactly what a blockchain is from a Hyperledger standpoint. It's basically a distributed database 3.0, if you would like to call that, right? So with all that fancy stuff that you want out of it within the network of peers. Why do we want to do blockchain in the first place, right? I'm sure you guys have heard a lot about blockchain from Bitcoins. You guys know what Bitcoins are, right? So Bitcoin is an implementation of a blockchain, essentially, a very specific implementation use case of blockchain. But blockchain is the general form of what Bitcoin networks are, right? And it's meant to be transitioned across the different business organizations and business processes in order to inbuild all of that into the distributed database. Traditionally, let's take, for example, from a banking sector, banking standpoint, right? We have a lot of different parties to do clearing ledgers and clearing the money and things like that, right? There's a lot of different ledgers to be done. And traditionally, what do we do in the IT department? We create APIs, right? That's what we do. We create APIs, and then Bank 1 calls our API, I call their API. We have a customer client who creates their own application. They call my API, I call their API. There's integration issues, there's this, there's that. Basically, everything becomes a whole slew of mess. That's what happens, right? And it is, in fact, in the banking sector, this is what real life is. And there's a lot of approval processes. I'm sure you know what banks are like, right? Layers and layers of approvals and whatnot. So what Hyperledger is trying to add into the features of distributed databases is to be able to have a permission level ledger, right, that is shared and replicated, leveraging on the database, the distributed database technologies to replicate it out there so that you actually own your own ledger and it gets updated and synchronized automatically. But not only that, right, you actually only can have or see the particular hashes or particular entries in the ledger. So that means that you only have the permission and it's built into as part of the system, right, that you can actually see only what you can see. That makes it very interesting from industries that have a lot of regulations. Especially, you don't want Bank A to look at Bank B's records. You want only MOM, or rather Ministry of no, it's not MOM. What's the ministry that? MAS, yes, MAS who can see everything, but you don't want you don't want the other organizations to see the different records, right? So you want to have those kind of flexibility, and you want to have everything that's tracked. And one of the things that a lot of times, a lot of people ask me, right, in terms of a blockchain, can I actually roll back? Can I actually roll back an entry in the ledger? So one of the things that's built into part of the ledger is that it is immutable, right? You must remember that. And I get a lot of developers who ask me, hey, can I delete this entry? I made a mistake. If you want to delete the entry, yes, write another entry into the ledger that reverts back that entry, right? So everything is all tracked. Scary, isn't it? right? And that makes it very interesting on both ends. You have accountability, and on the other hand, it's difficult to work around certain things, which is what's happening in the industry right now. So the Hyperledger has changed. The Hyperledger project has changed a lot over the past 1 year, actually about 9 months now. It was announced in the beginning of the year, and it's about 9 months now, and it's changed quite a bit. It is meant to be a collaborative effort to advance the blockchain technologies with a cross-standard industry open standard, right, to transform business transactions. So the key point is actually business processes and transactions. It's not just about money, it's not just about Bitcoins, it's about processes. And you can actually map blockchain technologies to pretty much any industry out there, even in, let's say, in the manufacturing industry, right? One implementation is actually to track the materials and the bill of materials, essentially, right? Everything within the ledger itself. That's one example. And many other examples that might not have benefited from the blockchain is now considered and being looking at. And the other thing that makes it very interesting about the ledger or Hyperledger is it's meant to become a connector to connect various private blockchains together. And this is one of the things that hasn't been implemented yet, and it makes it very interesting in the near future. Which, let's say, for example, a business network in the finance industry has its own Hyperledger or its own distributed blockchain. You can connect that distributed blockchain to another distributed blockchain automatically and do permission synchronization, right? Which makes very, very interesting use cases from cross-industry standpoint. So this is something that hopefully we'll see in the next 10 years, maybe 20 years down the road. And one of the biggest problems with blockchain is it is a business network. So the entire business networks and all customers in the entire industry within the business network needs to adopt, which makes it one of the very interesting problems when adopting with blockchain, is that you can't just get any benefit if I use blockchain and my one client use blockchain and that's it, right? There is absolutely no benefit. It makes more sense when the entire organization, when the entire cross-industry actually adopts. All right, so Hyperledger, what is in scope of Hyperledger? The standards are, which is in the scope, is smart contracts. I'm sure you guys, those who are under Ethereum, it's smart contracts. What Hyperledger calls it is chain code, but it's essentially the same thing. It's smart contracts. Okay, it's literally code that's being run and executed, which I'll show you later what a chain code looks like. You have the data structures, and this ledger data structures will be standardized across the different Hyperledger projects. And this is the one main change over the last presentation I did, is that now there are 2 more implementations of the Hyperledger standardization, so to speak, right? The more popular one is Fabric. And there is 2 more which just came out, and one that's already approved, which is from Intel, which is Sawtooth, and the other one, which is Iroha, from a Japanese company, which is still in the process of being approved. So Hyperledger as a project, so to speak, is about having multiple implementations of the ledger or the blockchain, but following a set of standard data structures so that you can actually have different technologies or different implementations with their own benefits and whatnot, but still following a same standard contract, so to speak, language, so to speak, from a data structure standpoint. Membership services is part of it, which allows you to connect with your whatever authorization mechanism that you need or want, using CA, certificate authorization and all that. Validation framework, identity services, and so on and so forth, network peer services. What is not in scope is actually the development stuff, right? So the main purpose of Hyperledger, of course, is for organizations to actually make money out of it, right? And one of the things of making money out of it is actually with the operations, the specializations, the more modules to be created. From an overview standpoint, Hyperledger blockchain looks like this. From a cross-implementation standpoint, you have the membership module, you have the blockchain module itself, you have the transactions, and you have the chain code. These are the three main things that are happening in blockchain and very basic stuff. Membership handles essentially all your authorization, your registration, identity, and all of that stuff, right? Very standard. You can, there is no OAuth authorization at the moment, but it's possible to actually create a module and plug in, and that's how it's trying to achieve to be modular, one of the key benefits of Hyperledger. The main core focus is the blockchain itself, the protocol itself, and the doing actual transactions, right? That is the core of the blockchain services, which has all that stuff. Consensus. The consensus manager actually allows you to plug in multiple different consensus algorithms. So at this point of time, there's a few of them, like proof of execution, proof of things like that. There's a whole bunch of it, right? Those are the advanced, crazy algorithm stuff which I don't really want to understand, right? And how you actually do consensus, right? If you want, you can read a lot of papers from the universities themselves. The main thing is a distributed ledger. A distributed ledger is a database, full stop, right? At this point of time, it's actually leveraging on, if I'm not wrong, on RockDB and CouchDB on the back end, right? So it's just a database. That's it, done. All right. The P2P protocol, right now it's leveraging on gRPC using HTTP2 protocol, all right? gRPC versus the REST. So one of the updates, which I'll show you later, is that the REST APIs that were created previously, it's going to be deprecated in the next few versions down the road in preference for gRPC. So leveraging on HTTP2, the new specifications. And the ledger storage. The ledger storage is just blob storages. So it can be any physical hard disk, it can be any S3 or whatever it is, you can do that, right? That's where the actual content, if you want to store videos, images, whatever it is, into that storage. And of course, what is chain code? Chain code is business logic. That's it, right? So business logic that it will be run automatically when a transaction is trying to be made and approved. That's pretty much it. And the chain code, initially in the Hyperledger Fabric, which is the main project implementation, is leveraging on Golang. All right, it's written in Golang. And just very recently, only it's got approved the Java chain code. And what? Yes, Java. Right? So one of the things, no, don't shake your head, don't shake your head. You know why? Because the thing is, the thing is for the chain code itself, it's built in such a way that it's extensible to any language. So it's just a matter of time to actually, there are shims available and written already. It's just, and exposed, it's just the different languages to implement those shims, right, in order to integrate in. So if I want to have a C++ chain code, I can have that. If I want to have a Ruby, a Python, or whatever it is, I can have that. There is work being made for Python right now for chain code and the various other languages and the other implementations also, right? But for now, officially, it's Java and Go. So if you want to contribute the other languages like Rust, maybe, that'll be great, you know, to write your own chain code. All right, so that's chain code. How much time do I have? OK, let's quickly get into the actual code. So benefits, you know, reduces, saves, removes, blah, 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 and so on and so forth. OK, this is the one that comes into the core of what I want to share with. I mentioned there are 3 implementations right now in the incubator status. Right? These are all incubated. That means that it is still, it's not even beta. It's still alpha. It's developer builds, right? So right now, Fabric, which is the main one, is version 0.6. It's still developer preview. It's written in Golang. The protocols is gRPC. It still does have the REST API, but 0.6 will be the last implementation of having the REST API implemented in it. In 0.7 or 0.8, when the first beta release comes out, it will be removed. So the REST APIs leveraging on HTTP 1.1 would be removed. All right. There is a reason behind that. It's mainly performance. So right now, the performance for doing the REST APIs, or actually calling the REST APIs, you can actually call on a standard deployment about 15 to 20 requests per second. With the move to gRPC, it goes up to about 200 to 500 requests per second, and it's a huge performance jump. That's the reason why they are going with gRPC. Java chain code support, just recently implemented with Go chain code already in there. Chain 2, which is another language in a way which I don't quite understand, but that's another one that's there. And then what just came out was the Hyperledger Fabric Client SDK, which is just a wrapper of calling the gRPCs and or the REST APIs within an SDK, which I'll show you a little bit later. Sawtooth Lake is something very interesting, which the code base just came in, was contributed in July, I think, June, July. It's currently release 0.7. It's written in an implementation of Python. It's leveraging on REST APIs. One of the benefits, or one of the interesting implementations of Sawtooth Lake, why Intel, this is by Intel, by the way, proposal by Intel, is that it has its own new algorithm called proof of elapsed time, which leverages on their Intel software guard extension thing, which is a hardware thing for their processors. Yeah, so it's one of the consensus models. One of the consensus models, right? To do the proof of elapsed time. I have no idea what the algorithm is because it's quite complex, but it does a consensus approval. And then quorum voting consensus, right? Which is essentially I vote yes, you vote yes, you vote yes, and it all consensus say everything yes, we approve. Right? So that's the consensus model. Iroha is something that's very interesting that just came out. It hasn't been approved yet for the incubator. It is written in C++. It's pure C++. It's leveraging on also gRPC and REST APIs. And it wants to actually be a lightweight blockchain implementation so that to help address with Android phones, and iOS phones. And there are a lot of interesting stuff that's happening also. One of the things that I am actually personally working on is trying to see whether if I can actually port the Hyperledger project, one of the implementation, into iOS using Swift. The entire thing. So having your phone as a node. Right? That would be very interesting, and I'm working with a few guys internally to get this implementation going. So I'm actually quite excited about this. So from an application architecture standpoint, you still follow your same 3-tier architecture. You have your application, you have your API layer, and then you have your database in the backend, which is the ledger. Right? There's a few differences. Now, in the ledger itself, you have multiple peers. The peers form a network. Each of the peer has its own implementation of a chain code. One peer can have the same chain code as the other peer, or it can have different chain codes as long as the chain codes get approved. There is one major change going forward in the version 1.0 preview. One major change is that they're splitting up the peers. So previously, peers are nodes, consenters, essentially these two. They are splitting up the trust assumptions, or rather the approvals, to another node type so to speak, called endorsers. So which means that an endorser is not a consensus. Okay? An endorser is someone who basically says, or an application who basically says, approve. So this is one of the things, yes, think about it, right? It's not a consensus approval. It's actually, let's say, for example, doing some checks within the organization, having a physical person to say approve, or having a push notification to someone, let's say you, right, saying, do you want to approve this transaction, yes or not, right? So that's what exactly an endorser is. In order to split that peer into two away from the chain code. So right now, right, in order to do endorsement, the endorsement code is actually part of the chain code, which makes it very heavy in terms of execution. So one of the big major changes is to split that apart so that the chain code business logic only focuses on the business logic. And then the endorser part of it essentially is the approval, right? So however you do the approval, you do it under an endorser peer. That's the main change. So what does that mean? That means that now they separate the trust assumptions away from the chain code and the consensus, right? You can scale the endorsers because it's now lighter weight away from the chain code execution. Confidentiality now extracts out and moves to the endorser, so your chain code doesn't have to handle any of the confidentiality, which means, very interesting now, remember I mentioned that each of the entry in the ledger can only be seen by one person or a group of people or role. Now with an endorser, that can actually, the endorser will be able to give approval for a particular role or a person or an identity to read that particular line of ledger, right? So that's one of the other things that an endorser can do. And then, of course, privacy. All right. There is also a big change in the implementation of the application level itself. On the application level, previously everything was very separate. The application calls the REST APIs to the HTTP server, which is and then from the HTTP process and everything actually goes out to the peer. Going forward in the future, everything will be into a native API before going out to an endorser. All right. So now it goes to an endorser to validate the actual thing, and then goes into a peer. A chain code peer. Okay. So that's that. This is a transaction flow. I'm not going to go through. I'm going to go show code. I think I have a few more minutes to show code. So all in all, this is the updates on the changes that's going to happen, major changes that's going to happen into the Hyperledger project, specifically Fabric itself. So whenever I say Hyperledger, I usually mean Fabric because that's the main implementation of Hyperledger. All right. So how do I get started? Let's see. So all the source code and everything for Hyperledger is all open source because it's under Linux Foundation. You can download from the GitHub, do a clone from the GitHub account. Let's see. Oh my God, it's so small. Can you see? Okay, hold on. Let's make it bigger. There we go. So you just clone it from the GitHub account, right? Git clone github.com hyperledger fabric.git. And one of the things is because Fabric is written in Go, so you need to set up your usual Go path and all of that stuff, right? So I'm not going to go through that. You probably know how to do that. All right, so there are two ways of getting the development environment set up. One way is actually if you're going to make changes to the actual core ledger itself, right? And you just do a vagrant, vagrant what? Vagrant start, vagrant init, vagrant what? Yeah, vagrant, right? Sorry? Yes, correct, vagrant up. Vagrant up, right? You just have to do that, and it will set up the environment and everything will get set up. You can also set up the environment within your Mac or Linux. It does not support Windows, I think, at this point of time. Well, if anybody's interested in getting working in Windows, then sure, why not? But for Mac, you need to install a few more packages. So the fastest way is actually just to use Vagrant, right, and just keep running. There are two applications that are created. So as you can see, it's a make file. You just do a make peer or make chain tool. These are the two applications that are being created. So that peer is the main ledger, essentially, or rather the main blockchain. I won't call it a ledger. It's the main blockchain because the ledger is the database behind it, right? So it's the main blockchains, and it will create the nodes. So once give me a second. Let me just get into the Vagrant. And I don't really like to deal it with Vagrant unless I'm actually changing the core source code itself. Is it big enough? Or is it okay? Bigger, bigger, bigger. Tell me when to stop. More. Really? Okay, okay. I don't know. It looks huge on my laptop. So yeah, so Vagrant up. Right? Great. And all the base images and everything is already there. You can actually create your own base image if you want to. All the source code is all within this project itself. So let it run. I've already created it, so it doesn't have to download all of that. There are a few ports that you need to remember. As you can see, there is the port 7050, 7051, 70 blah, blah, blah. As we can see, 7054, 7053, and so on and so forth. Right? These are some of the main ports that is required or needs to be open. How do I know what the ports are? And you can actually change the ports. All right. So if you go to peer, there is actually a core.yaml, right? Let's just do a quick see in this. This is the main configuration for your various peers. Right? If you're gonna do install and run a peer on the different boxes and everything, this will be your configuration. You can also change the configuration, so you can have one configuration and different changes to a configuration using environment variables. So each of the environment variables are essentially res dot. If you want to change the address, res dot address, and then just change it, right, in the environment variable. So that's the core YAML. Let me quickly SSH into Vagrant SSH. And everything is already copied and set up over here, right? Once you have it. So it's located under, where is it located under? I think it's located under Hyperledger. And you have all the source code here. All you need to do is just do a peer. This is the main application. You can register a chain code. You can create a network. You can mainly to just do it's just peer node start. And that's how you create one node. And that's it. That's how and I've just created a blockchain. As simple as that. Well, actually, I have some socket issues, as you can see. So not exactly. So, so this is from the source code itself, right? But if I actually want to do implementation, you guys are familiar with Docker, right? I love Docker. So one of the things is I would rather use Docker to have my peers and my member services already created. So what I do is Docker, there is ship service and the peer, right? This is all generated as they change the code, right? So this is the latest version. And that's all I need, right? And then after that, all I need to do is just do a Docker compose, right? Set all my machines up. As you can see, the environment variables for the core YAML, if I want to override it, I just create environment variables here, right? And I start the node, right? So if I want to have multiple nodes, I can actually create more Docker containers and whatnot and images and just spin them up, Okay? So that's from a basic level. So what happens when I do a Docker compose? What do I do? Just like that? Start. There you go. Oops. What did I do? Oh, yes. The reason is because I need to halt my vagrant. Because the pod has been binded. So I need to halt my vagrant instance. Okay. Docker compose. Start. And I just created a membership service and a peer. Right? I can have multiple peers if I want to, and that's it. I've just created a blockchain. So what do I do now? All right. So the next step is actually to register a chain code, right? Your business logic into the peer, right? In order to register a business logic into the peer, what do I have to do? That's a very good question. Compose up. All right. Now my Dockers are running. All right. So the next step is actually to register the chain code itself. You have to compile the chain code in the different languages. So I have not this one. Let me go to the chain code example 2. This is a very simple example. I have to just do a go build to build the chain code itself. So it's actual execution code, okay? And then I have to run, or rather register the chain code into the peer I want to register it to, right? So that whenever something happens, a transaction happens, the chain code executes automatically. You can register multiple chain codes. All right, so it's registered. 0.0.0 is actually pointing to my peer, which I already exposed, right, with 7051. So it's already registered with the shim and everything. So I have the execution for this. This chain code is really simple. It's just A and B, two entities. I just call it A and B. That's it. And I associate a number to it, right? And that's it. And I just do plus minus. So I just do in the query itself, I just do move number from one to the other number. So very simple, right? So from a very basic level, that's the chain code. You can have very more complex chain codes, but from a basic level, that's what the chain code is. All right, so remember I said that you can actually do everything in the REST APIs, right? So I have here Postman, and it's really small. I have no idea how to. Is there a way to actually increase? I'll just zoom, okay? So the very first thing, right, is because I already set up the membership, right? So you need identity. You need to register yourself. In the membership, how do I know what the registry, what members I have? Let me quickly go here. Under Fabric, in the membership service, there's another YAML file, right? And this actually sets the certificates, the CA, the SHA, and all of that stuff. And also your users, your affiliations, your roles, your admin, whatever it is. Okay? So right now I'm just gonna use one of the default ones, which is Lucas. Right? So I'm gonna register myself. I'm gonna say, hey, I am Lucas. I'm gonna register, and let's see whether it works. Send. All right, so I'm logged in. All right, so now I'm logged in. What I want to do is I want to actually initialize. So there are a few steps to doing peers, right? You want to initialize your backend ledger, so to speak, with some data, right? And my data is essentially A and B at this point in time. So there are a few methods in chain code. The first one is deploy. Deploy actually initializes. In these arguments, in my chain code, it takes this query arguments, it extracts it out, and just stores it in the database. As simple as that, right? I have a secure context identifying who I am, right, and just the ID of the this call. So I call it to I call it to chain code, all right, 7050/chain code, and what it does is it returns back, it initializes, right? So now the next step is I want to query what data do I have in this, right? So I do a query. So in my chain code itself, I have written implementation. Say if I have query, if whatever the query is, B, A, whatever I name it, return just the number, integer, right? So remember what I did? It's 1,000, 2,000 over here. So what is the expected if I have B? It's 2,000, right? So I query for the database, it returns 2,000, so it's correct, right? Really simple. And then now, the third method is invoke, right? So invoke it can be as complex as you want. This is the main transaction, all right? This is the main transaction. And it can be anything you want in terms of the message and whatnot. This message is really simple. It's just I'm going to transfer 100 from A to B. That's it, all right? Very simple. All right, I execute, send, returns me, it's successful transferred, everything is okay. And the actual, basically when it fails is that if A is less than 0, essentially. So you can do all your checks in the chain code itself in order to say whether if the transaction goes in or not and gets accepted. And then, of course, each transaction forms a hash within the chain, within the blockchain. So I go to a query, a get query to chain, and essentially I have the current block hash and the previous block hash. And if I want to actually check the individual transactions, I can go to each of the block, right? Query the transactions, and it will show me the type of transaction, the ID, the payload and everything, the certificate and whatnot, and also the hash data, right? And do remember, the blockchain is just a chain of blocks, hence blockchain, a chain of blocks of hashes. It does not actually contain any data. Got it? It does not contain any data. The actual data is actually on another database, which is stored as blobs, or what we call blobs, right? And that's data. And it's stored as binary stream. That's it, right? And it's not part of the blockchain, all right? It is reference based on the hashes. You can lose your entire data blobs if you want to, where the benefit of blockchain is that the blocks of chain of the hashes are there, and that's what you want, is the records, the ledger records. The data does not matter, right? And that's one of the things that a lot of people don't get with blockchain, is that if you lose the data, it's okay, because you still have the transactions there, the actual transactions there. And that is good enough from a regulation standpoint. As a regulator, you don't actually need the data. You need just the record of transactions. All right, so this is a very basic overview of the blockchain itself from a fabric standpoint. Those who have used Ethereum, it is slightly different, I'm sure, definitely. There are a lot of concepts that are very different from the fabric. And, but the main one thing is that it is meant to be modular, it's meant to be extensible, and it's meant to have multiple peers, okay? with multiple chain codes and everything. And each of these peer can be hosted in any, basically distributed. So all you need to do is just pipe the IP address properly, and that's it. All right, so from a code perspective, that's pretty much it. So the core, oh wait, I want to show the chain code itself, the implementation of the chain code. Where is the implementation of the chain code? Over here. Okay, I'm just going to zoom in like that. So the shims are essentially init, which invoke, delete, and query. These are basically the shims. So init, is the initialization. Invoke is the invocation of, just now we saw the method invoke. Delete is to delete the entire state. And of course, the query is just to query what the thing is, right? And all the code is here. Is just to get the state and whatnot. So that is, from a chain code perspective, that's the very basic stuff. So what you usually do to start creating your blockchain is to work on the chain code itself, the different business logic within the different peers, set up the peers, and then the next step is to set up your actual application. Right? And the actual application recently, or rather a few months ago, they released the Node.js SDK for the Hyperledger Fabric client, which essentially is just a wrapper for all the gRPC calls. That's it, right? So that's all. It's just gRPC calls. You can just write for any language itself, not just Node.js. Just do a gRPC call, and that's it. And then you can on your application side of things, you can just do all the calls and entries and transactions to the blockchain. All right. I should be finishing already, right? Yeah. Okay. All right. So that's that. That's how you get started. Work on the chain code. Set up the peers. Set up the membership service. Run all of that in different Docker containers, virtual machines, whatever you want. Right? Attach the chain code, register the chain code to the individual peers, and then call the invocation methods to the individual peers itself. So you have, when you set up multiple peers, you have one standard main peer that you can call to, or you can call to another peer, and it'll automatically propagate out to the other peers for consensus and run the other chain codes. All right. So all the automation and everything is done automatically for you in the background, and hence the beauty of distribution. Some use cases, routing codes, shared routing codes. You have vehicle maintenance. The most obvious is a financial ledger. You have letter of credit, and so on and so forth. There's a lot of things that you can base out of from an industry standpoint. The key thing is to think of the ledger or the hyperledger as a record of transactions. That's it. Don't overthink what blockchain is. Blockchain, hyperledger is just a transaction, a distributed record of transactions. And it can be on anything, and it transforms the business processes, right? Business processes of a business network. And that's the basic stuff of what blockchain is. All right, so there's a lot of companies that's doing it. There's communities out there. These are all the links. Later, when you get the when you get the PowerPoint slides, you'll be able to click on all that. And that's it. Is there any questions?
Are there restrictions for security reasons?
The restrictions are you must adhere to the shims, right? At this point of time, there are no obvious restrictions in terms of the amount of time and things like that to execute. It is based on the consensus model. The consensus model by default, which is what I put, is just no op, which doesn't do any consensus. So the consensus is the one that does the restriction on the chain code.
Can you make it run like an infinite loop or something?
Sure. And then it crashes lah. Yeah, so that's the one thing in terms of contracts. Contracts is malicious, right? You need to control the registration of the contract of the smart contracts going in. They are still building out the what do you call that? Not the restrictions, but yeah, to a certain extent, the various restrictions that you can set. I think they call it a policy, which you can set on a separate module, right? But the policy is not it's not ready yet at this point of time.
And I was also assuming that in the future they might implement something that implement some cost on the execution time or something.
Yes. All of this is you can set it in the policy and within the consensus model. Yeah.
We have time for one more question.
That's it.
I think we're low on time.
All right. Any other questions? All right. I know it's really technical. It's quite a lot of information to absorb. Oh yes, question. Yes. Can you write directly to the blockchain?
As in, like, in like Bitcoin or Ethereum, like there's not interacting directly with the blockchain, right?
Yes.
Or the hashes.
With the hashes and everything.
Like this abstraction, like we just basically write all these contracts, and then automatically there's a layer that modifies the blockchain.
You mean the ledger, right? The database. Yeah.
Like when you write the chain code, you specifically modify the blockchain.
You mean to synchronize it to the different peers? Or what are you changing? What are you modifying?
Sorry, this is to say, when you've got multiple pairs who have consensus, then a mutation on the...
Then the mutation happens on the actual ledger itself. The transaction gets approved and the mutation happens on the ledger.
But only once the consensus protocol is run.
Correct.
Yeah.
Correct. Only once the consensus model, the consensus protocol is all run and approved. Once the chain code itself has been run, and also no issues or any problems. In future, there will be one more layer, which is the endorsers. So it will be endorsers, chain code, followed by endorsers, chain code, followed by consensus. So 3 layers, right? In order for anything to be approved, in the transaction to be approved. And then in future, also I didn't really cover, transactions can be in 2 views, a single transaction and a batch transaction. So that makes the ledger even more interesting because now you can batch transactions into as one transaction hash, right? So that batch of transactions become one immutable block in the chain. Yeah, which makes in terms from a use case standpoint, even more interesting use cases can be implemented in this kind of transaction entry. All right, if there are any other questions, I'm still around. You can come and talk to me. And there's actually a lot more information that I did not actually talk about. This is just the bare level, and there's a lot of new stuff and a lot of things that are have not been implemented yet also within the Hyperledger fabric. All right, I didn't have any time to actually show you the Sawtooth, but Sawtooth is another one that's very interesting that's upcoming. And then hopefully in my next presentation, in the 4th one that hopefully I'm going to do, I can actually show you implementation of a peer on an iOS device, maybe. All right, thank you very much.
Thank you, Jim. If you want to talk about stuff, now's a good time. We're going to have a quick 5-minute break for a little bit of housekeeping. So I would recommend stretching your legs. We have a couple more talks in
Hey, thank you. I don't know, I think it's a little bit.
It's a bit technical, I think, for most people.
Yeah, I also think so.
Setup. Thomas wants to quickly talk about Dev.SG for a couple minutes. So you can like set up here, just like the cable will be occupied for a bit.
Do you have like a VGA?
HDMI. Oh, using your
What's your talk?
GraphQL.
Oh, Facebook.
Okay, cool. Sure. Later, right?
Yeah.
Yeah. Uh-huh. The chain code is a business logic, which is execution code. So modification is data. So the data is the data is the ledger itself, which is just a database.
I get it. Yeah. So I guess my question was, like, in the chain code, all you need to write is business logic.
Correct.
And then automatically the blockchain, like whenever the data is updated, the hash of the data is automatically reflected on the blockchain.
So whenever there's an execution of a transaction, it needs to go through 2 levels of approvals first at this point in time, right? And then the next step is 3 levels, right? The next version. So the 2 levels is it needs to be submitted to a peer first, right? To one of the peers. So if you have multiple peers, you submit it to a peer. Each of the peer, so it gets propagated out to the various peers, right? And then from each of the peer, it has to get the chain code itself to be approved. So it has to run.
There's some consensus match.
Yes, correct. Okay. Not just the consensus, but the business logic.
Hello.
So the first step is the business logic.
Everybody.
Right. The business logic needs to be like run checks.
Well, it's GeekCamp, right?
application happens, that we can put a label on, specifically this label, to promote Singapore and what is happening here in the tech ecosystem and give a lot of you the opportunity to learn more about what's actually happening. The main thing that I want to say actually is you come to this party. It's like if you are within the first 100 people, you get free drinks too. That's on the 18th of November, so it's coming up in about 20 days. So it's not too far away. And check out all the other events that are happening during DevFest Asia. A lot of them free, some of them paid, but really good content on the workshops. We have people like AWS helping us, Palo IT running a mobile app prototype sprint workshop for 2 days where you actually end up building an actual application in 2 days. We have a careers meetup if you're looking for a job, that's free. Rails Girls, Node School, the RedMart event is already sold out. The Product Hunt Golden Kitty Awards are going to be given out in that time with like special editions of some favorite meetups here in Singapore, like Talk CSS, WordPress meetup. Melissa is doing another product thinking workshop. We have obviously the big conferences, CSS Conf and JS Conf, with cool parties afterwards, like the Code in the Dark and the DevFest Asia Talk.js special edition. Loads of stuff, hardware workshops with Tessel, our 5-year anniversary party, and this party you should attend too, actually. You can just join as well, get a drink. It's going to be at the the Great Escape at the Golden Mile Tower. Web Audio Hack Day.
Which, by the way, is sponsored by BandLab, one of our sponsors.
Right, yeah, you can see BandLab as a partner here as well. Yay, BandLab. That's going to be a cool one. Chima is organizing that one. So this is the community organized festival, and I organized 2 of those events, which kind of started it, and you might have seen that one. This is CSS Conf, and we're going to have some, I think, phenomenal people over this year. Go check it out with Rachel Andrews, Sarah Drasner, Leah Veru, Soledad from Mozilla. It's pretty high profile this year, so you can expect a lot of good content here for that. And then the other one is JS Conf, which you might have heard about. 2 days, and this is going to be mad. We're taking over the entire Capital Piazza Mall, essentially, for this whole thing, with a theater inside. We have live performances, and it's kind of cool if people explain beforehand what they're going to do before they perform something live, because it's all JavaScript powered. A lot of machine learning. We're going to have brainwave reading with JavaScript. We're going to have people from Microsoft, actually, and PayPal as well that are contributing, telling us about the developer tools that are coming into Edge. Loads of good stuff. Please check out the website. Tickets are still there, and if you need reasons for your company to actually pay for your ticket, I'm super happy to give you group discount codes. And there's going to be a discount code GeekCamp that I'm going to create right after this, which you can also use for 20% off the tickets. So forward that to everybody. And additionally, I hear there's a BandLab competition going on with pictures and your hashtagging, and then you can win some of these amazing headsets. And I really want to join in. I'm super happy to give away like a combi ticket for CSSConf and JSConf to people that tweet with the hashtag DevFest Asia, take cool pictures, geeky stuff. You can combine this, just BandLab and DevFest Asia. They're contributing to DevFest Asia too, so I don't think they mind. And we're going to look through this and see over the next week who does the coolest tweet with the hashtag DevFest Asia, and I'll contact you on Twitter and you can get a free ticket. It's worth, by now, almost $1,100, so it's definitely worth it. That's about it. Please check it all out. We have DevFest stickers here and at the counter, and I would love to see you contributing or attending any of those events. Thanks. How are you doing?
And
Very well.
next we have Jos talking about GraphQL. If you've not heard of GraphQL, well, the QL tells you what it is. It's a query language that uses graphs. Unsurprising, I know. I'm going to let him tell you more because all I can do about this is reading Jos.
Thank you.
You couldn't tell. I know, it was such a dry program.
Hello. Okay, hi everyone, I'm Jos. I work at PayPal, and today I'd like to share with you GraphQL, which is a new way to build and expose web APIs. So you can follow along. The slides are available at this URL. I'll just keep it there for a few seconds so you can write it down if you'd like. Okay, so just to get this over with, I work at PayPal, but this is from my own personal experimentation and nothing to do with, it's just personal stuff. So I'll walk you through a bit of background about where web APIs are at the moment, followed by REST, which is how we're currently building web APIs. We'll then get into GraphQL and some code of an actual GraphQL service written in Node, and that's it. So this is the key idea of my talk. If nothing else, this is it, that an API is a user interface for developers. So we should put some effort into making it pleasant, that the user experience of an API matters. So a bit of background. So today, web APIs are eating the world. So there's a service for every imaginable need: payments, video encoding, file storage, analytics, transactional email. Most likely, if you're building a web app today, you'll be using one of these services. And so APIs are pretty important. But for some of you, you might be wondering, hey, but I'm not building an API, so why should I care? So how many of you use Slack at work or personally? A lot of people use Slack. So I think part of the reason we use Slack is because of the massive selection of integrations available. We could, for example, notify a channel when a PR is built, PR is opened, or when a CI job completes, or when a deploy is successful. And how was Slack able to do this? Each integration wasn't built by Slack's developers, but rather by third-party developers that found it very easy to integrate with Slack's API. So I think we can attribute part of Slack's success to the fact that their API has a great user experience, and that generates immense value for Slack and the users. So web APIs are pretty important. The user experience matters. So next, we're going to REST, which is how we're currently building web APIs. So the key idea of REST is we separate our API to different logical resources. So for example, if you have a blogging platform, you would have things like users, posts, users, and comments, for example. And then we map CRUD actions, create, read, update, delete, to a combination of HTTP methods such as get and post, and URIs. So for example, to retrieve a list of posts, we make an HTTP GET request to the post namespace, and so on, for each CRUD action. So for the rest of this talk, let's imagine that we're building a Hacker News or Reddit clone. And so we have a list of posts and links, which are essentially links to interesting stuff. So what resources do we need? First would be posts, and others could be users and comments. So this example will be revisiting throughout this talk. And this could be a possible data model for such an app. We have 3 tables with some fields, and we expose some endpoints to allow our API consumers to interact with the underlying data model. Yeah. So that's it. Wow, we're done with our REST API. So we can rest easy, right? Well, let's try using our API. So again, this is what we're trying to build, what we're trying to render. So first, we have to make an API call to get a list of posts. So we get to the post namespace, and we get a JSON response, which is an array of JSON objects. But we're still missing the author's username here. So we have to make a separate API call to get the user's name. But we have to do this for every single post. So the problem is we have to make multiple round trips. Each API call is a separate request response cycle. And especially on mobile, where we have variable network conditions, it might be undesirable. So one solution is we auto-load. We allow the clients to specify that, hey, I also want to load this other resource alongside my post. But this solution seems more of a hack because, again, one is that we are polluting the endpoint, the post endpoint, by specifying, hey, there's this other resource I want to pull alongside the post. Another problem with REST APIs is we often overfetch. So a lot of APIs, usually you get a massive JSON object that is returned, even though we might only be using, say, a couple of fields. So, and another solution is, again, clients should maybe be able to specify only the fields that they need. But again, the query string, not as clean a solution, I think. And so one solution is we create a custom endpoint for each client in each version, which returns exactly the fields they need. So they don't have to manually specify fields in their query strings. But the problem with this is you end up with a massive amount of endpoints that are very tightly coupled to the clients. And this is also not desirable. And a final challenge with APIs is documentation. It's pretty important. Imagine integrating with a third-party API with no documentation. If you're lucky, maybe they have some hate OS links that you can discover the API, but it's a nightmare. So who needs to learn about our API? So if you have an API product, this would be your users, your API consumers. If you're looking in like a microservices setting, it will be developers from other teams that needs to consume your service. Or it could be new hires who needs to get on board very quickly and start getting productive. And the documentation must cover things like what resources does the API manage? What can I do with the API? And for each endpoint, what parameters does it accept? And is it a string? Is it an integer? So these things have to be documented and accessible to your API consumers. And currently, the solution to this is something called an API specification language. So how many of you have heard of Swagger? Right. So Swagger is essentially, and others are essentially a DSL to describe your API. So for example, my API has this endpoint, and it returns a string, for example. Or it takes a parameter, and it's an ID, for example. And the benefit of using API spec languages to describe your API is that you can auto-generate a lot of these things. Because as a single source of truth, your documentation can be sure to match the underlying implementation. So you can auto-generate documentation, server stubs, and client code, and many others. So it saves you a lot of effort. So to summarize very quickly, these are the drawbacks of REST that GraphQL tries to solve. First is multiple round trips. You need multiple REST calls to get the data that you need. Then you have custom endpoints, because the problem is because APIs are rigid by default. You can't change the response that you get without changing the backend code. And finally, documentation is a challenge. So next, we'll look at GraphQL, which is the most exciting part, I think. So GraphQL. So GraphQL is actually more than one thing. First of all, it's a query language for the clients to describe the shape of the data that they need to pull from the server. That's the first thing. The second thing is a type system for both the client and the server to have a shared vocabulary of what the objects they are discussing. And finally, it's a runtime for the server to translate the queries from the clients into a JSON response, for example. So it was devised by the Facebook product team to solve some of the problems that we've seen in the previous section. It's data store independent. It doesn't make any assumptions about database or data store that you're using. You could use SQL, NoSQL, or even another REST API. It's language and platform independent. Bindings are available in most major languages and frameworks. So you can definitely use GraphQL for your stack. So the name of graph in GraphQL has actually nothing to do with graph databases. It's actually from the fact that we can technically model our business domains as a graph. So from this diagram, so this is like a library system. You can imagine it's like a library system. We have books and authors. So if you look at the top book node, the one with the dashed circle, a book has a title. So it has an edge to the economics of inequality. And it has authors. So the edges here refer to the relationships between the objects in your business domain. And GraphQL lets you extract trees from this graph of relationships. So for example, one possible tree might be starting from the top book node. We traverse the graph, we follow the outgoing arrows, and until we can't anymore. So that's one tree. So formally, a tree is a directed acyclic graph with only one parent per node. So this is the key idea of graph in GraphQL. So this is an actual GraphQL query. So on the left is a GraphQL query. And on the right is the response that a GraphQL service returns. So if you look at this, you can sort of tell just from the shape of the GraphQL query what the response would look like. So this is what they mean when they say GraphQL is declarative. So the key idea here is that we give power to the client instead of the server. The client can choose to specify only the data that it needs, and the server will do what's necessary and optimize on the server side to return the data. Right? So the client is no longer beholden to what the server returns. And GraphQL server is just like a REST server or an RPC server. It accepts GraphQL queries from clients and returns a JSON payload. And behind the scenes, the GraphQL service can be talking to multiple data sources, and it's completely abstracted away from the clients. So again, it occupies the same space as REST and RPC. It's a view for your underlying business domain. So here's a quick example. You can go to this URL if you'd like to follow along. Actually, I have it open here. So this is a GraphQL IDE. This is called Graphical. It's essentially it's like a Postman or a web IDE for GraphQL servers. So on the left here, we enter our query, GraphQL queries. So for example, let's say we want to return posts. And when you press this, Graphical will just fix some solvable issues on their own. So here, we're retrieving posts, the IDs of all our posts. Let's say we want to pull a different attribute. You can check the documentation and see what this root returns. So posts returns an array of type post. So let's look at what posts can return. So post has these following fields. So we can just, so it has autocomplete as well. And let's try pulling the author as well. So the author is a type user. And let's see what the user returns. And let's get the name. And that's it. So we extract the complex graph of relationships of our business domain in a single API call. So that's pretty cool. And one other thing is, nice thing about GraphQL is, because the schema is saved on both the server and the client can perform client-side validation. So for example, name is an invalid field here for the type post. And the client can know, even before we send this request to the server, that if a query is valid or not. Okay. So that's graphical. So wow, the first time I saw this, I was like, oh shit, this is the thing. Wow. And when you compare the user experience of the graphical to pouring through pages and pages of API documentation, it's clear that GraphQL has a better user experience. And when you think about it, having a great API documentation is actually a good marketing tool. It drives adoption, especially if your product is an API. And how is this possible? The type system that underlies GraphQL makes this possible. So if you use RPC frameworks, this might seem familiar, or if you use Swagger, this might seem familiar. Or protocol buffers, this also might seem familiar. So the schema language lets you describe the objects of your domain. So for example, in a blogging platform, you have a post object with the fields title, author, and comments. And each field has a type. For example, this could be a scalar type, just string, or it could be another custom type, such as user and comment. So the exclamation points just means it's non-null. And we also have to define the roots, possible roots of our tree. Usually it's called the query type or root type. Yeah, I won't spend too much time here. And it's a full type system. You have scalar types, you have more advanced versions like enums, lists, interfaces, tag unions, sum types, and so on. So you can describe your business domain very accurately. So how does GraphQL solve the drawbacks of REST, as we've seen in the previous section? First, it's a single round trip. You don't have to make multiple REST calls to get all the graph of relationships. It's client specified. You don't need custom endpoints because the clients can just tell you exactly what they need and you just give it to them. And it's so introspective. Because by annotating your business domain, you get a lot of stuff for free, such as the graphical playground, client-side validation, and documentation. Yep, so that's GraphQL. So now, to make it more concrete, let's look at an actual GraphQL server written in Node. So to create a graphical server, you need two things. You need a schema, which is essentially a description of your business domain, the objects in your application, and resolver functions, which tell GraphQL where to pull the data from. And for this example, we'll be using Node and Express. But again, bindings are available in all major languages. So you're free to use whichever you would like. So this is visible, right? Okay. So we'll be looking at 3 files: package.json, server, schema. So package.json is like a Ruby gem file, a Python requirements.txt, or a Java pom.xml. It lists out the dependencies of your application. So this is our dependencies. And these are the GraphQL libraries that we are using for our GraphQL service. And then we have server. Essentially, first we are importing the GraphQL library, point to our schema, which we'll be covering next. This is nothing. And then we use the GraphQL middleware to enable our route/GraphQL to interpret GraphQL queries from the client using our given schema. So essentially, one interesting thing is that in GraphQL, there's only a single endpoint. It's the /GraphQL endpoint. Oops. And then we start the server. So this is the actual schema. First, we import the types that we'll be using in our schema, such as lists. An object type is just for custom types, strings, integers, floats, and so on. We then point to our data source. So this is just this could be your ORM or your database, just a light wrapper over your data source. And this is the actual schema of your object. So we'll take a look at this very slowly, so we can understand it fully. So first, we define some metadata. For example, what's the name of our type? And object type here just means it's a type with some fields that might be of other types. And so for each type, we define the fields that it has, for example, ID. And for each field, we define its type. For example, an ID is an integer, title is a string, URL is a string, and so on. And then for associations, to links to other nodes, essentially, if you remember the graph diagram, outgoing nodes to other non-leaf nodes needs a resolve function, which tells GraphQL where to get the data from. So for example, this author here is of type user, and the resolve is a function which accepts the source node, for example, that means like the post node, and uses that information to retrieve the next node, in this case, the user. Anyone, any questions at this point? Okay. And then next, we have to define the roots, the possible roots of our tree. And this is often called the query type. So for example, so the query type defines the valid starting points of our queries. And so post, we've seen in the graphical demo. So post is a possible root of our tree, and as type list, a list of posts. It returns a list of type post. You can also specify arguments, which lets us specify acceptable arguments for a particular node. So for example, I didn't actually show you, but you can specify arguments along with your query. And then you can make use of these arguments in your resolve function, which again lets the GraphQL know where to get your data from. And finally, we return the schema, and that's it. Okay, well, thank you. So we've seen this GraphQL. And so the thing about resolver functions is I mentioned that GraphQL is data store independent. in your resolve function, you can technically do anything as long as it returns the data that you need. You could make another, you could call another API, you could do some SQL, raw SQL queries, or you could use some ORM. Yep. So that's pretty much it. In closing, give GraphQL a try. I think it's pretty interesting, especially if your product is an API, or if you have many clients with flexible requirements. I deliberately didn't cover many features of the GraphQL because these are mostly syntax sugar, but the core idea is the same. And because GraphQL is still pretty new, best practices are still emerging. So yeah, we'll see how GraphQL comes along. And so just a bit of a plug. If you're interested in all things like APIs, like API design, API development processes, and new technologies like GraphQL, do check out this meetup group, API Craft Singapore. I think you'll be interested in something like this. And thanks. Yep.
You mentioned all about reading. Can you do writes?
Yes. So in GraphQL, it's called mutations. I didn't really cover it because it's actually more of the same. Yes, it's possible. So what you do is, actually I have an example here. So I can quickly demo some writes. So in GraphQL, it's called mutations. And it's something like RPC. For example, let me just show you. So you just do this, and you specify all the arguments to return either a success response or the object or whatever you wish. Yeah? This is pretty much the same. Okay. Yep. Any other questions?
All right, if there are no other questions, thank you, Jos.
Thank you.
All right, very good. You're up next.
Oh, okay. An hour should be enough?
I mean, unless you want to talk for an hour and a half, but yeah.
I'll try not to. I'll try not to. That's all right. Oops. Darn it.
Obviously, we want to sit around and read all your stuff.
Yes. Sorry, when I speak of you, doesn't actually display it. Darn it. Okay. Sorry. Technical difficulties. Sorry, just a minute. I have lost my slides. Just a minute, yeah. Oh, wait, okay.
Makes you wonder if this is why native apps exist.
This is a live view, right?
Looks like it. Start presentation.
Okay, great. Now that we've got the hello. Okay. Now that we've gotten the technical issues out of the way, Hi, today I'd like to talk about Kubernetes for small organizations. And in case you're wondering, this is not a technical talk. This is more talk of our experience with Kubernetes. Quick show of hands if you guys all know what Kubernetes is. Somewhat a majority. I'll do a very brief overview in just a minute. But first, a quick introduction. My name is Raymond, and I work with Lomotif. You guys may have heard, Lomotif is a social media app that allows people to very easily stitch together music videos. So if you've got a bunch of videos, together with your friends, holiday, road trip, thank you. You can use Lomotif, stitch them all into music video, apply a soundtrack, share that to your favorite social media. Very brief introduction of what we do. So the question that we're trying to answer today is Kubernetes, is it worth it? So briefly, Kubernetes is this thing that allows you to manage your infrastructure. As you know, in this day of microservices and distributed services, you have all sorts of different servers spinning up all over the place, right? And how do you effectively manage them in a way that essentially keeps you sane and doesn't drive you mad? And Kubernetes is one of these frameworks that allows you to do just this, right? I asked Angad, a good friend of mine. Some of you may know him. But it was worth it. For those who don't know, Angad was SRE at Twitter. He worked with DevOps at Viki locally, and now he's back at Twitter again. So he knows his stuff, I assume. And with all this experience at hand, his advice was no. Right? So we are a very small company. We are 7 people, 4 of which are engineering. So given that, this is Angad's professional advice. I'm just kidding. He just said no. Right, but let's take a look at the motivations that started me on this route of investigating Kubernetes. Why did I go down this way in the first place? You know how, if you guys maintain servers, right, you have production server, dev server, staging server, personal dev boxes, and so on. And sooner or later, you will run across this message. 77 packages to be updated, restart required. So my dev box is fine, or my staging box is fine, yeah. But what if it's production, right? This gets really annoying in production. How am I going to reboot a production server if my service is running on it? I can't take my service down. So you can say, yes, you should build for redundancy, have distributed services, do a stage rollout, but the problem is we have these things. We're a very small company. Let me remind you again. We have 4 engineers, but we have 1 main API. We have 3 secondary services. We have a CI/CD setup. We have a chatbot and all sorts of other little scripts, maintenance scripts that need to be run at one point or the other. By the way, our chatbot is called Lobot. It says hi. Right? We have all these things, but there's one backend guy, and that's me. Right? And this gets really, really tiring if I had to go in to every single server, slowly reboot, move my service off, update the packages, reboot, move the service back, and do that for every single server we had. So then it gets really annoying. If you guys have any servers, you know what I mean. This gets depressing. Right, so in the end, as all engineers realize, eventually laziness wins. What's the most amount of impact I can achieve in the least amount of work? Right, so as I looked around, and Kubernetes seemed like a very promising solution because it does a lot of stuff for you. Right? So let's take a very brief look at what Kubernetes does for you. So basic concepts of Kubernetes, we have services, deployments, and pods. Right? Each pod is a set of servers. It could be application server, it could be a DB. Basically, it's a small set of functionality. You take this functionality like your API, for example, and you duplicate that multiple times, and that becomes a deployment. So you can say, a deployment of my music API, I would like to scale it to 2 pods, or 3 pods, or 5 pods. Right? So the deployment is what manages the scaling of your pods, and that makes it very easy. Then you have services on top of that that map logical functions to the actual servers, application servers that are running. For example, my service would be the music API service, and this maps a I could have it map a public IP and have it load balance across my family of pods that are managed by my music API deployment, for example. So very brief overview, but you get this with Kubernetes out of the box. So as an admin managing my API, this is great. I don't have to worry about individually deploying Docker containers, for example, to 1 server, 2 servers. Oh, if load increases, I need to spin up more servers. That gets old really fast. And if you take a look at it, Kubernetes gives this to you out of the box, so it's a great win for me. So we decided to experiment with Kubernetes. We've been experimenting with it since July this year, thereabouts. We've got a couple of services migrated, a couple of the supporting services, not quite a main API quite as yet. Hopefully we'll bring production here meets main API across at some point into Kubernetes. We're currently deployed only on AWS, but hopefully we'll be able to bridge across Azure as well. So that at least we have that kind of balance in our deployment. So the whole point of this talk is to share the experience that we've had dealing with Kubernetes, setting it up, and deploying it. And in case any of you were considering deploying Kubernetes yourself, let our failures and let our success kind of help you avoid those things. Well, let's take a look. What are the good things about Kubernetes? I'm sure you've heard a lot about it. You read Hacker News, you read all the tech blogs. Everybody's talking about Kubernetes and other orchestration frameworks. So a lot of good points, of course. So what I found personally is the community is very, very active, right? It's one of the fastest growing projects, I think, on GitHub. You can see that, you have 36,000 over commits by over 1,000 contributors. It has huge year-on-year growth. These are all stats done by OpenHub. I think you can follow the link below. But what this means is the community is very, very active. So new things are coming in all the time. You have lots of blog posts, you have GitHub issues, you have all sorts of people who are willing to help, and that's a great thing. So if you were looking for an active project, this is really one of the most active that are out there. So large active community, open process. There's a lot of discussion for Kubernetes is discussed on the GitHub page. So thousands and thousands of issues on the GitHub page. The thought processes are all laid out there. So it's very open to understand the rationale behind certain decisions. There's documentation with so many volunteers, of course. You have a nice set of documentation, only that it exists sometimes, right? So it's there, but making use of it, we'll see how that goes. So the other good thing about Kubernetes, I would actually say stability. Initially, I wanted to say stability, but I realized the word I was looking for is perhaps resilience. And why resilience, right? As IT people, I'm sure we've all faced this, right? The quickest way of making any IT system work is turning it off and turning it on again. And surprisingly, this is what Kubernetes gives you, all right? Because it's a managed framework, you tell it, OK, I want these services. I want these pods. I want these number of pods to be spun up at any one time. And Kubernetes is constantly watching your architecture to make sure that it satisfies its requirements. And the great thing is, if something it fails, like if I have a node that fails, right? So just before I go there, so Kubernetes sits on top of all your VMs. So let's say I have 10 VMs. What Kubernetes is going to do is treat this as a huge resource pool, and then it will take a look at my service description and say, OK, this pod needs, for example, half a CPU and 2 gigs of RAM. And it will look across my entire resource pool and say, oh, this node has that amount of resources. I'm going to put this container or pod here, right? If I have another service that has different requirements, it will look around my resource pool. Oh, I have space here. Let me put this here, right? So it abstracts individual machines into a huge resource pool. So keep this in mind. What happens when one of these nodes in this resource pool malfunctions? Let's say the Docker daemon fails, network goes down, something goes wrong. You literally turn it off and let Kubernetes turn it on again. I am not kidding. I've done this, right? Docker daemon in a node went down, couldn't contact it. Kubernetes told me the node was down. No way to go in. I couldn't shell in. I couldn't reboot the machine through the shell. I went to the AWS console. I terminated the node. This is not Kubernetes. This is AWS's auto-scaling groups. It brought that back up again. The nice part was Kubernetes recognized this, injected itself into the node, spun up my containers onto that node. Brilliant. Didn't have to do a single thing beyond clicking terminate. And this goes beyond the node level. I can do this at the pod level as well. If my individual pods on a single node, they're malfunctioning, delete pod, right? They come back, right? They come right back up. So it saves a lot of time when it comes to managing your deployment, right? And for a single admin like myself, I don't have to go in and debug. My first course of action in any case these days, turn it off and turn it back on again. I am not kidding. Right? So essentially, the benefit I'm getting here is that out of all the previous slides, is Kubernetes provides us with very well-established patterns to do certain things. If I wanted to spin up a new service, documentation, that's a template for that. If I wanted to spin up a new set of pods, for example, there's documentation for that. How do I put a new service onto my Kubernetes cluster? There's documentation for that. And as a small team, when I need to hire, my consideration is how do I onboard someone very quickly? And so the conclusion in this case for me was, why do I need to invent my own deployment process? Why do I need to go document the process and then be responsible for teaching any new guy who comes aboard? I can just say literally go RTFM and then come and deploy the stuff as we need to, right? So it's really about maximizing the efficiencies for a very small company in this case. I found that this does work for us. Of course, there are bad points as well. So we talked about documentation, right? Sometimes it's there, sometimes it's not. The worst case where it's there, so in this case, so the scenario is I need to hook up Lobot, our chatbot, to our Kubernetes API. I would like to manage that through our chat ops system. I would like to say Kubernetes, I would like to say Lobot, give me this, do that, and I would like to have Lobot manage my Kubernetes cluster for me. So I was reading up on the Kubernetes REST API, and I came across this field that was part of the REST API documentation. And it says field selector, you can select nodes by field. So of course, the first thing, when you're investigating an API is to say, okay, what does this field do? What are the behaviors? What can I do with it? And after an afternoon of experimentation, I find this. In case you can't, in case you can't see, this GitHub comment by Kubernetes member says, what would you like to use field selector for? The lack of documentation is intentional. Pending implementation of ticket 1362, which is cool, right? But I've wasted an entire afternoon trying to figure out why it doesn't work when, it just doesn't work. I would have liked to be told up front. And if you take a look at issue 1362 on GitHub, if you can see the timestamp up there on the date, that's 19 September 2014, 2 years back. It is still open. So I'm not dissing the contributors. I'm sure they're doing very good work. They're doing the best they can. But with any open source project, there are gaps in how that is delivered and executed. So if you're ever considering implementing Kubernetes on your own, these are the things that you probably want to be aware of, right? These things have been open from 2014. You may waste an afternoon, but that's on par for the course for an open source project. Thank you. So other things inside the documentation, right? So for example, we have these things called pet sets. Pet sets are nodes that have a more defined identity. In Kubernetes, your standard pod is treated as ephemeral. It may come and go at any one point in time, so long as your desired number of pods are still available. Pet sets tend to have a fixed identity. For example, Web API 1, part of a pet set should always be Web API 1. It can be addressed by DNS and so on. As part of the pet set documentation, they say you need to have this field in your service description, otherwise they won't spin up properly. If you wanted 3, it will stop at 1, waiting for you to set this flag. So before it continues spinning up to 3. Yeah, sorry, it's a bit small, but if you can see a little red underline there, it says in the documentation, wait for one pod to come up, and then flip the switch, edit the pod through Kubernetes, and flip this flag to true, and it will continue spinning up the rest of the pod. Sounds great, right? Then if you look lower down the page, they say, unfortunately, the only field that can be updated for pet sets is not that field. It's a field determining how many replicas they are. So even things like this, when they have the documentation that, and they do tell you up front of the certain pitfalls or the certain workarounds that you have to perform, the system itself does not support actually updating the pet set, right? So these are a couple of things that we've come across. These are actually fairly minor issues when it comes to the grander scheme of things. If you think about it, documentation issues, with sufficient Googling and GitHub searching, you eventually get there. But do be prepared that you may spend an afternoon or so, hunting down the causes for these issues. Right, so the documentation really needs to be taken with a little bit of pinch of salt, lots of Stack Overflowing, lots of GitHubbing, and you want to be able to figure out all these cases before you feel you're ready for production. Right, so another thing we found about Kubernetes is about persistence. So having a huge resource pool, having my server spin up and down, scale up to 5, scale down to 3, that sounds really good. If I don't need to maintain state, if my pods don't need to remember where they were before, who they were before, what they used to deal with, that's great. 5, 10, 15, 20, down to 1, that's brilliant. But dealing with databases is a different thing altogether. You really don't want your database to be ephemeral, right? So this was, in the beginning, this was my diagram when I first started dealing with Kubernetes. I was thinking of all the great things I could do with it. So what I have is a Greylock cluster, an Elasticsearch cluster, a Postgres cluster, a Redis cluster, and I thought, okay, each of these things will be individually scalable via Kubernetes, and I'll just layer services on top of it. I have a huge collection layer, and they will route individually to my various persistent services until I realized that persistent stores really like being stable. So the reason why I crossed out the word stability in my earlier slide and put in resilience is that resilience, it's very resilient to damage. I can take down a node, it'll spin back up. But stability probably implies something different. Like if I wanted my pods to be stable, not only do I want DNS to be stable, Music API 1, for example, I would also like the IP to be stable as well. And the problem, or at least the feature of Kubernetes is if a pod dies and your controller brings them back up, chances are they will come back with a different IP, right? So if it were an ephemeral service, Music API, 5, 10, 15, 20 pods, it really doesn't matter. Your service would load balance across the set of them. But if you're dealing with a persistence cluster, if you're doing sharded Postgres, for example, or if you have a Reddit cluster, the controllers really don't like a pod disappearing from the cluster and coming back up under a different IP, right? My experience has been with Redis Sentinels and Memcache, and they go crazy when the pods go missing. Right? If you guys have dealt with Sentinels before, they never forget a slave, right? So when your pods are coming up and down, your Sentinel remembers what these pods were addressed at. And if by some chance you had some other pod come up at the exact IP that the Sentinel recognized, my Sentinel will now try and co-opt that guy who just came up. And he may belong to a completely different Redis cluster, right? So that is a problem. Same thing goes with things like Memcache farms, right? You shard your Memcache across multiple servers. One of the pods goes down, right? Then your sharding fails, you have a block of your results that no longer are being served from cache, right? So this may be very specific to maybe Redis or to Memcache, but it is a characteristic of how Kubernetes functions. So if you're ever deploying persistence into Kubernetes, this is something you probably want to keep in mind as well. So you can see just on my feed service, the Redis, I have 3 in the pet set. So you recognize pet sets by the fixed numbers at the end of the name. And you can see these Redis servers have restarted 725 times. Right? Sentinels really don't like this. Yeah. So once again, in a Kubernetes pet set, you do have stable DNS identities. You can always identify a pod by feed Redis 1, feed Redis 2. That's great. kubedns, which is the internal DNS system, they will resolve to the right pod for you. But there's no guarantee that will always be the same pod. There's no guarantee that it will always resolve to the same IP. Right? And this gets tricky. For example, like certain Memcache implementations want you to address your nodes via IP, for example. So let's say you set your farm, your Memcache farm, one dies, now your configuration is invalid. You have to manually come back, reset to the new set of IPs, right? So these are a couple of things that we've come across in our implementation that, again, you probably want to be aware of at some point. We could probably change this around, maybe to avoid having a set of IPs, maybe put it behind twin proxy or something. But again, for a small team, you probably want the most direct, fastest route to get there. And this is what we have so far. The ugly, right? So it's not really bad. There's some points about Kubernetes that really make you want to, either slap someone or go bang your head against the wall, because these are really crazy. So let's see if let's see if you guys have seen this, right? I get phantom pods, right? So Kubernetes is really great at bringing up pods, bringing down pods. Sometimes they bring down pods and then leave them behind and they don't tell you about it, right? So I ran into this issue where I was looking, this particular IP, this particular pod IP was being identified, I think, as a Redis sentinel somewhere. So he, as a sentinel, was trying to co-opt my various Redis nodes under 18.6. But when I looked through all my pods, I grabbed through all the pod IPs, I couldn't find it, right? So I had a phantom pod somewhere in my system. It was co-opting my Redis servers, and it was nowhere to be found. So how could I address it, right? So what I had to do was to shell into one pod, and then use that IP, get a Redis shell, and just kill it with fire, right? So how do these things happen? I'm not sure. It doesn't make sense that it should happen. But experience will show me it does. So be careful. This is really bad. I can't explain it either. So if I haven't had time to investigate, so if any of the people know, please tell me. I would love to know. Being a very fast-moving open source project as well, their tooling is always evolving. Features always evolving, documentation is always evolving, as we found out. Tooling is always evolving as well. When I first started implementing Kubernetes back in July, there are very few ways to officially spin up a Kubernetes cluster. So you could do it the manual way, spinning up individual nodes, installing the kube daemon on it. There were some scripts that some people had assembled. There was a script in the Kubernetes distribution. If you downloaded tarball, you would get a kubeup script. Oh, okay, seems very convenient that it comes with the distribution, right? Let's run kubeup. Right, so kubeup spins up a cluster. You set a few environment variables. It spins up a cluster, 3 nodes, 4 nodes in whichever AWS zone. Does it all for you. Brilliant. So my cluster was up and running until I started to try to integrate Lobot into Kubernetes. Right, and what I needed to do here was to establish TLS auth between my chat bot and my Kubernetes master API, my master node. Right? So we use TLS auth to ensure that my client, which is my chatbot, can verify the authenticity of my API server. Otherwise, it's just an SSL connection. I wouldn't know whether there's a man in the middle. That would be bad. So I would like auth to be, no, sorry. So I would like to first identify my master node, but I would like also my master node to identify my client. So that's how we know which user the client is authenticating as. So ideally what I would do is, one step back. Kubernetes uses a self-signed cert, self-signed SSL cert to protect communication between the master server, the kube control that lives on your personal machine, the master API, and then the minion nodes, right? So it uses a self-signed SSL cert to protect the communications. If I essentially wanted to create another client, another kube control, and this would authenticate to the API master. So therefore, I needed to provide credentials via TLS auth, or at least I wanted to. So in a scenario like this, having self-signed certs, I would need the certificate authority that was used to create the individual certs for the master and the minion nodes, and I would need to sign a cert for my client, right? So this is how my master node will say, okay, this client is valid, we can authenticate it, and I can allow his commands to come into the system. The problem is, and I didn't discover this until 3 months after I deployed the cluster, is the kubeup script does not keep your certificate authority's private key, right? So without the private key, I cannot sign any more new client certs. I have 0 ways of creating a new client to authenticate to my Kubernetes master, right? it's a great way to spin up a cluster, but little things like that really kind of throw you for a loop, because now I essentially have to recreate my entire cluster just so that I can get back my private key, or get a private key, and I can sign client certs for other clients that may want to authenticate to my API master. Right? Without this, I'm stuck, and at some point, I will have to schedule a recreation of the entire cluster just for that. So, yeah, very, very painful. Yeah, the good news is there are newer ways of spinning up a cluster now. Now with Kubernetes 1.4, here something called KOPS, Kubernetes Ops, KOPS, is now out, and that's the more recommended way of spinning up a cluster than kubeup.sh. So if you're ever spinning up a Kubernetes cluster, check out KOPS instead. Yeah, so this is me trying to find my private key. You know, when the blank command line comes back, it's very sad. Yeah. So was it worth it? The question we're all here to listen. This is what it's all about. Is it worth it? Angad said no. I said yes. Right? As a very, very small company, we need to move fast. We need to automate as much as possible. We need to be able to automate the process of information transfer as much as possible. If someone new joins the team, you cannot spend 2 weeks onboarding him or her with all our custom deployment scripts. And so on. We just need to point him at the Kubernetes documentation, read that, understand, look at the system, it's exactly the same, just apply. Right? So this really helps us be more efficient. If anything breaks, we don't have to rack our brains. Oh shit, what do I do? Sorry. What do I do? I have to struggle to remember what my shell script did. I can just hop onto Kubernetes Slack and ask them, hey, how do I do this? Or follow GitHub report. Your thing is broken, could you fix it for me? Right? So this provides you a level of support that you wouldn't otherwise get in a very homegrown custom solution. There are caveats, of course. Right? The learning curve is fairly steep. When I started deploying, I had to read the documentation for about 2 weeks before I got anywhere near spinning up a cluster. So just to get my head around all the new concepts that were being introduced, services, pods, deployments, replication controllers, services, endpoints, so many new words. It's a whole new field. So if you're a small team, make sure you dedicate time to reading up and understanding the whole concept of Kubernetes first. Persistence, also a problem. Persistence is very important to a lot of startups. Data is pretty important. So if you want to deploy Kubernetes, deploy your persistence into Kubernetes, you're going to have to experiment a little bit of it. There are problems with Memcache and Redis, as I've told you. But there may be other problems with other databases as well, so heads up. And of course, there are rough edges with tooling and documentation and so forth, right? That's it. It's a really good system. It really helps me feel that my cluster is a lot more resilient than it has ever been. I can just blow away a node, comes back right up, blow away a pod, comes back right up. It feels a lot more assured that my system will function the way it's meant to be and the way I wanted it to be. So yeah, if you're ever considering deploying your application into Kubernetes, bear in mind that these things, there are problems around. So just bear in mind when you're deploying to production. Because last but not least, right, so anyone wants to find out more, please come talk to me, find out more about architecture, about more about what we do, but we're looking for full-stack backend guys, so here if anyone's looking for a gig. Right, so that takes me to the end of the talk. Any questions?
One quick comment and one question. So comment is you can get hosted Kubernetes services, yes, for example, on Google Cloud. So for even smaller teams, that might be a good way to go.
Yeah.
Second question is for self-hosted. How about upgrading of Kubernetes itself?
That is a huge problem. I wish I knew.
Upgrading is a huge problem for Kubernetes. I've asked on the Kubernetes Slack many, many times. I've not gotten a decent answer. The closest answer I can come across is you shell in to each of the nodes individually, replace a line in the YAML file, restart the daemon. Right? That addresses your running nodes. That does not address the saved configuration in, for example, your auto-scaling group that AWS uses to spin up more nodes. Right? So I can upgrade the running ones, but if I have to scale my cluster, then I have to perform that on the rest of the new nodes that come up, because they will still be using the old configuration, unless I replace the saved configuration. But again, the documentation around that is very, very sparse. I wish I knew, sorry. Yeah. Anything else?
Can the master node fail, and if so, what else?
So the master node is, okay, so the question was, can the master node fail? The master node can fail, right? And the implication of that is that you lose connection to your minions. Your minions will continue running. The minions don't need your master to be alive to continue serving, but then you will lose the ability to control your minions. So, yeah.
Because I've seen architectures where if the master fails, then the minions will elect a new master.
Oh, yeah. Not quite, no. I don't think the Kubernetes does it this way. There's one very clear master. Yeah.
Where does the DNS live?
So kubedns lives in what we call the kube system namespace. So in Kubernetes, in a cluster, you can split your resources into multiple namespace, or production, dev, and so on. So these are just namespace ways of addressing your pods, not network isolation, by the way. So your DNS lives in a pod called kubedns, and that lives in the kube system namespace. So it doesn't appear by default if you do get pods, but you can specify the kube system namespace and you'll see the pod. One note about kubedns, if you scale up to a larger cluster, more nodes, you will want to spin up your kubedns replica set as well. So you will probably want one DNS pod to each physical node to be able to serve that. Otherwise, your kubedns service will get overloaded. Yeah.
I'm not sure, but how do you handle persistent storage on disk, for example, for your databases?
Okay, so not considering aside the whole IP issue, right? So, but Kubernetes provides you this thing called PVs, persistent volumes. And when you write your service descriptor, so it's a YAML file that says, oh, use this image, I want these resources, and so on, you can specify, oh, I want this PV, right? So you can do it two ways. You can create, for example, in AWS as an example, I can create my EBS volume first, and then I recognize it as a PV, mount that into my pod. Otherwise, I use pet sets, which do auto provisioning for you. Yeah, so
use the pet set, you get automatically the...
Yes, KVM pet sets are still in alpha in 1.4, so be careful with that. Yeah. Anything else? Cool. Yay.
The world is full of adapters. My life has been full of adapters for many, many days. Alright, once again, obligatory sponsor slide. We couldn't have done this event without these people. There is no way we could have been here without Microsoft, because we wouldn't be in Microsoft and we wouldn't have a venue. PayPal, thank you so much for the food sponsorship. You guys would have all gone hungry if not for them. And last but not least, thank you BandLab for the coffee. I would be obviously, and I wouldn't be awake and standing here right now. Also, thank you so much for the lovely headphones that, speaking of headphones, prizes. I hope that punk was ominous enough. Well, we're going to do this very simply. I will drag up a tweet on screen. I guess that gives it away that none of the Instagram photos won, I guess. But I will drag a tweet on screen. And if you are in this room, come up here and whip out your phone and prove that that Twitter account is yours. And you get a pair of headphones, courtesy of BandLab. If you're not in this room, which I guess you wouldn't know unless you're watching the live stream right now. Well, I'm sorry, the headphones are going to someone else then. Yeah, that's pretty much what's going to happen. All right, first one. I'm going to make that bigger so everyone can see it. A little bit of coffee script. Because coffee, I thought that pun was pretty good. Here you go.
Why do Java programmers wear glasses? Because they can't see sharp. And last one, last person about to get a pair of headphones. I'm sorry, this is just absolutely adorable.
Have to use their software.
All right, that was prizes. I know we're all tired and sleepy, possibly. Lots of new information entered your brain, lots of old information recycled in your brain, lots of stuff going on. Maybe it's time to retire for dinner and food and stuff, so bye. But before we leave, if you spoke at GeekCamp today, I'd like to meet you at the front. The rest of you, no, seriously, bye.